Hello! I'm very excited to start this course, but before we start everything, we need to figure out where we're starting and where we're ending up. We want to have a clear path of success. This course is going to start off with some React basics. This is especially useful for those who have never written a single line of React or for those that need a bit of a refresher. In this section, we're going to learn about why React exists. We're going to learn about the fundamental principles so that you can tell people this is why React has become popular. These are the benefits. These are the pros and cons. And we're also going to build a fun little project to get us comfortable with React. It's a big section, but it's going to be a lot of fun. By the end of this section, you're going to know React basics. I mean, that's what the section's called. But this is the fun part. Using the basics that we've learned in this section, we're going to right away start building our large e-commerce app. We're going to introduce topics like React Router and Firebase to have different pages on our app and also do user sign-ins. We're also going to start adding Redux into our application so that it's ready to scale. And then finally, we're also going to add payments using the Stripe API so that people can actually buy stuff from our store. And in this half of the course, we're going to have a fully fledged e-commerce app where we store user information. We use Redux to store state, React Router to move between pages, and Stripe to actually make online purchases. And don't worry, we're going to teach you these topics from scratch. And this is where most courses would stop. We'd have a nice app, you'd learn the React basics, and you'd feel comfortable working on a React project. But we take this a little bit further. After we've gotten the fundamentals and we've built the main components of our application, we introduce you to advanced topics like CSS-In-JS. We're going to convert our app to use a popular library called Styled-Components. And then we introduce Redux-Saga, a scalable way for us to handle asynchronous actions in our app. Then things get even more interesting. We actually start implementing hooks into our app and see how it compares with Redux. We also use Context API, again, comparing it how it's going to work with Redux and hooks. And finally, even add GraphQL to manage at an even larger scale our state. And by this point, we'd have done a lot in our application. But we take it a little bit further. We start implementing Firebase features in different ways, even creating a Stripe backend that you can use so that our app can actually process payments. We even talk about complex topics like design patterns, including observables or a higher order components pattern, and even touch on an important topic of performance, how we can scale our applications and make them performant. And finally, the last two bonus sections where we actually learn about progressive web apps and implement our app as a progressive web app. And then a nice section on testing where we use the Jest library to practice writing tests. As you can see, there's a lot in here. And this won't be easy, but we do promise you that we're going to make it fun along the way. And by the end of this course, this all is going to make sense. These are going to be the skills that you will acquire throughout the course. And by the end of it all, you would have had an app that implements all of these so that you can compare and contrast. Know when to use Redux, when to use Context API, when to use hooks or GraphQL. You're going to be able to make smart decisions with any React project. We're going to take you from zero to mastery. And along the way, we might throw in a little joke or two to make it fun. Whether you're new to React or you've taken a few React courses but you still don't feel confident in your skills, this course is for everybody. But the best part is this right here, our online community. We have over 40,000 developers chatting every day in our little community here, where we help each other out. We work through problems together. And we discuss the latest and greatest in the world of programming. And this is an optional resource for you to use so that you can have back and forth conversations with other students as well as myself and Ihua. But you know what? I can see you getting antsy and ready to start learning. So enough talk. Let's learn. Let's get started. I'll see you in the next one. Hey there, this is Andre. You're about to dive into the course. But here's the truth. Most people won't finish this course. Why? It's because doing a course from the comfort of your home is going to take something away that is one of the most critical parts of doing anything challenging and worthwhile. Accountability. It's a lot harder to stop going to elementary school than to stop watching an online course, right? But here's the thing. There is a way to guarantee right now that you will finish the course and you will get through the ZTM courses no matter how hard they get. And trust me, it's going to get hard because we want to teach you really valuable skills. And they are valuable because they're hard to acquire. And this is why you're here. If you don't finish the course, it's a waste of your money. But if you finish the course, we truly believe it will get you the skills that you want. So this is what you're going to do that might put you outside your comfort zone, but it will be extremely effective in increasing your chances of success. Ready for it? You're going to come join our online classroom. In the next lecture, I'll provide a private link only for ZTM students. In there are 3 things I will ask you to do. 1 is to introduce yourself to the community. You can share as little or as much as you want about yourself. I'm going to finish X course by this date. And put that date in your calendar too. Number 2, go to Accountability Buddy's channel. Oh, that's a mouthful. And find someone who is starting a ZTM course right now at the same time. It doesn't have to be the same course, and you can have multiple partners. You're going to make sure that you each finish the course and the goals you set out to do. Finally, number 3, hang out in the general chat and talk about anything that you want. You will also have course-specific channels that you can chat in. You want to be surrounded by other learners like you to stay motivated and being part of a class. Now in here, we're also going to have virtual hangout sessions with myself, other ZTM instructors, and students. I recommend having the Discord server open as you go through the course and as you are learning. Now, I'm not saying this to sell you something. This is simply a fact of learning. When you learn in a group, when you surround yourself with other learners, when you have accountability, you are more likely to succeed. It's a fact. Finally, throughout the course, as you encounter problems or challenges, don't give up. Come back to our Discord server and ask questions and get help. But most importantly, as you start to learn and grow your skills, come here and help out other students. Teaching and helping others is one of the best ways to retain the information you just learned. If you create this routine around your learning, opening up Discord, start watching the lessons, surround yourself with others that have similar goals to you, you will have the accountability and the support system to finish the course. I promise you. Oh, and another fun bit, when you finish the course, you post your certificate in the alumni channel to become an alumni. And then who knows, the people that really are stars of the community become star mentors. Ooh. Now, this all may sound silly. You may say that you don't need anybody. But trust me, we've been doing this for many years, and there is this consistent trend of those that finish the course, get hired, and find success in their careers. You have to do the things that are uncomfortable sometimes to succeed. So that's it. See you in the next lecture and see you in our community. Hey everybody, welcome to your ZTM course. Now, as part of being a ZTM student, you get to have a couple of nice freebies, a little bonus, a little extras that all the students that are part of ZTM get. Let me show you some of the extra things you get as part of this course. First off, we already talked about it, but we have a pretty big community of tech enthusiasts, learners. So we have a ton of coding challenges. If you go to our website and go to the community tab, we have coding challenges that you can practice some skills with. We have open source projects that are open to anybody, that anybody can participate that's part of ZTM. We have our Discord server. We have campus events, which is like a live virtual classroom that you get to meet other students and talk to them. And we also have events like Advent of Code or Hacktoberfest throughout the year. We also have cheat sheets. Now, these are all free. None of this requires any sign up. You can just open up a cheat sheet that is related to your course that you want to check out. Let's say we want to check out the JavaScript one. Well, you can actually go through the cheat sheet here and follow along with the course and maybe take notes along the way. These cheat sheets, we add every month a new cheat sheet. So you can just keep an eye on this tab and check out different cheat sheets based on your interests. We also have our blog where we post 2 to 3 blog posts a week, so quite a lot. And we have different topics for beginners, for people that are already working in the industry, different instructor posts. We also have posts about how to get hired, so on and so forth. So you can check out our blog, and we have different tabs here. Obviously, beginner, start here, advance your career. But the most important one is right here. We have monthly industry newsletters. So every month, myself and other ZTM instructors write a recap of what happened that month in the industry. You know how you're always overwhelmed with blog posts, what to read, how to stay up to date with the industry? Well, we try to make it easy for you so that you don't have to read 100 blog posts, watch 100 YouTube videos every month just to stay up to date. Instead, we recap what happened in the industry. So we have a web developer monthly that recaps what happened in the industry that month, what are the best resources to read, what is the big takeaway, all digested into one blog post like this one. But we also have one for Python, one for machine learning, and a blockchain developer. Now we're going to add a few more throughout the year, but these should cover a lot of the interests that students have. Now, finally, you can also check out our career paths. So this, if you're looking for a certain career, will give you advice on what path to follow, when to apply for jobs, what sort of skill levels are required for each of these careers. So again, this website you can use for free, doesn't require any sign up, and you can find different sort of information based on your needs. Now, 2 last things. One is that we have a LinkedIn group for all our students. So this is great if you want to have a LinkedIn profile and you want to endorse each other's skills, get advice, career advice from people. So there's lots of things happening in our group, and people are always sharing job openings, tips and advice on career, and also endorsing each other's skill. So if you want to boost your LinkedIn profile, this is a great place to start. And then finally, we also have a YouTube channel that we recently started, and we're posting about 3 to 4 videos a week, different topics that are free that you can kind of check out. And as you see, we already have a ton here. We're going to have a lot more coming up throughout the year, but you can check out our YouTube channel, Zero to Mastery, as well. All of these you get for free as being part of the ZTM student. So enjoy, good luck, use these resources to your advantage, and welcome to ZTM. Hello and welcome to the best React course online. Wow, that's a bit of a bold statement, and okay, I may be biased here, but I'm definitely looking forward to us diving into some fun topics and coming out the other end as great React developers. This course tries to build onto each topic and gets more and more advanced as you progress. Trust me, if you go through everything, you will come out the other end confident with React and be able to manage or even lead React projects at your company. Now, before we dive into coding, building projects, and learning about React, I want to take a moment and understand why React exists. What problem does it solve? Why it makes front-end development easier? And also, what principles we need to understand to be more than the average React developer. You see, a lot of times people learn a tool, a library, or a framework without understanding the core principles that make it great. By learning these things first, we'll have a foundation as we move through the course and understand what the best practices are. The goal of this course is not to be another React course like thousands of others already out there in existence. The goal is to make you a React developer that can think on your own, make good architectural decisions, and lead projects instead of only following tutorials. Therefore, in this section, let's dive into the important principles that will help us get through this course. If you are new to React, some of these principles may be hard to understand at first. Rest assured that we will keep revisiting them throughout the course as we learn. For those that have already worked with React, you may learn a thing or two, so hang in there. My goal by the end of this section is for you to be able to explain to other programmers the benefit of React without writing a single line of code. I do recommend that this section is something you come back to after you've watched through the entire course. Alright, enough talk. Let's get started. Now, React came out in 2013, but what do we have before then, before React? Well, the front-end landscape was very different. Initially, back in the 90s and early 2000s, we just had basic HTML, CSS, and JavaScript. HTML displayed the text on our web pages, CSS the styles, and JavaScript allows us to have some interactivity in a website. And initially, it just started with simple forms, where we send from the backend when we go to a URL all these files, and when a user, let's say, submits a form, we simply send that back to the server to store that information. Now, if a user clicked on, let's say, a link in the page, well, once again, we simply request the new HTML file and the new page from the server, and that gets sent to the front end. And that's how websites worked for many years. But there's a problem here. You see, all these websites were run on different browsers. And all these browsers were worked on by different group of developers. So each one of these browsers implemented, well, their browser differently. So what happened was, as we wanted to use more and more JavaScript in our web pages, we had to account for all these browsers that sometimes worked differently from each other. And we had to accommodate JavaScript to work with these different browsers. Now, eventually, we had jQuery come out, which allowed developers to easily interact with the DOM, or the document object model, across all these browsers. You see, back in the day, if we went to, let's say, Hacker News over here, clicked on Views, Developer, and then Developer Tools, and we went to Elements here, this is the DOM that, well, is our page. It displays exactly how our page should look like, and it's a tree-like structure. And JavaScript, all it does is modify this DOM. You can remove elements, you can update elements. And although there's now more similarities and compatibility across different browsers, back in the day, we didn't have that. So jQuery made developers happy because it had a unified, easy API that kind of looked like this. Instead of a developer trying to think about how to work with the DOM in each of the different browsers, jQuery said, hey, we'll take care of that complexity for you. Just, this is the syntax we'll use that works across all browsers, and you can manipulate the front end or the DOM however you want. So that was great. But with this power, developers started building bigger and bigger applications. Instead of just something small, we started getting these massive applications like Facebook, where you got to log in, look at the newsfeed, message friends. And as websites turned into these full applications that people can interact with, besides just requesting more and more pages like a blog, well, libraries like Backbone.js came out. Because, well, our JavaScript files started getting bigger and bigger and bigger. Libraries like Backbone.js allowed us to organize these JavaScript files. And because it became easier and easier to work with the DOM, we had the birth of a single page application. You see, traditionally, we just had HTML files for each page, and every time we moved to a different page, we would request from the server, well, the HTML file, the CSS file, and the JavaScript file, which usually contain jQuery, for each time we clicked on a link. But with more advancement, like we had with jQuery, Backbone, and something called Ajax, we now had a different system. What generally happened now is we focus less on HTML and a lot more on JavaScript. You only load the application code once. Instead of us making new requests to the server, where we returned a new document, instead now our applications acted more like a desktop application where we stay on the same page the entire time, and the JavaScript file simply changes or updates the HTML file or the DOM to display new things. So you were able to sign into an application and interact with that application without ever speaking to the server anymore. And this way of writing applications or single page applications became really, really popular. And in 2010, AngularJS, which was created by Google, really became the standard way of building applications this way. Now, unlike jQuery, Angular allowed developers to build these large applications by forming these containers that, wrapped your project. And because it was created by Google, it had a lot of power because people said, well, this is the way that we should build things. Everything's organized. We have these large JavaScript files, but we can organize them this way. You had code that now had better containers, where you had things like controllers, views, and models. And this idea of a model view controller, where each part of the application or each JavaScript file was divided into different things that it did. This idea of organizing our large code so they're easier to work with as teams get larger and larger really made AngularJS popular. But there was a problem. You see, things started getting more and more complex. Because of this, as things get bigger and bigger, more things have to happen. Users are clicking on this button, which changes this area, which in turn changes this area, which now has to display this information. We have more and more complexity now. And although frameworks like AngularJS came out, people started to notice it's getting harder and harder to find bugs in the code and understand how each part of the app was affecting the other. Meanwhile, Facebook developers were finding it hard as well on their end to maintain their app, especially their Facebook ads app. You see, the Facebook ads app got more and more features. More and more people were added to the team. Now, the growing number of lines of code, the growing number of people working on the app, their app became really, really difficult to handle. And each update would cause more and more issues where you had all these arrows relating to each other, pointing to each other. And after a while, the engineers of Facebook just couldn't keep up with the way that they had created this app. They needed to upgrade their code base. And this isn't just special in the front-end world. This is all over programming. It's why we need good architecture. We need to think about how we organize our code, how we manipulate data, and how that data flows through our programs. So Facebook came up with a solution. And that solution worked really, really well for them. That in 2013, they released React to the developer community at JSConf 2013. And their solution was really, really good. And it took off because React developed a whole new way to build front-end applications. Now, it also happened that in 2014, AngularJS realized that the way that they've architected their framework just didn't allow good applications to be built anymore. So they decided in 2014 that they were going to rewrite the entire library, call it Angular. But because they wanted to do an entire rewrite, a lot of people during that time moved to React. So combined with the fact that AngularJS was getting a complete new rewrite, Facebook was backing React. And the great principles that React introduced made it what it is today. That is, it became the most popular front-end tool with the most job demand across the world and being used by very large companies like Airbnb, Uber, Netflix, Twitter, Reddit, Pinterest, Wix, PayPal, Stripe, Tumblr, Walmart. However, what made React so great? What were these principles that made it jump from something that Facebook used to something that developers all over the world use? Let's find out in the next video. Now, the success of React comes down to 4 key things. And these React concepts are what we're going to go over in the next 4 videos. But in this one, let's talk about the first one. And the first one, React says, hey, don't touch the DOM, I'll do it. What do I mean by this? You see, many existing frameworks and libraries before React were directly manipulating this DOM on every page. First, let's just go over what a DOM is. If you remember, DOM is our document object model. It's what the browser uses to display, well, a website or a web app. And JavaScript is simply manipulating this DOM. That's all JavaScript is doing. For example, if I right-click over here and select Inspect, you'll see that here, if I click on Unvote, we'll get a little flash saying that, hey, JavaScript just updated this. If I click again, I get a little flash. The DOM is just the tree representation of the page. We start all the way up from the HTML tag, all the way down to the body through each individual element. And websites were built using things like this. All these ways that browsers allowed us to manipulate the DOM. They gave us the DOM API that we could access using something like inner HTML or get element by ID, get elements by tag name. This API allowed us to traverse the DOM, access any node we wanted to, maybe remove them, add new nodes. And before React, this is what libraries did. You either did this manually, or you used jQuery, or you used some sort of a library that allowed you to use this in a simple fashion. You see, this way of programming was called imperative. That is, in an imperative paradigm, you directly change individual parts of your app in response to various user events. So you had, let's say, your JavaScript file. You'd say, hey, if user is logged in, well, then go change that little icon over here to the user's profile. And now that the user is logged in, well, also show profile page. Okay, so JavaScript goes, changes the DOM, and updates the profile page. And then, okay, now that we're also logged in, we also need to display friends. Okay, let's do that as well. Modify the DOM. And all right, that's good. We're good. Oh, by the way, it's been 5 seconds and we need to display a chat over here. Okay, I'm going to go and do that. Now, this sounds intuitive, but the problem with this imperative approach is that it becomes difficult to see the relationships between events and all these edge cases. Remember this diagram over here where we had AngularJS that all of a sudden had all these relationships affecting each other and all these arrows pointing to different things? Well, instead of this imperative approach, React came up with a novel concept, a more declarative approach. And this is what React says to you. Hey, DOM manipulation is one of the biggest performance bottlenecks. It takes a long time for DOM changes to happen. The browser has to do 2 really intensive operations. One is to repaint, that is, change an element and add it onto a page. And then reflow, which is to recalculate the layout of the page and move things around if need be. So changing the DOM was a really expensive operation. So React says, hey, you know what? Let me take care of that. I'll find the best way for me to change the DOM and just declare to me what your app looks like. So all we need to do is say, hey, this is a JavaScript object of how I want the app to look. And React is going to hold this JavaScript object, this massive blueprint of how things should look. And based on this blueprint that we give it, well, React just says, hey, just tell me what the page should look like, and I'll take care of it. I'll do everything for you. I'll find the best way to use the DOM. You're never going to touch the DOM. Just tell me what the page should look like. This declarative paradigm is called that because we declare that, hey, this is what the state or data of our app should be like. And based on this state, well, then just make those changes. So if user is logged in, then React already knows exactly what to update and what to do. Now, this idea of a declarative style meant that we didn't have to directly say, do this, and if this happens, then do that, where we just say one by one exactly what should happen. Instead, we tell it, this is the state of our app. And React automatically just does it for us. The difference is that all the different states are accounted for in one place. That is one big JavaScript object that describes how our app should look. And this resulted in less complexity, better code quality, and faster developer times. So it created this whole idea of, hey, you can build web interfaces without touching the DOM. And this is where the name React came from. The name React is simply saying, hey, based on whatever the state or data of the app is that describes our app, I'm just going to react to it and change everything for you so that you get the display that you want. So we learned that React had this revolutionary idea of, let me handle the DOM updates. Because I know the best way to do them, the most efficient way. You don't have to do that. Just tell me what the page should look like. Next, big game changer was this idea of building websites like Lego blocks. React is designed around the concept of reusable components. Just like you see in this app, how each square or rectangle has different color. Well, these are all components. Each of these individual pieces create this whole app. React had this idea of small components that you put them together to form bigger components. So you had the profile picture component, you had the add component, and then you had the navigation bar component. And within here, you had components containing components. So you had a component in here that was surrounded by another component that was surrounded by an even bigger component, just like Lego blocks. And all these small components, whether they're large or big, can be used in different places. For example, I can have this component just copied over to multiple locations because, well, they're the same thing. And I can even move these over to different projects and reuse them. So people can build these components, like material UI components, that I could just copy and paste this code and add it to my projects, like so. You had different component libraries, like React Bootstrap again, or something like Blueprint. So people can now share these components across different websites, across different projects, and they will all work. Now, this idea of components in React, in a simple term, is just plain JavaScript functions that we write. So we have the state of our app, or that is any data that describes our app. For example, the user is logged in, whether it's true or false, and maybe friends. Then components are created based on that data, well, simply as functions. And don't worry, don't get intimidated by this. This is something that we'll cover throughout the course. But components are simply just JavaScript functions that receive some sort of input or attributes, which we call props. And in return, it returns this thing that kind of looks like HTML, but inside of JavaScript. And these components can be built like this as a function or even as a class. But the key here is that based on the state and these components that we build, we have an entire component that we can add to our page and reuse maybe over here as well if we wanted to. Just like Lego blocks. Now, here is a simple React to-do application. And I'm going to be using something called the React Developer Tools, which I recommend you install as well in the Chrome Web Store. You can add it to Google as an extension, and what it allows you is when you click View, Developer, Developer Tools, you'll now have the Elements tab, which shows you the DOM. of your app, which you can see over here, but also a new tab called React. And this React plugin actually allows you to see the components that we build into an application. Now, you can see over here that this isn't exactly HTML. We're creating custom tags like header or filtered list or footer that isn't valid HTML, but you'll see that inside here, all of these are actually, built by HTML elements like header, h1, or input. So again, this idea of a components architecture means that we can have some sort of data about our application, and we build these components ourselves. And these components are what we call React components that we built out of HTML tags that signify a component. And each of these components work together to eventually have our app. And this component architecture is really, really key in React because it allows us to reuse and share components between projects. So that if you wanted a date picker on your app, instead of maybe building it yourself, you can just Google for it and say React date picker component and just use somebody else's code. But there's two more key concepts to get to. So let's do that in the next video. So we've learned the first two concepts. The third concept that made React really popular is this idea of unidirectional data flow. What do I mean by that? Well, so far we understand that React is just a JavaScript library that allows us to write more JavaScript to have interactivity on our websites. And in React, we have this idea of state, which you can think of it as a JavaScript object that describes our app. So all the data of our app is within this state. And then we also learned about this idea of components that we can build using React with this weird HTML looking thing, but inside of our JavaScript files. This idea of state, which is the data of our app, works with the components, which are built using what we'll eventually learn is called JSX. So it's HTML-like syntax inside of JavaScript. And these all combine to essentially give our React library two things. That is the components that we've built, the state of our application, and you can think of this as a function. A React library is simply a function that we give all these things to. What it's going to do is it's going to create what we call a virtual DOM. That is, it creates a JavaScript version of the DOM. Remember, this isn't the DOM. We installed the React plugin to have something that looks like the Elements tab, but isn't exactly. And this is just a JavaScript object that describes our app into what we call this virtual DOM, which is a tree-like object like this that gives React a blueprint of how it should update the actual DOM. So what happens then is React takes all of this and says, hey, here is the actual DOM or the document object model of the website. And the React little bot over here is going to go look at the blueprint of what it needs to build and modifies the DOM for us. Now, this idea of a unidirectional data flow means that anytime we want something to change on our web page, the state has to change. That is, the data has to change in our app. So what happens if, as a user, I click on, let's say, a button? I click on a button. React is going to intercept that and say, hey, somebody just clicked on the bottom. How does that, let's say I click on the sign out button. React is going to say, hey, somebody just clicked on the sign out button. How are we going to change the state? Internally, we would say that if somebody clicks on the sign out button, we're going to change is logged in to now say false. And React, as soon as the state changes, reacts to that change and says, hey, the state just changed. Combine the new state and the components we have and update the DOM. You see, the data only flows one way. A better way to think about this is like this. Our application is simply built with this virtual DOM, this JavaScript object that describes our app. And as soon as a state changes, it's going to trickle down that information and let everybody know, hey, the state just changed. If is logged in is now false, display this version of the app. Data can never move up. So for example, the state, as we'll learn, can live in different locations, different components. And if the state, let's say, changes here, the data can never move up. That is, all these changes can only trickle down. Now, this concept is hard to explain without actually seeing it in code. So if you don't get this right away, don't worry. We will explore this idea and revisit this idea of one-way data flow throughout the course. But the key takeaway here is that by having this restriction of data only being able to move down from the state of our application all the way to the DOM, and if any changes or events happen that change the state, well, we go back to the state, and that state change trickles down to different components in one direction, is a restriction on how data can move through our app. And by adding this restriction, it's really easy to debug code. For example, if there's something wrong with our sign-out function, I can go to wherever the state is logged in lives. Let's say it lives in this top component here. I can go over here and know that this is where the bug is happening. And whatever's underneath this component, well, that's it. I don't have to look outside of the component, or if this tree was massive with thousands and millions of components. I only have to look in the place where the data exists and where the data flows through. Again, this is a really hard concept that we will explore throughout the course. But this idea of one-way data flow is the restriction. And because of this restriction, it's easier for us to understand how our app works. Unlike the arrows and points that we saw with an Angular app, where things got confusing really, really fast. So we've learned that React takes care of DOM changes for us using something called virtual DOM. We learned that we build the websites with components, and this idea of unidirectional data flow, where data only flows one way so that it's easier to debug our code. Then the final thing that really made React stand out is this idea of, hey, I'm just the UI. The rest is up to you. What do I mean by this? Well, remember how with Angular, it came with all these things built in? That is AngularJS. It was a framework, and a framework is kind of like a whole kitchen. It gives the developers all the tools necessary to build an application. So if you're a cook in a kitchen, well, you get the oven, you get the knives, you get the drawers, you get the pots and the pans, you have the stove, you have everything for you, and this is how you cook, or this is how you build a website. It's very opinionated. On the other hand, React said, hey, I only care about this whole idea of components and virtual DOM, and I only am going to work with the view, the user interface. Everything else that you need, well, you can just use other modules, other libraries, and mix and match and have whatever you want customized to your need. So it was a library, a UI library, which is not like a kitchen. It's more like, let's say, the stove. They gave you the stove to cook your soup on, but everything else, like knife, cutting board, spoon, well, you can pick whichever one you want. It's up to you what you use to build that soup. All we give you is this oven. And the key idea was that because it was so small, you can learn once and write anywhere. What does that mean? Well, React doesn't make assumptions about what technology stack you use. All we give you is, hey, here is this idea of components of a blueprint that we can use a massive JavaScript object to make changes. And here's also a robot that, well, interacts with the DOM and makes changes for you. But because of this, we actually are able, because it only focuses with the UI, we're actually able to move React to other places other than, well, let's say the web. For example, we now can have different robots that interact with different views, and all they need is this main React library or blueprint of how to, well, look at a JavaScript object and say, hey, change this UI. So now you could have things like React Native, and this little robot can look at this blueprint and say, change the view in a iOS app, an Android app, and although it might not know anything about the DOM, it only needs to know about views in a mobile app. You also have things like React 360, which is VR apps. And again, using this blueprint of React, I can use it for VR apps, and this little robot or library can focus on VR. We also have things like Electron and React Desktop that allows us to build desktop applications, and they interact with Windows and Mac OS and Linux operating systems. We even have things like React Blessed that work with the terminal and the command prompt. And because of this, React was able to use this concept and have developers that originally just wrote for websites on the browser to now use the same idea and the same principles and the same JavaScript code to build desktop applications, to build VR applications, to build mobile applications. And this idea of cross-platform really took off with React. And you'll notice when we start building our projects that we actually import two libraries in React. The core React library, which is this little robot, and the React DOM library, which is this specific robot that only knows how to interact with the DOM, or the web browser. We learned the four main concepts that really made React take off. It gave developers a whole new way to think about their applications and how we built them. And it was architected in such a way that it made building large-scale applications a lot more pleasant than what we had before. Now, since then, a lot of libraries have come out that have taken some of the React concepts. Angular was rewritten to a new version that is more in line with these concepts. Libraries like Vue are also using these concepts because people have realized that these are some really good principles. So now you have things like React, Angular, Vue that developers are using to build front-end applications. But React really had this initial jump, and it's still the most popular library and the library with the most job demand because it was the first to introduce these principles. And the beauty is that although we haven't written any code, you've now learned a little bit about some of the keywords that we'll encounter throughout this course. And don't worry, you're not supposed to get them 100% just now, because all of these things are something that we need to practice, code, and build projects with to really understand them. But now when you hear the words like declarative, JSX, components, state, props, virtual DOM, you'll at least have an idea of what it is. Because we've learned that React is a declarative paradigm. That is, instead of telling our apps exactly what to do, we simply give it some state, some components that are built with something called JSX, and these components sometimes receive properties, which are called props. We give all that information a giant JavaScript object in a declarative way, which creates a virtual DOM in JavaScript, and that virtual DOM is used by the React library to update the DOM for us in a declarative way. But your question is this: how do I become the best React developer I can be. And to be a great React developer, it actually comes down to three things. Three things that really, really good senior React developers do well. And we're going to focus on these three skills throughout the course. The first one is to decide on components. Really good React developers decide what is a component. How much do we want to break down a component? How do we build these reusable components as we've seen? And deciding on how to break down the app into different components is a very important skill. The next thing is to decide the state and where it lives. Now we're going to explore this idea of state or data of our app a lot more, but this state can live in different locations in our virtual DOM. So whether we put the state here, or we put the state here, or here, or here, or in multiple locations, that decision is very important in architecting your app. And really good React developers do a really good job placing state in the appropriate component. The third is, what changes should we make when the state changes? Based on what this JavaScript object called state is changed, we have to decide what to re-render, what part of the virtual DOM changes. And deciding on this is also important because it has huge effects on performance. Now, don't worry, these are the things that we're going to really work on, but I want you to keep this as a reference because if you want to become a senior React developer, these are the things that you have to become really good at, making these decisions and knowing when something is good, when something is bad. We're going to explore that and a lot more in the next section. I'll see you in the next one. Bye-bye. Let's get started with React basics. Now, if you've taken any of my previous courses where I've taught React, or you're not a React beginner and you've built some applications before with React, then you can actually just skim through these videos or skip this entire section, as this section covers the React basics. We're going to build our first React application from scratch using something called Create React App, and then we're going to deploy it to GitHub Pages. Again, if you're completely new to React, then you have to finish this section to move on with the course. However, for those with a bit of experience, you might find this section a little bit easy. Determine for yourself which direction you want to go. Remember, our goal here is to build these basics so that we can build our giant application, our e-commerce platform using React. Now, in this section, we're going to learn a few things. However, we're going to make a few assumptions here. First, we're going to assume you know how to use your terminal or your command prompt. And you can also use any code editor you want. You can use Visual Studio Code, Sublime Text, or any other popular JavaScript developer environments. Now, this section is going to be a code along. So I highly recommend, if you're following along, to have your terminal or command prompt set up if you're on Windows, terminal if you're on Mac or Linux system, and have your code editor so you follow along. Now, over the next couple of videos, we're going to install Node if you don't have it already, and also the Create React app that is going to allow us to write React. I do want to make a few notes though. First, with this course, as long as you have version 10 or higher for Node, you're going to be fine. If you don't have a version of Node on your system that is 10 or lower, then I recommend updating Node, or if not, you can use something called NVM. And NVM is a Node version manager. So it's a simple way in the terminal for us to switch Node versions. Now, this is something you can go through on your own. The easiest way to do things is to just simply download Node from the node.js.org website. Now, the second thing we're going to do is we're going to actually install something called Create React App. And if I go to reactjs.org here and I go to Docs, under the Create a New React App, we have this thing called Create React App, which we're going to talk about in the upcoming video. Now, the one thing I want to mention is that you'll see this command npx. And npx is actually new and comes with version of npm 5.2. So if your npm version is lower than this, this command won't work. So you might want to update your npm version as well. Now, npx, for those that haven't seen it before, runs a command of a package without installing it explicitly. So what does that mean? Well, before we had npx, this is what we had to do. You see here that this is the current version of React. Based on when you're watching the video, you might have versions that are higher. But again, this course will work with any versions higher than 16.8. If I go here and go to an older version of React, let's say 15.6, if I click on documentation, and then let's do docs, and then finally we look at the installation, you'll see that we had to run npm install globally create React app. And then we ran the create React app command to create our app. npx allows us to not install this global version of create React app and just simply run that one command to create our app. All right, now let's go back. If for some reason during this section you are unable to get this started, there is another option where you can use this codesandbox.io, which I'll link to, that actually allows you within the browser to use React Online. Now, one last thing. We're going to get started and go step by step into building our React application. But I also want to point something out to you. You see, when we study or learn libraries or frameworks or tools like React, the best place to learn about something is often the documentation. And most tutorials don't mention this fact that, well, we have the official React documentation that explains how React works inside and out. And most tutorials that you see online are taught using this basic template. So remember, if you ever have questions, this is always the best place to start. Now, we're going to be covering some main concepts in React here. But remember that the way you learn a library is not like reading a dictionary where you just learn every single thing that this library gives you. The thing to understand that we'll go into later on in this course is how to build bigger and bigger applications, how to architect your app, so that instead of learning something like a dictionary one by one, we learn the principles and the concepts that allow us to do advanced things and build real-life applications, something that I'm really excited to do in this course. So, enough talk. It's time for us to get started. We're going to start setting up our environment in the next video. We're going to build our first app, and it's going to be a fun one. I'll see you in that one. Bye-bye.
Welcome back, everybody. In this lesson, I'm going to show you how you can set up your environment so that you can follow this course with all of the tools that I have and that you'll see throughout the course. Along the way, I'll mention some alternatives that you might use. It's entirely up to you because these are all just tools and I simply have my own setup that I use throughout this course. Now, the first thing you need to install is your editor. So if you already have an editor that you prefer, such as Sublime or Atom or even an IDE like WebStorm, you can totally use that. I like Visual Studio Code, so that's what I use. So in order for you to get Visual Studio Code, simply go to this link that I'm going to provide you in your resources, and then hit the Download for Mac button. Now what this will do is this will trigger the installation. So simply choose the place where you want to download the actual VS Code. So I'm going to choose Desktop, and this will download the zip folder for you. Then you simply just open up the zip, and now you'll have your Visual Studio Code application where you saved your zip folder. So now if I go to my desktop folder, I see it right here. So just double click to open it, and then allow your Mac to open Visual Studio Code. Because it's downloaded from the internet, you need to give it permission. Now, once you've given it permission, Visual Studio Code is up and running. So you now have the same editor that I use. The only thing I would suggest you probably do is add the code shell command to your terminal. Now, we'll explain more about what that actually is in a little bit later. But right now, in order for you to add it, you simply hold Command Shift and press P. Then you're going to type command, and here you'll see shell command install code command path. So simply click that, and then it will install the code command to your path. Now, once you have your path set up, you're now able to use the code dot command to open up files and folders inside of your terminal, which we will do a lot in this course. Now, what is the terminal? Well, the terminal is actually going to be the main way that we navigate around our application, as well as modify our files, as you'll see in this course. Now, by default, Mac comes with a terminal. So in order for you to access it, simply go to your Spotlight search and type in terminal. Once you have that, just open up the first thing you see, and this will be the terminal that you can use throughout this course. Now, with this terminal, what we need to do next is actually install Node. Now, the easiest way for us to install Node is actually to use something called NVM, which is Node Version Manager. Now, in order to install NVM, simply go to the link that I'm going to provide you inside of your resource folder. And then once you navigate to this link, scroll down to this section called Installation and Update, and simply copy this line and then paste it into your terminal. What this will do is this will clone down the NVM package and then add it to your existing shell, which is the thing that we're running inside of our terminal. Now, once we have NVM, we have to actually close our terminal and then relaunch it. Now, once you've reopened your terminal, type in Command-V NVM. If you see nothing listed, then this means that NVM is not yet loaded to our shell. So what we have to do is we have to actually scroll down here, and we can see inside of these instructions right here on OS X, if we see that there's no NVM script, then what we have to do is first check if we have a bash profile. Now, you can do this by simply typing nano and then this tilde sign /.bash profile. Now, if you hit this and nothing occurs, meaning that there is no bash profile, instead of nano, replace this with touch and then run nano bash profile again, because touch will open a new bash profile for you. So inside of our bash profile, if at the very bottom we see nothing related to NVM, then we need to add this line of running source bash rc. So let's just add that in right now. You can also copy paste this in if you want. Once we have that, we just need to save by hitting Command X. It'll ask us if we want to save. We hit Y, and then we hit Enter. And now what we need to do is we need to type source /.bash profile to upload and rerun our bash profile that we've just made changes to. And now if we type in NVM, we'll see that there's something here instead of NVM command not found. So now we know we have NVM. So now what we need to do is actually install Node using NVM. And the way we do that is we can actually first figure out what Node version we want to run. So let's go to the Node website, which I will link to you as well inside of your resources. And here we'll see that the latest version is 10.16.0. So we don't need to actually manually download this from the website. We can use NVM. So go back to your terminal and you can type in NVM install 10.16.0 or any other version of Node that you want to use. Now, you can also type in NVM install Node, and this will give you the latest version of Node. So for us, I'm just going to use 10.16.0, and now this will install the appropriate version of Node that we need. Once it's done installing, what we need to do is make sure that we use it. So in order to do that, we can just say NVM use 10.16.0. And now we'll be using the right version of Node. We'll also see that npm was installed as well. And npm is what we're going to use to manage the packages, which are the libraries that we use inside of our JavaScript applications. So this is really good. We have both of them installed now, and we can check by typing node-v as well as npm-v. And here we see that we have both installed on our computer. So at this point, it's actually perfectly fine to continue with the course. You have Node, you have npm, you have your terminal, and you have your editor. Now, the thing is that I use yarn instead of npm. Yarn is simply another package manager that Facebook made during a time when NPM had some issues. But NPM is perfectly stable now, and both are pretty equal in terms of the features and the speed regarding package management. So if you want to use NPM and not install Yarn, you can definitely do so. You can simply look at the different commands with NPM that you need in order to run commands instead of using the Yarn ones that I do. But if you want to use Yarn, just go to the Yarn link that I provide you in your resources, scroll down to the installation script, and then copy that line right there. Then you go back to your terminal, we clear it, and then we paste it in. And now this will install Yarn into your computer. Now, once you have Yarn, you just need to check whether or not it's there. So simply type in yarn-v, and if you see a version, now you also have Yarn. So now you're able to do everything that I do in this course with Yarn, and you can switch between Yarn and NP freely. Ideally, in one project, however, you should use either one or the other. You should not use both NPM and Yarn in the same folder. Now, keeping that in mind, you're fully set up to move on with the course. So I'll see you in the next lesson. Hello everyone, and welcome back. In this video, I want to quickly show you how you can get your environment set up so that you can code along inside of this course if you are on a Windows computer. Now, in the Windows computer, there's a couple different terminal options you have. The main one that I think is very useful is the one that comes integrated with Visual Studio Code. The benefit of this as well is that because I use Visual Studio Code as my editor, if you're unfamiliar with editors, you can easily use Visual Studio Code and you'll be able to follow everything that I'm doing with my editor because we both would end up using the exact same editor. So in order to use Visual Studio Code, I'm going to paste for you a link inside of your resources that you can use to get the download. So simply hit download for Windows and wait for the download to complete. Once your Visual Studio Code finishes downloading, simply go to the folder that you set it in. So in my case, it's in my downloads folder, and just simply double click to install it. Now, inside of here, you're going to be asked for a license agreement. So simply accept the agreement, and then you'll have these boxes that you can check. Now, I would probably check all the ones that are unchecked, but what this allows you to do is access Visual Studio Code through different settings on your computer so you can use it to open up your projects. Simply hit next and then install. Once it's finished, we can simply launch Visual Studio Code. And then inside of Visual Studio Code, you now have your editor. So in order for you to actually open up the terminal that I have here, simply go up to the Terminal tab and hit New Terminal. And this will now open up the terminal that you have by default set up inside of your Windows computer. If you have installed other shells, you'll be able to select them from this dropdown. But in my case, I only have PowerShell, which is the default shell that comes with the computer. So what I'm going to do now is I am going to actually install a different one called Git Bash. Now, with Git Bash, you are now able to access the underlying Git projects and Git folders that we will use throughout this course because we want to push to GitHub. So use the link that I provided for you and simply hit download. Now this will download this the same way that we just downloaded Visual Studio Code and just save it wherever you want to. Once it's finished downloading, go to the folder where it's downloaded to and simply run it as well. Now this will ask you if you allow it to make changes. Now you want to hit yes because this will install Git Bash instead of PowerShell, which comes with much easier to understand controls. Now here it'll ask you if you want it to allow you to install different things. And in my case, I just want to add another icon on the desktop so it's easy to launch. And then by default, it'll ask you what editor you want to use. So usually Vim is the one that most people are comfortable with, or Visual Studio Code, which we just downloaded, if you want it to be the one that opens whenever you want to modify files and text files. But we'll explore that a little later. For now, I'm just going to stick to Vim and hit next. And then I want to run Git from my command line. And then I want to also use OpenSSL in order to validate my Git. You can just hit next for this. And for here, you can also use Git Bash's own Minty terminal emulator. So this one is entirely up to you. I personally, I'm going to use the Git provided Minty, and then I'm just going to hit next again. Experimental is up to you whether or not you want to opt in or not to these new commands. It does not really matter. I'm not going to opt in. And I'm just going to wait for the install to finish. Now, once everything's installed, simply hit finish, and then go back to your Visual Studio Code and close it. So we need to actually access the new terminal because we have a new shell. So in order to do this, just reopen Visual Studio Code after you've closed it. And then inside of this dropdown, what we're going to do is we are going to hit select default shell. And we are going to choose our Git Bash. Now this will switch our main terminal whenever we add a new one or whenever we open our terminal to use our new Git Bash shell. And the way to do that is now you simply hit this plus icon, which we'll see is now Bash, and then you just close your old PowerShell by switching back to it and hitting the garbage can. And now you have Bash set up as your main terminal. Now if you see these colors when you switch to Bash, that means that you are running the Minty emulator, if you remember in those settings when we were installing Git Bash. So this is actually a quality of life emulator. It just makes different things in the terminal prettier as well as easier to understand and reason about. You can of course run other emulators if you want, such as Z Shell, which is what I have when you watch my course. But in our case, Minty is fine for Windows. Now, what we need to install next is Node. Node is actually what's going to allow us to run JavaScript inside of our terminal. What we have to do is we have to go to this website of Node.js and simply download the installer equivalent to whatever bit your Windows is. So mine is 64. I'm just going to download the 64-bit one. Once it's finished downloading, open the folder and then just run the Node installer. Now, Node is what we need in order for us to run our JavaScript, as well as manage our JavaScript packages for all of the applications that we'll be building. So simply hit next, accept the license and agreement, install Node, and then hit next again, and finally install. Now, Node also comes with NPM, which is Node Package Manager. And we want to hit yes here as well when it asks if it allows us to make changes to our device. And Node Package Manager is what allows us to manage different versions of Node. Now, the versions of Node all come with different features, and Node is always being updated. But we want to just use the latest version of Node at the time of when you watch this video. And usually that's what this link will recommend you as well. It'll try and give you the latest LTS version. So simply wait until our node is finished installing. And once it's finished, simply hit finish. Now we have to make sure that Node and NPM are properly installed on our computer. So the way we do that is we just have to close our Visual Studio Code and reopen it again, because we need to see and load a new version of our terminal. And once our terminal comes in, we simply type in node-v, and we should see some number. So this will tell us the version of Node that we currently have installed. If we hit npm-v, we'll see the version of npm we have installed. Now that you have npm and Node, you can actually run through this course. The only thing is that I use Yarn as my package manager instead of npm. Now, Yarn and npm are pretty much the same thing. The only thing was that there was a period of time where npm was kind of buggy. And what Facebook did was they created Yarn so that it was a more efficient package manager. But npm has since then caught up. Now, you can easily Google all of the commands that you need that are the same replacements for what's used in Yarn if you wanted to just use npm. But if you want to use Yarn, I'm going to show you how to download Yarn. So simply copy the resource that I've given you inside of your resource folder that says Yarn, and then paste it into your browser. And once you're on this page, make sure your operating system is Windows and your version is stable. Then you just click Download Installer. Now you'll see here that it says that we can only do this after we've installed Node.js, which we just did. So with this, once it's finished, we simply go to where we've installed it and run the installer. We're going to accept the license, hit next, and then finally hit install. We want to allow it to make changes, and we finish. And now we need to go back to our Visual Studio Code, close it again, and rerun it because we need to make sure that we have the version of Yarn installed on our computer. So what we can do inside of our terminal is just type yarn-v once it's finished loading. And we should see the version that we just installed. And with this, your environment is now set up for the rest of the course. So I'll see you in the next lesson. Hello everyone and welcome back. In this video, we are going to start building out our first React application. And the application is going to be this Monsters-Rolodex project. What this project is, it's a single page application React app. And what it lists is a bunch of these different monsters. You can also see the monsters and actually filter them using the search bar. So let's say, for example, we wanted to filter for Clementine as we start typing. We will see that we will start filtering out any monster that does not have a name where it matches what we typed in the string. It's a very simple application, but it'll teach us a lot about how React works and how React application is structured. Getting started with a React application might seem very complicated because there's a lot of files that we would typically have to come up with and write from scratch if we wanted to actually write out an application in React. However, luckily for us, Facebook has actually created a tool that makes this significantly easier. And this tool is called Create React App. Create React App is pretty much just a tool that you can run inside of your command line. And what it will do for you is it will scaffold out a React project, a very bare bones React project. And scaffolding just means that it will set up all of the necessary files and folders and then link them appropriately so that you can get started with a React application. And that's what we're going to use to really understand how it works. Here inside of React.js's own documentation on Create React App, you'll see that it's very simple. It says, of course, that it is a comfortable environment for learning React and is the best way to start building a new single-page application. So we're going to deep dive into what this means, all of the different files and the different setups that it provides for you. And then we're going to deep dive into how we can do this without Create React App later in the course. So we're going to fully understand how all of this works under the hood. But for now, we're just going to leverage it so that it makes our lives easier so we can get started with our first React application. So here you'll see what it says is that we want to run this command, npx create react app, and then the name of the application that we want to call. So what it means is just that when it builds it for us, it will build it into a folder, and we want to give it some kind of name. So here, let's go into our terminal, and we're going to type exactly what it said, npx create react app, and then the name of our folder, which it's going to actually put all of the files into that represents our project. So I'm just going to call it Monsters-Rolodex right here. Now what's happening is that you will see that npx is actually downloading the package and the latest version of Create React App in order to actually help us scaffold out this Monsters-Rolodex project. Scaffold being actually generating, again, the files and folders required for our application to actually work. So this is really handy. But in this process, you might be wondering, what is npx? What is Create React App? And let's take a little deep dive into all of these things while we're waiting for our project to be built. So I'm going to open a new tab. And what I'm also going to do is that I am going to show you npm versus npx, because that'll actually be the best way to understand what npx does. And npx is actually a tool that gets included with npm version 5.2 and greater. So npx is actually a tool that lives within npm. So npm, as we know, is Node Package Manager. These packages are just these different node-related libraries or files and folders that get created by different tool developers online that we can use to help us with our Node projects or JavaScript-based projects. What this means is that npm is what we use to coordinate and also leverage these different packages that we download. Create React App is an example of one of these. It's just this tool that Facebook built that allows us to quickly and easily build out React applications. So we can do this with npm and not npx. The thing about npm is that npm is an installation as well as an executable environment. So what this means is that we can install directly Create React App and all of these different packages onto our local project, local being this local folder I have, or we can install it globally on our computer. So if I do npm install and then the name, let's say Create React App, what this will do is it will install and download Create React App locally into this folder. So that means that anything inside of this folder can leverage Create React App. However, if I wanted to use Create React App in multiple projects, but I only wanted one version of it, because Create React App, as we know, is a package created by Facebook, and Facebook could be constantly updating it. So you might have numerous versions of Create React App in multiple different projects. But what if we want to always to leverage one version of it across our entire computer? Well, here it's very easy. We just say npm install -g, which means global. So install it globally and then create React App. So this is typically how we used to do it before npx, meaning that what we had to do is we had to download down the latest version of Create React App if we wanted to use all of the latest features in order to build our React applications. So let me give you an example of what we can do with a very simple library, and it's called cow-say. So cow-say is a library that just draws out this cow that says whatever we pass it. So for example, if I wanted it globally again, what I do is npm install, or npm I, which is shorthand for install, -g, so globally make this available, and I want cow-say. So now it's going to download, again, as we know with npm, all of the appropriate files and install it globally. So what I can do now is I can say cow-say hello. And you'll see that it draws a little cow because I have this cow-say project globally installed, and it will just say the text that I passed it, which is hello. So if I wanted to see where I have this cow-say project, I could do npm list, which just lists out the location of a package. So if I say npm list cow-say, what I'm saying is that I want you to check the current folder for some package called cow-say. And when you see this, you'll see that it's empty. Of course it is. The reason why is we installed it globally. So if I wanted to check npm, again, list -g and then cow-say, now it's going to check the global location, which is your path location where we save all of our globally installed packages with npm. And now we say that, oh, there is a version of cow-say here, version 1.5.0. So here you can see that we have with npm, when we installed this library and then wanted to use it, we had to install it somewhere on our disk, our hard drive, our computer. This could be in our local project folder, or this could be globally on our computer. So what I'm going to do now is I'm going to delete this cow-say project from our global list. So I'm going to say npm uninstall -g, because again, it's global, cow-say. So now this is going to get rid of it. You'll see that it says removed 41 packages. And again, if we just double check list -g cow-say, what we'll see is that it's empty. So this is exactly what we wanted. So now that we have this, let's understand what npx does instead. So instead, I'm going to say npx cow-say hello. And now if we run this, what we'll see is that we're still downloading the package cow-say because we don't have it, and it will execute it immediately. Before, when we did it with npm, remember, we downloaded it, and then we had to run cow-say and then call it. So here, what npx does is it directly installs all of the required files for this package, and it executes it immediately. So what this means though, is not all it is, just that it downloaded and it exited quickly? No. In fact, if we check npm list cause locally, we'll see that it's empty. If we check npm list-g cause, what we'll also see is that it's empty. So what this means is that npx downloads the packages, the latest package for cause, so the latest version of it, and it executes it immediately, and then it deletes it from the disk. Now you might be wondering, why do we want to do this? Well, the main advantage is that 1, you don't have to clog up your environment or your disk with all of these different packages that you have to make sure that if you're running the latest version of it. Certain things like this, you might just want to use when you need it and make sure that when you use it, you're using the latest version. So the benefit here is that when you call npx, you are going to ask for the latest version. Now, of course, you can specify with a argument at version. So you can say, oh, I want this exact version instead, and npx will download that exact version. But if you don't pass that, what it'll do is it'll just download the latest version and then execute it and then delete it. So that's why it's super useful, because this way we don't have to think and manage the different packages that we're leveraging. And this is really useful for something like Create React App, because chances are you just want to use the Create React App library to start up a new React project when you need to. When you don't want to use it. And if we go back to our CRA folder where we were running our Create React App with npx to get the latest folder, here we see that now it's done. We have our application called Monsters-Rolodex, and we can see it right here. So let's cd into it. And what we're going to do is we are going to talk and break down about what got generated with Create React App in the next video. So here, once again, let me just go over quickly what we did. We used npx to download the Create React App package, the latest version of it. We generated our React application, Monsters-Rolodex, and then with npx, automatically, it deleted Create React App, so it doesn't take up any space on our computer. And now we have our Monsters-Rolodex React project that Create React App has scaffolded for us, and we are going to break down what is inside. So with that, I'll see you in the next video. Welcome back, everyone. In the last video, we leveraged npx to download the Create React App package to help us scaffold out our React project, Monsters-Rolodex. In this video, we're going to break down and take a look at all of the different folders and files that have been set up for us by Create React App. So let's go ahead and open up our project. And inside, what I want us to take a look at is the package.json file first. We see that there's a lot of these different files and folders that got set up for us, but let's just focus on the package.json file first. Package.json is a file that tells our application, or tells any developer looking at the application, what are the different libraries or packages that this project needs in order to work. All of this was set up for us by Create React App because Create React App knows what the minimum required packages are going to be in order to run a React application. And it's installed all of them for us, as well as a couple handy packages that make our lives easier. So if we look at it, what was installed for us in dependencies is that there's some testing libraries here, and these are really just ways that we can test the code that we write. We can take a better look at that later in the course. We're going to talk about testing very extensively. Right now, it's not important. We see that there's React and React DOM. Both of these are libraries that are very critical in order to run our React application, as well as React scripts and Web Vitals. This one I want you to ignore. React scripts is the main one that we want to focus on. React scripts is the kind of package helper that Create React App gave us so that it can make our life easier when it comes to doing all the different things we need to develop a React application. These React scripts are just different tools that help us leverage these new scripts that were generated for us. Start, build, test, and eject. What you'll notice is that they are just calling the React scripts library and then calling one of these commands. So React scripts was installed in order for us to actually leverage these scripts themselves. And what React scripts does is it helps us better build our application and develop against it using these 4 different commands. So let's start with start. What does start do? Start will take all of the files that we have written for our React application, and it will run them in a local development environment so that we can actually test it in the browser. So in order to run this, what we need to do is go back to our terminal and use your package manager. So I'm using Yarn. You can use NPM. It's totally up to you. I prefer Yarn. And I'm just going to say Yarn and then the name of the script, which was start. Now here you'll see that it said React scripts start. So this, of course, was what was inside of package.json for that script, which was start. So it actually runs the full command right here for us. And what you'll see is that it's starting the development server. So as I mentioned, what it's doing is it's taking all of the files that live under our source folder, the source folder being the entry point for the actual code that we're writing for React app. Inside, there's a bunch of these files that we're going to go over. But what it's doing is it's just taking all of this and it's building out the actual React application. And now if we go to our browser, we see that at localhost 3000, which is where React scripts start, hosts to the specific port on our computer of 3000, and it will show us our application. It's a very simple application. It's just a one page with a spinning logo and then some text. So let's understand what it is that React scripts start is doing for us. Going back to our project, we see that there's a source folder and inside are all these files that were built for us. These are the minimum files required in order to actually use React. So let's take a look at what's happening inside. The entry point for every React project is the index.js file. Just like any project, index.js just says that index being the first file that we want to look at, which is JavaScript related .js. This file inside imports a couple of these libraries that, again, Create React App is set up for us. The main one is React and React DOM. These two libraries are very critical in order for React to work. You want to see React as kind of the underlying engine. So it's the engine that actually does all of the work when it comes to how React functions as a website builder. Or not just a website builder, but essentially an application builder. Now, why do I say application? Well, this is where we look at the second library, React DOM. React DOM is related to the web, DOM being the document object model in web-related projects. So React DOM is these different tools that help us actually build web applications. React is the engine that runs how these applications get built. React DOM is specifying that that engine should be directed towards web-related applications. Though these two libraries combined is what actually allows us to build out all of our web application in React. So you might be wondering, well, is there other React-related libraries for building out other things? Of course. There's React Native, which is for native mobile applications. You might have heard of React Native. There's also a virtual reality application tool that you can build, also leveraging the React engine. So that's why for our web application, we want both React and React DOM. And both of these libraries get included with Create React App. We're going to deep dive into what each of these do a little later. For now, we just need to understand that they are provided for us and we need to leverage them in order to build a React application. We also import index.css, which is just a CSS file that is also built for us by default. There's this app, which we're going to take a look at a little later, and then this report web vitals. Again, we're just going to ignore the report web vitals. And what we're going to look at is the code right here. So what this is saying is that it is saying that we want to leverage this React DOM library and we want to render. So again, I don't want you to get too bogged down about these methods that get used because we're going to really deep dive into it later. But for now, what I want you to see is that all this is doing is it is rendering out this code right here. And inside of this is the app. Now, I want you to think of the app as the entire React application. We'll go into all the details later, but for now, conceptually, just understand app right here is our entire React application. This React.strict mode, this is something that Create React App has generated for us, and strict mode just means that inside, whatever's inside of this strict mode, these two tags here, you're going to essentially add these additional checks and warnings that React says in case you're using old deprecated code. So the reason for this is because React, of course, is at the latest version, which is 17 right now. 18 is just about to come out. And there are certain features that are being deprecated with these new React versions. Essentially, a lot of different teams are still using those old versions of the code. And strict mode just says, hey, there's certain things I don't want you to use. I want to be very strict about you not using some of those things. So what it's saying is that anything inside that's React related within this tag that says React.strict mode, I'm going to throw warnings about those specific things, or I'm just going to outright not let you use them because they're deprecated. Deprecating meaning that the React team doesn't support them anymore in the new version of React. So really that's all that's happening here. So React DOM, of course, is again the library, and it's saying, hey, I want you to render the application. But where do you render it? I want you to render it finding some document element with an ID of root. So where is this happening? Well, this is actually happening inside of the index.html. Now you might be wondering, where is our index.html file? This is actually inside of the public folder. So the public folder is also generated by Create React App for us. And index.html is like any index.html file in any application. It's just the base HTML file that represents the application's entry point. So in here, you of course have all your different head tag, your meta tags, and all of the typical web application related files that all get built for you, or not files, but necessarily, but the HTML components. And down here in the body, which is where I want you to focus, you'll see that there is this div. And this div has an ID of root. So what's happening here is that our index.js is looking for some element with an ID of root. And as we see in the index.html, this div has the ID of root. So what React is saying is, oh, I want you to take that div and I want you to replace that div and render into it our entire React application. And that's what this is doing right here. So that's pretty much how React actually works with HTML as a whole. In fact, you can actually easily see that, let's say we write something underneath here. Let's say we just add an H1 and inside I say, hello everyone. If I save this, what will happen, and one of the benefits of Create React App, is Create React App will actually rebuild our application for us. And what we'll see now is that it is updated. And down here you see the hello everyone text. So what you'll notice though, is that this is living outside of our React application. And this is perfectly normal because all, again, this index.js file is doing is it is saying, oh, what I want you to do is I want you to find some element with the ID of root and essentially render inside of it this React application. So that's what's happening right here. But below it is another perfectly valid HTML tag with an H1. It just doesn't have to live inside of our React application. So it lives outside of it directly as a sibling, which is why you see right here, this is living outside of our React app. So that's what I want you to understand about React. React is just some way for us to actually just build React applications into an HTML file. But that doesn't mean that all of the other HTML is not valid. No, it's perfectly valid. You just have to understand that everything lives inside of whatever you're rendering, which in our case is all within the app. Now, throughout the course, we will break down what each of these libraries do, and we'll take a much deeper dive. But for now, I just want to give you a high-level idea of what it is that Create React App has set up for us, as well as how React kind of works at a very high level, without diving too deep into these details. So that's all I want you to think about for now. In the next videos, we are going to break down what some of these files actually represent that Create React App has given us, and we're also going to continue looking at those other 3 scripts that come in package.json. So with that in mind, I will see you in the next video. Welcome back, everyone. In the last video, we took a look at what files and folders got built for us by Create React App, and inside of package.json, we took a look at our start script. We took a look at also the files related to setting up the initial project, which is the index.js file and the index.html file, and how React DOM at a high level helps us render out our application. In this video, we are going to deep dive into the 3 remaining scripts inside of React, And what we're going to do as well is we will take a look at some of these other files and how they relate to these scripts. So diving into the next one, which is build. What is build? So right now, what I want you to understand is that when we ran script start, this is just taking our application code and pushing it directly through our local port of 3000, so on our computer, and our browser is just accessing it directly. It doesn't have to go through our network, which is our Wi-Fi or internet connection or anything like that, in order to get the related files in order to run our application. It doesn't need to. It's all local on our computer. So this is incredibly efficient and fast. We don't even need to think about optimizing it at all. But when we're actually hosting our application live somewhere so that anybody can access our website, they need to leverage their internet connection. And as we know, internet connection varies and it can be very slow. So what needs to happen is our code needs to be much more optimized so that it's as small and efficiently served as possible. And that's really what this build step does. So going back to our terminal, if we do something like we call yarn or npm, whichever one you prefer once again, and we call build, what will happen is that React scripts will actually generate an optimal build for us, an optimal build folder. And what this is doing is it is taking all of this code that we have. So all of these separate files and all of these different JavaScript and CSS files. And what it'll do is it'll actually group it all into one file for each related JS, CSS, index HTML, and it will make it as optimal as possible. And it will put it all inside of a new folder right here called build. So if you go into this, what you'll see is that there's our index.html file again. But inside of here, you see that it's very condensed. And what you'll notice is that in here is all of the code related to our application. You'll see that there's all this like really funky looking JavaScript code, and it's really tight, and it's just using these very reduced variable names. And the reason for this is because it's trying to create the most optimal low memory version of our application as possible. So that's really what's happening here. It's taking all of these files that we have, all these potential JavaScript files that we're going to write throughout this course, and it's just condensing it down into the fastest version that can be sent over an internet connection for a browser to consume. So that's really all this build is doing for us. So going back to our package.json, we want to look at test. So testing we're going to cover extensively later in the course. At a high level, all you need to know is that tests are just ways for us to make sure that the code that we write for our React application does what we expect it to. Inside, you'll see that there is a app.test file. Don't look at the content for now. This is not as important right now. But essentially what it is that it's a test file that is trying to test something in specific. In this particular case, it's testing the app.js file. We haven't looked at these yet, but all you need to know at a high level is that this test is related to this file. And it's just making sure that this file's code does what we expect it to. So when you run React scripts test, it's going to try and test your code. And it'll tell you whether or not your code is doing what you expect it to do according to the test. If it doesn't, it will break and fail. And again, we're going to talk about testing much later. I don't want to bog you down into the details of it right now, but just understand that's what this does. Now, finally, let's talk about eject. To talk about eject, we have to get a deeper understanding of actually what happens in the build. So one thing I want you to think about is that when it comes to a browser, right now I'm using Chrome, but there's actually numerous different browsers. There's Safari, there is Internet Explorer, there's Edge, there's Opera, there's probably some other browsers. Each browser is implemented a little differently. That's why there are different browsers. What this means is that they consume the HTML, CSS, and JavaScript files in their own way under the hood. This code that we're writing, which is React code, is not necessarily code that every browser can understand. A lot of the times, this is some interesting, funky syntax, which we'll deep dive into once we go throughout the course, that is already kind of hard for us to understand. We have to understand how React works in order to write this code. The browser definitely doesn't understand. Oftentimes, the browser understands an older version of JavaScript syntax only. So what's happening is that in this build process, there is actually two libraries being used, or two packages, two helpers, essentially. One is called Babel, and the other is called Webpack. What Babel does is it takes all of this React code that we've written, all this React funky JavaScript, and it actually condenses it down into this JavaScript that these browsers can understand. If you look at it, it's very basic JavaScript, very, very old school JavaScript. None of the new syntax that you and I are used to writing with. So the reason for this is because, again, all of these browsers, all these different browsers can understand probably a very basic version of JavaScript. And Babel is just making sure that all of our code gets built into a version that can be understood by these browsers. So I mentioned there were two main helpers. There's Babel and there's Webpack. What is Webpack? Well, Webpack is actually something that makes our code a little bit more efficient. So inside of here, this index.html, there is some JavaScript that is focused on actually pulling the primary JavaScript files. So inside of the static folder inside of build, you'll see there's a CSS folder, there's a JS folder. Inside of this JS folder is all the different chunks. You'll notice that they all end in this .chunk. A chunk is essentially a contained portion of JavaScript code that is working together to actually represent a part of our application. What it's doing is that Webpack is saying, hey, sometimes, let's say our application, we wrote a massive, massive web page. There's a lot of different JavaScript files that even when reduced can only be reduced so far. So what Webpack says is, oh, okay, actually, you know what? Let me break these into chunks so that when the user is trying to access the homepage, he just gets the JavaScript related to the homepage. If he wants to navigate to like another page, then I'm going to turn that other page into a new chunk and then send it to them when they need it. So Webpack is essentially modularizing our code. Module being a chunk. That's a good way to think about it. So that's really what Webpack does, is it's saying, oh, your JavaScript's really big. I'm going to make sure that I optimize it and break it into the self-contained portions of it so that when the user is trying to access one part of it, it only gets the relevant JavaScript for that part. It's not going to get all of it. And that's all Webpack is doing. So essentially, what Build is doing is it's leveraging Babel and Webpack in order for it to properly optimize for these browsers as well as for the speed so that we send down all the appropriate chunks when the user needs them. That's what it's doing. So how does this relate to what I was talking about, which is eject? Well, again, Webpack and Babel are tools. That means that you can modify them so that they follow some specific rules that you want. Create React App is just saying, hey, I've already optimized that for you. I'm optimizing telling Babel and telling Webpack what to do. If you want to modify it for your project needs and concerns, you can eject. And what that will do is it will spit out the files that are related to actually showing you what Babel and Webpack do. So you can modify them to do what you want. And actually, Andre is going to break that down in the next video and actually tell you why you shouldn't eject, because honestly, Facebook's a really optimized team for this kind of stuff, and they've written extensively and they've tested extensively the best configuration for Webpack and Babel for most cases. Chances are you might actually work on a project that does need you to eject because of some funky work requirement based on your project. But most of the time, especially for us learning React, we definitely don't need to eject. But that's really what's happening here. Now, before we break down some of the core portions of the actual React code, I want to take a look at a couple other of the more minor files that we got generated. There is this setup tests.js, which is related to the actual tests themselves. It's just a file that really just imports the specific testing library. And that testing library will dive deeper later, so don't worry about this one. Inside of our public, there is a favicon. So this favicon is really just this icon right here in the tab of your browser. That's just what that icon is. We also get these logos of these different sizes, and these logos are more so related to this manifest.json file. The manifest.json file is a way for us to actually be progressive web app compliant, and all this means progressive web app is that some people want to be able to download your web application onto their desktop so that they can access it offline. It's essentially a way for somebody to use your application not through the browser. So essentially with these logos, you can create this little icon of your choice, which is what these logos will be, inside of this contained progressive web app application that they download from the website onto their desktop. And then that logo is what they double click to actually open your progressive web app version of your website. If that seems confusing, don't worry. We're going to go through how that all works later, much later in the course. But just understand that this is doing that for us. And then there's also this robots.txt file. And this file is just telling essentially web scrapers, which is SEO related. So like Google, for example, when they determine whether they need to rank your website higher or lower, it crawls your website with their own kind of like code crawlers. And this robots.txt is just a way to help explain what that is. This one you don't have to really worry about as far as your building web application goes, but just understand that it's generated for you. So now that we understand the majority of some of the lesser important files that are all generated for us, we are going to dive into what the main bulk of the actual code created for us by Create React App and related to React code is related. And we're going to do that in the next video. So I'll see you in the next video. Welcome back, everyone. In this video, we are going to dive into the meat of the actual React code finally. So what we're going to do is we're looking at the app.js file. As I mentioned, the app.js file, if you think back to our index.js file, we were importing app from this .app file. So app here is actually the app.js. And what app.js is it represents our entire React application. So we're going to dive deep into how this one file doesn't actually contain the entire application as we build it out. It's just that right now, this is the main bulk of what the application represents. Because the application is very simple. It's pretty much just this part of the website. So if you look at it, all it is with React is that we are importing the logo, which is the logo.svg. And we are also importing our app.css file. So this is also generated for us, and it's what makes the logo spin and gives the background color and then makes these the certain sizes that they are. That's all this CSS that's listed in here. So by importing it, we're saying, oh, I want you to apply the CSS. So that's being applied to this website now. Here, you'll notice that there is this function. And this is very important because in React is pretty much just using functions to return HTML. That's all it is. This code is just some generic function called app that returns you this specific HTML that represents this function of app. And you can see this app function as a component. So what is a component? A component is pretty much a self-contained piece of code that returns some visual UI representation of HTML. UI being this thing that we can see and interact with. Now, as we know with websites, anything we interact with is a combination of HTML, CSS, and JavaScript. So this is no different here. It's just that all of this is contained within this function. So inside of here, if you look at this is pretty much just basic HTML. We have a div, we have a header, we have an image, and this image is being passed the source of our logo. So our logo, SVG, which is just this icon that is spinning. And this image is being rendered inside of this header HTML component. And then there's some p tag here with some text inside. And then there's an anchor tag that points to Learn React. Very simple HTML. And this function is essentially returning this HTML. So that's really all that's happening is that inside of index.js, React is just saying, oh, I want you to render this app. And here, this looks like an HTML tag. And the reason for that is because using React DOM, we're saying, oh, okay, this HTML tag is some function code that will return us more HTML, which is exactly what app.js is. It's returning us HTML code. So what we're looking at here is really just the HTML that's being rendered on the page. And if we update this, let's say I update this p tag to say, hello, my name is Yihua. If I save this, now if I go back here, again, Create React App is just rebuilding and it is updating this text now to say, hello, my name is Yihua. You saw it's pretty automatic. But here, what we're just seeing is that that's really all React is, really. It's just code, so a function or a class, which we'll learn about later, that returns us back HTML. That's really all React is, if you really want to think about the very bare bones of React. It's just these helper functions that help us return HTML. So it allows us to build websites and these UI in a very efficient, componentized way. Components, once again, being the self-contained representations of HTML, CSS, and JavaScript. So this is really all that's happening here. So with that, you pretty much understand actually all that React app has given us. Some of the more nuanced things that go on, such as tests and the progressive web app stuff, we'll explain later. But as far as the main bulk of what we're going to work on, when we start converting this Create React App application over to the Monsters-Rolodex project, is just going to be around writing these functions or these classes that return us back HTML. And that's all it is. So now that you understand what Create React App does, there is one caveat I must mention before moving forward. So a lot of the videos were done using an older version of Create React App. Right now, I'm actually speaking to you in the present with the latest version of Create React App. So when you go through, you'll notice that some of these files are slightly different, but honestly, it's so insignificant. It's pretty much all the exact same. It's just that a couple things have been tweaked and the placements are a little different, but all the concepts you learn and everything that you see is going to largely remain the same. So definitely don't get scared if you see it. Just understand that all the core concepts that you have are already now fully explained as to what Create React App is doing. The older versions are doing the exact same thing. It's just that Create React App and Facebook like to change the way that they build things every once in a while. Not necessarily because it's more optimized, but sometimes just because they want to introduce some things or remove some things, but nothing is that significant. 99% of everything is largely the exact same. So now that you understand this, let's start actually building out our Monsters-Rolodex project and getting really into the meat of our React application. So before we start doing that, once again, Andre is going to just quickly dive into why you should not eject by showing you what happens when you eject. Once again, this is just a better understanding of what it is that our code is doing. But here, again, you understand that all React is just functions that return HTML. That's really all it is. So with that, let's move to the next video.
Hey, welcome back. I just want to add a quick note here. I've actually ejected a Create React app just to show you what happens. You'll see here that it gives me a folder called scripts and then a folder called config. And in here, well, this was everything that the Create React app was hiding underneath the hood for us. You had things like Jest that was using for tests. We have our Webpack configuration. Remember our module bundler. You can see over here how long and intense and complicated it looks. We also have all the scripts that were run, for example, when we ran npm run build or npm run start or test. You see over here that it's quite a lot of code. This is why I recommend not ejecting. Because no matter what, no matter how much time you spend with React, you are never going to compete with the developers that are working full time, trying to make Create React app the best tool possible. Developers that are getting paid to make this tool as easy and as efficient for you. So I recommend that you never eject out of Create React app unless you absolutely have to. Because by using Create React app, we automatically get the best system and project build out of the box. And anytime there are updates or the industry changes and there's new ways of doing things, Create React app is automatically, going to have new version that has those changes implemented by professionals. So again, I wanted to show you that this is what's happening underneath the hood. But 99.9% of the time, you don't really need to eject because you lose all the benefits as Create React app gets more and more updates. I'll see you in the next one. Bye-bye. All right. I had to make this quick video to talk about the elephant in the room. If you know anything about the React world, this discussion has to happen. Classes versus hooks. Now, as you learn in the course, there's many ways to build React components. And one of the newer ways to write these components is using hooks. Now, the way we've structured the course is the way that we actually recommend you learn how to write proper applications. The thing is, hooks are fairly new and they're exciting. So a lot of people talk about them, but they're also very specific to React. What you learn about hooks, you can't really apply to anywhere else in the programming world because they're so React specific. Versus classes, well, that's part of JavaScript. Learning classes is an important concept, not only in JavaScript, but a lot of other programming languages. Also, because hooks are fairly new, a lot of code bases in React still use classes because there's nothing wrong with classes. So the way we've structured the course is that we're going to teach you React starting with classes, so you know how those work so that you can apply that knowledge to any of your future projects, or if you land on a project at a job that still uses classes, and then we're going to convert the app using hooks. So you get to learn both ways. And we also started with classes because there's been a little bit of move lately in the industry where people are shying away from hooks because of the added complexity it adds to React. Now, this is a hot topic of discussion. It doesn't really matter whichever one you prefer. Our goal is to teach you both, and then you can decide for yourself what is best. The way we've structured the course is what we think is the best way to learn React. That is, starting with classes as they were intended, and then learning hooks afterwards to show what problems hooks solves that maybe we had with classes. So hang in there. We're going to cover both of these. I'll see you in the next one. Bye-bye.
Welcome back, everyone. Now that we understand how Create React App has helped us scaffold out our project, let's actually go about building our project. There's a couple things that I want you to really focus in on while we go through these lessons, especially throughout this course, because I think that this is probably the main thing you want to focus on when it comes to learning React as a concept, beyond just learning how to actually write the code that React presents itself with. And this concept is the idea of rendering. In my opinion, what makes a great React developer from a good React developer is a great React developer really understands when React is rendering and re-rendering your website. This is one of the most core and essential things to understand with React because that's really all React does. Earlier, Andre mentioned that when we're writing React, we are going to write things in either class components or functional components with hooks. Functional components with hooks is the modern way that we do a lot of things in React, even though many companies use a mix of classes and functional components. And if this doesn't make sense right now, don't worry about it. The reason why you don't need to worry about it is because it's really just syntax and different ways to do kind of the same thing, which is tell React when you want it to render and re-render different parts of your website. And I'm really going to hone in on this throughout this course. But this is what I really want you to focus on, is understanding when React renders and re-renders parts of your website. Because that's really all React does as a framework. So in order for us to begin on this, let's first take a look at our project. So as I mentioned in our package.json, Create React App gave us this start script that lets us start the base project that it's scaffolded for us. So in case you haven't done it again, let's just quickly do it. Let's go back to our terminal and let's run yarn start, which is the script that will start up our React server that will then host our website. So here we're going to localhost 3000, which is where our website is going to be hosted. So let's just wait for this to load. And now we see it. This is the base project that Create React App has given us. So what you saw here is that this website was loading and waiting for React to render something onto the page. In this case, we have this spinning logo, we have this text, and then we have this link to learn more about React. It links to the React docs. But what happened here was that this page was rendered. These different things that you see were all rendered. All you need to understand about rendering is pretty much putting some UI, which is some HTML, some CSS, or some JavaScript onto the page that a user can then interact with and see. So something is done rendering the moment that they can interact with it. It's on the page. That's the idea of rendering. So let's go back to our code here and let's go into app.js. As I mentioned when we were walking through our Create React app, it generated this file for us, app.js, and inside is a function app. And this function returns some HTML when you look at this. The reason why you can read this as HTML and JavaScript is able to render this is because of the fact that this is written in JSX. So JSX is really just a syntax extension of JavaScript. Now you might be wondering, whoa, syntax extension, what does that mean? All it really means is that they've taken JavaScript and they've added more functionality to it. They've extended its functionality. And what it really works is that it allows you to write what looks like HTML inside of your JavaScript. So this looks like HTML, but it's not HTML. But it really closely resembles HTML. And that's really the most important thing. The reason why is because React decided that a lot of what you want to render visually, now the visual representation, of course, is HTML. As we know, HTML encaptures what we want to put onto the web page. It doesn't actually extend any of the functionality. Remember, the functionality is the JavaScript. The behavior is the JavaScript. The HTML just determines what you want to see. React has decided that that thing that you want to see, the UI component, is very closely tied to how you want the UI to behave. So we'll learn a lot more about that throughout the course, and you'll really understand that idea. But what you really want to focus on here with JSX is that it makes it much easier for us to tell our JavaScript code, i.e. our function, what we want it to visually render to the page. JSX is really just a more efficient way for us to tell our React code or our JavaScript extended code what we want to render. In this particular case, this function app is a functional component that renders through its return statement this block of HTML or HTML-like JavaScript. So we'll dive into this a lot more, but again, what I want you to focus on is that this has to do with the rendering. We're telling this function what we want it to render, and the JSX just makes it easier for us to tell this functional app what we want it to render. So writing a functional component is one way to render something to the page. It's one way of telling React what our component should do. Another way, though, is using a class component. And a class component is where I want us to start. As I mentioned before, class components do pretty much the same thing functional components do, just in a slightly different way. But they all do the same thing, functional components and class components. It allows us to tell React what we expect this component to render and how we expect it to render things. And I want to start with a class component over a functional component because a class component is easier to understand this idea of when React will render and re-render things. And I'm going to show you how. So what we're going to first do is just convert this into a class component. In order to do that, we actually need to import component from React. And this is something that is a class that React gives us so that it allows all of the new components that we write in a class component format to get access to some of the functionality that by default React has already built for us inside of this component class. So to convert it, I'm going to say class app extends component. So here I'm saying, hey, I want you to make this class called app, and I want you to extend the functionality of this component class that React has given us. And what we need to change here is that React has also created on this component class a render method. So this already exists, but what we're passing to it is this return. And inside of this return is going to be, again, the JSX or HTML representation of what you want this component to give back. And that's it. This will pretty much be the exact same thing as that previous app function that we had. So if we go back to our browser, we'll see that our web page is the exact same. Everything is still working. If we open up our console, we see that we have no errors. So here we understand, okay, this functional component that we had before is pretty much the exact same now as this class component. They're still rendering the same thing. In fact, it's just that here, React is explicitly telling us, oh, this is what you are rendering. So that is why I think it's more helpful. We're already seeing, oh, I'm already explicitly telling my component what I want it to render. And therefore React knows, oh, what do I want to render? whatever is returned from my render method. So in this lesson, we learned that there are functional components and class components that both pretty much just tell React that with this component, what do I want you to render? In the next video, we're going to learn about some additional things that we can do that we can jump in and modify both what we're rendering and how we want things to be re-rendered. And that will really help us be able to actually begin to modify our website to be more like an app. And we're going to see that in the next video. So I'll see you there. Welcome back, everyone. So when we look at our React application, we see that this website is pretty static, meaning that things don't really change. Yes, our logo spins, but none of this text really changes, and this link doesn't change where it links out to. No matter how many times you click this link, it's always going to take you to the React website. This is very atypical of the complex applications that we're used to working with. So when we look at our app.js file, that makes sense because when we look at the code inside of here, everything is hard-coded. And you'll hear this a lot when something is hard-coded. What this means is that there is nothing dynamic about the code. The text inside the p tag is exactly what we see it as. This is exactly what we'll render, the string inside of here. There's nothing dynamic about it. There's no way that that string is ever going to really change. But that really isn't useful for us when it comes to building websites. And this is a very important thing to understand because essentially what we want to do is we want to make it so that React will render this string code dynamically based on something. Whatever it is, we want to have control over that. And that's what we're going to go into in this lesson. So here what I'm going to do is I'm going to actually change up this text so that it says Hi Yihua. Again, it's still hard-coded, but that's all I really want you to focus on. And I'm also going to create a button instead of that anchor tag. And inside, it's going to say change name, meaning that when you click it, I want to change this name. So right now, it's still hard-coded. And when we go back, what we see is that React has re-rendered our web page so that now it says what I changed it to, Hi Yihua, and it has a button that says change name. Now, of course, when you click it, nothing happens because we haven't coded in that functionality yet. But that's what we're going to do. So here you see Yihua is still hard-coded. It's still not a variable. It's nothing really. It's just hard-coded Yihua. But I want to change this so that maybe when I click this button, change name, this value will change. So how do we do that? Well, going back to our class component that React has given us, React actually allows us to do this quite easily. And what we can do is use a method that we have access to with any class. But React has actually gone into it and made some modifications that allow us to keep track of something called local state. Local state, or just state for short, is just some information that only this component is aware of and can modify and can read from. So the way that we can actually access and generate this state is through the constructor method. The constructor method is a method that's available on all class components, and you can see constructor as in construction. And why that's important is because it's saying that, hey, whenever this app is constructed, whenever it's built, instantiated, any of those terms, I want you to run this constructor method first. And inside of this constructor method, you call super. Super is not actually important for what it does for our React component code as far as you're concerned. All it is it's saying, hey, call super. Super just calls the underlying constructor method of any other classes you are extending from. So here our class app extends from component. Just call super so that you're calling the constructor method on the component. If you're unfamiliar with what that is doing and why that's useful, you can watch a video that I'm going to link where Andre gives a deeper dive on classes in general, and you'll understand what that's happening there. But for now, you just got to understand that whenever you write this constructor, you got to write the super. This is really not that important for how it extends into our functionality with these class components and what we dictate, but it's just something that needs to happen and you need to write. But going back to state, here inside of our constructor function, I mentioned that React will run this constructor method before anything else. In fact, all classes do that. But what I want to do here is I actually want to instantiate this state that I was talking about. And to do that, I'm going to say this, which is referencing this class, this.state. This is something that React is looking for inside of your constructor, inside of your component. I want to say this.state is equal to an empty object. So for now, it's an empty object because I haven't told it what the state value should be. But this state is always a JSON object. And here, what I want to change this to is I want to give it a key value pair inside. Key value pairs can be whatever they want. So whatever key you want to have, and then whatever value you want to give it. Here, because we're working with names, I'm going to say this.state equals a empty object for now. And I want to give it a name key. And this is going to point to a string value of Yihua. So now that I have this, I want to actually, instead of hard coding hi Yihua, I want it to reference this state object, and I want it to reference the name key so that I can get the Yihua value. To do that, inside of JSX, I can actually access JavaScript variables, which is why, as you can see, we're tying what it looks like with the functionality, and the functionality, of course, being the JavaScript. So in order to use this variable, we can actually use curly braces inside of our HTML of our JSX. React is looking through this HTML and saying, hey, whenever I see curly braces, I know you want to access a JavaScript variable. And the variable I want to access is this.state.name. And now if I save this and we go back to our website, we see that nothing's changed. This is exactly how we want it to be. But let me prove it to you. Instead of Yihua, let me say Andre. And if I save, look, we now see it says, hi, Andre. So we know that instead of hard coding, this is now using the variable this.state.name, which right now is equal to Andre. So this is what's so great about using state, because now we're able to cast these variables that React has access to inside of this component. And using this, we now have more dynamic ability. We don't have to hard code all of these values inside of our HTML and JSX. In fact, you can kind of see it actually already being scaffolded out for us here with this logo. But this is a little bit more complicated than we need to dive into right now. But essentially what I want you to focus on is the fact that this is so powerful now. We, inside of our HTML, can directly use and leverage JavaScript variables. And whenever these variables change, React will re-render this HTML that we see so that's using the updated variable value. And this is incredibly powerful. So again, right now, all we know is that we are able to leverage this value that has been initialized when our constructor gets called. But it's still not dynamic. We're still not changing it on the fly, maybe not even through user interaction. But that's what we're going to cover in the next video. How do we update this value? How do we tie some of this functionality to it and then make it more dynamic? But again, what I really want you to focus on, again, is this is how React is allowing us to render and re-render information that represents the UI. So in the next video, let's cover how we can make this more dynamic. Welcome back, everyone. In the last video, we learned about initializing some local state inside of this component, which is an object that has key value pairs in it. And then how do we access that state object, or any JavaScript variable really, inside of our JSX code? In this lesson, we're going to learn more about extending some JavaScript functionality into these components to do something much more dynamic and much more useful when it comes to building applications. So what we want to do is, let's say I just wanted to click this button, change name, and then have it change from Yihua to Andre. How do I do that? So inside of your JSX, React actually allows you to bind event handlers onto any HTML element. So what is an event handler? Event handler is really just something that I want to happen whenever an event happens. So what this means for our button, per se, is every time this button is clicked, I want something to happen. So to do that, I have access to this on and then the name of the event. In this particular case, I want on click. So whenever this gets clicked, I want some functionality to happen. And the way that I can tell it what functionality to happen whenever I click it is I say on click is a property, which is equal to a block of JavaScript. And remember, whenever I want to access JavaScript, whether it be a variable or even hard-coded in JavaScript, I use these curly braces. So here I'm saying, hey, onClick equals, and then inside of here, what onClick is expecting is a function. You may hear the word function or callback function used pretty interchangeably. A callback is just a function you pass to some kind of handler that you want it to call during some process. In this particular case, of course, I want it to be called whenever it gets clicked. So I'm passing it right now this empty function, so nothing will happen. But what I want to do whenever this button is clicked, again, is change the name value to Andre instead of Yihua. Now, you might think, oh, let me just do this.state.name is equal to Andre. But this is actually not going to behave the way that we're expecting it to. In fact, let's also console.log this.state, just so that we're very clear about what's happening once we save this. So if we go back to our application, we hit this button, change name. No matter how many times we hit it, we see that Yihua here is not updating to Andre, even though the object that gets logged out is the correct value we're expecting. We see that our object here, name, is now Andre, but why is it that inside our application, it's still using the previous value of Yihua? Now, this actually has to do with the way that React determines when a component needs to re-render. And re-rendering in this case, as I mentioned, is when React decides, oh, I need to update the DOM or repaint the UI. So let's break down why exactly it is that here this is not working the way that we want it to. This actually has to do with the fact that we're not actually changing the object in a way that React recognizes that the state object is different. Now you might be wondering, well, Yihua, the object is different. It used to say name equals Yihua, now it says name equals Andre. But for React, it's not leveraging that change in the values in the object as an actual change. The way that React detects it that there's a change is it uses JavaScript's underlying reference by memory for an object. What that means is that in memory, whenever we instantiate a variable, let's say const object1, and let me say that this object is equal to the same object that we have as our state. So name is equal to Yihua. This object1 is just pointing to this object when it gets instantiated. So what happens is that under the hood, JavaScript goes, oh, there's this object I want to create in memory, which has this shape, name equals Yihua. And then I'm going to create some variable called object1, and it's going to point to this object that I just made. An easy way to see this is if I say object2 is equal to object1. What's happening here is that JavaScript's like, oh, okay, this object1, what's it pointing to? It's pointing to this object in memory. So I'm just going to make object2 a pointer that points to the same object in memory. And now if I say object2, strict equality, which is 3 equal signs, equals to object1, it'll say that it's true. Strict equality just says, hey, are these two pointers pointing to the same thing in memory? Yes, they are. This is object equality when you do triple equals with objects. The reason why this is actually not working for React and updating the DOM has to do with this concept. Let's say we say object1.name is equal to Andre. When I update this, object1 now has that new updated value. Object2 also has that updated value. And this makes sense. They're both pointing to the same thing in memory. But again, this object in memory is not different. It's the same object in memory. So even though the value has changed, it's still the same thing in memory. So for React actually says the only way I'm going to update a component when I know that the state is different is if there's a completely different object in memory. And how does that happen? Well, let me give you an example. Let's say we make another object, object3. And in here we use object.assign. Object-assign is a method that allows us to create a different object using another object as a template. So let's say first what I'm saying is the first argument is a new object, a brand new object. So this is the first argument. It's like, what do I want to make or assign a new object from? The first one is a brand new object right here. The second one, I want to use object1. Now if I look, object3, it has the same signature, or it has the same shape as object1. It's still name equals Andre. But now if I do object1 triple equals, again, strict equality, with object3, I see that it's false. And the reason for this is because this object, even though it's the same one as object1 when we changed it, These are two different objects in memory. An even easier way to do this is if I say const object4 is equal to an object with the name Andre. Here you'll see that I'm typing out a brand new object. So this is a completely different object. Even though it looks the exact same as object 1 and object 2's pointing object in memory, even object 3, they all look the same. But when we do strict equality with object 4, we see that it's different. Object 3 and object 4, completely different. Not the same object in memory. So this is when React will determine that it needs to re-render your component, is when state is a completely different object in memory. The moment it's a different object in memory, React will be like, oh, okay, it's time to update this object. So let's do that quickly, actually. How do we do this? Well, an easy way that we can do this, React actually gives us a method, and it's called setState. Now, setState is an interesting method because there's actually many ways to use it, but I'm going to show you the very basic, simple way, which is that you give it an object that you want to shallow merge with your current state object. What's shallow merge? A shallow merge just means that whatever values that you pass to me inside of this object, I am going to update and check through the state object to see if there are the same keys. If there are the same keys, I'm going to update your state keys with the new value you give me. So here I'm going to say name is equal to Andre. So what's going to happen is that when we call this, React is going to be like, oh, okay, you want to call setState. So you want to update the state value. What do you want to do? You want to take this object and you want to say, oh, I want to find any name on this object and I want to update it to the new value. So now this object's going to say name equals Ihua. Instead, it's going to update it to name equals Andre. So now if we go back, we clear, we hit change name, we see that it's updated. And the reason for this, again, is because what setState does under the hood is that it's actually updating state to a different object. And React, once it detects, oh, state is now a different object in memory, let me re-render this component and in turn update the application's UI. So now that we understand a bit more of setState as well as object and reference, which is how React determines when a component updates, let's go more in depth into setState, which I will do in the next video. So I'll see you there. In the last video, we learned about how a React class component decides that it needs to re-render when the state is different. The way that it determines that the state is different is when it sees that the state object is now a different object in memory. And the way that we can best use this is to utilize the class component's setState method that React has given us. As I mentioned in the last video, setState can take an object and it will in fact shallow merge this object into your current state and give you a new state object. But there's actually other things you can pass the setState, but we'll talk about that a little later. For now, I want to focus on the shallow merge so we really understand what it does and then what the best practices for it are. So when you pass it an object, as we saw with shallow merging, it will look for any keys that exist in the current state object, and it will update them to the new one that we have. In our case, we're updating name to Andre. So we can actually see this if instead we do another value. Let's say company is equal to ZTM. And just to be clear, let's also render this to our UI, and I'll say, hi, I work at, and then this.state.company. So I haven't modified setState. We're still just updating the name. And if we go back to our application, if I hit change name, it says, hi, Andre, I work at ZTM. And just to be clear, let's also console log this.state. And if I save this, now if I click this again, you'll see the first time that we click console log, our state object still says Yihua and company, but I'll break this down a little later as to why that's happening, and it's not what you expect, which is why is it not saying Andre? If I click it again, now it's Andre. So don't worry about this for now. I'm going to talk about why this is happening a little later, but for now, what I want you to focus on is the fact that what happened with that shallow merge is that name did get updated to Andre. You'll see, name is now Andre, but the company stays the same. So this again is a shallow merge. It only updates the keys for the values that are being passed to it. Anything else, it keeps and it retains the same way. Now, one important consideration to make about the shallow merge is that there's actually a thing that yields a best practice when we do this. Because with a shallow merge, React doesn't care what the value was before. All it cares about is that I see that the keys match, I'm gonna update the value, regardless of how complex the previous value was. What do I mean by this? Well, let's update name so that instead of a string, it says that it's an object that has a first name value as well as a last name value. And now inside of my string, let's also update this.state.name.firstName so that it's now referencing the new value that we have, which is an object. And I want to point to the first name as well as the last name. So now if I save this and I go back to my application, we'll see that now it says, Hi Yihua Zhang, I work at ZTM. When I click change name, again, we see that this was the previous value, so let's ignore this. Again, I'll talk about this in the next video. But let's say I update again. You'll see what happens is that our state object got updated, so that name is Andre. But here we see that our app is not working the way we expect it to. It's not displaying Andre anymore. And this makes actually total sense, because name is now just a string. It's no longer that object that we had before, the first name, last name, complex object. And the reason why that this is not rendering is because when we look at our code is looking for this.state.name.firstName and this.state.name.lastName. But of course, as we know, a string doesn't have a .firstName or a .lastName property. So now our code is breaking. But again, with the shallow merge, React doesn't care that this is a completely different shape or even in fact type than what it was before. Because now we got a string. Before it was an object. React doesn't care. It's say, oh, you just want me to shallow merge this key of name value to replace the old one? I'm just going to do that. So this actually extends into a best practice so that our code doesn't behave in this weird way where it breaks. We want to make sure that when we update our state, we're always using the same types of values for our object properties. So if your name is going to be an object, make sure that you update it appropriately like so. So that here, first name is still Andre, and last name is Niagoi. I hope I spelled that right. So here now, when I click change name, now it works the way we expect it to. So this is an important thing to understand about using setState when you pass it an object. So now that we understand setState with an object, I'm actually going to, in the next lesson, break down what the different way you can use setState is, where you don't pass it an object, but instead you pass it a function. And with this function, it's actually the preferred way to do so. Not all the time, because you will see a lot of projects use setState where they pass it an object still. But as far as React's own suggestion goes, you should use the function, and there are certain perks to it, which I'll explain in the next video. Similarly, it's also going to explain why whenever we were logging our state object in our experiments, we see that the first time I do so, despite the fact that the value in the UI has updated, my console log seems to be behind because the object still says first name, last name of the previous value. So we're going to break that down in the next video, and I'll see you there. Welcome back, everyone. So I know we're spending a lot of time with setState, and you might be wondering, Yihua, let's just build Monsters-Rolodex. But I really think this forms a great, solid foundation moving forward of really understanding the code that you're writing and how React's engine works at a high level. If we build the solid foundation of just understanding how through setState and state and this class component that React determines when to re-render or render a component, we really can very quickly understand all of the other nuances of components in React, as well as why something is working or not working, and just the general flow of everything. Because as I mentioned with React, it's really just all about components and how and when they render or re-render. With setState, I showed you earlier that when we just pass the object, we do a shallow merge, which in turn React does do an update. But inside of this same function, so the same callback that we gave to onClick, we also did a console log.this.state. And yet for some reason, once this console log ran, we were seeing our old state object and not the new one. So just to clarify, when we refresh here, what we should begin with is Hi Yihua Zhang. This should be the initial state, which it is, as we see demonstrated in the UI. But I click change name, UI updates to Andre Niagoy, but for some reason the console log still shows the previous. Why is this? So this again actually has to do with the way that React does its re-rendering, which is where it re-rendered our component. However, with this set state call, what's happening here with the shallow merge is that this is actually happening asynchronously. So typically with JavaScript code happens in a synchronous manner, meaning that it runs one by one by one by one. In this particular case, we're expecting that within our callback that we update the state and then we console log this.state. But clearly, as we see, this is getting run first. However, the state is not being updated when this console log runs, meaning that the state at this point is still the previous one. Why is this? Is because React batches these different set state calls so that it can determine what the most optimal strategy for re-rendering the website is going to be. What do I mean by this? Well, let's say you imagine that you have an application where you have a lot of different components. And perhaps through one interaction, one button click, you're actually updating the state in multiple components, not just this one. Because inside of here, we have one component right now with one state. But you can imagine how in a more complex app, one interaction might update the state of multiple different components. In that case, React doesn't want to just completely isolate and do all those different updates independently. React wants to figure out if it can stack these together, or maybe there's a more optimal way of updating these components so that it is more performant. That's all what React is doing under the hood for us. So as a result, set state as a call is a non-synchronous call. It's an asynchronous call, meaning that when console.log, which is a synchronous call, gets called, at this point, the state might not be updated. It may or it may not be. Chances are it's not. So you might be wondering then, well, with set state then, what if I want to use the latest state after I've updated it inside of my code somehow? Like in our case, I want to console log and make sure that my state is up to date. Now we can achieve this where instead of passing this object to set state, we can pass it a function. So in this format, there's actually a different way. So as I mentioned, we can pass it a function. And what we can also pass it is a callback. So these are two different arguments that you can pass to setState. If you pass it like this, you'll actually be able to get a more consistent synchronous behavior, not really, but just at least one where we anticipate what's going to happen. So let me break this down. So I'm going to comment this out. So this first function is a updater function. The first function that you pass to setState here is going to be some function where you return an object that it will then use to shallow merge against state. So this is kind of very similar to what we did before when we just passed the object that we wanted to shallow merge against state as the argument to set state. But now instead, we're passing a function that returns this object that we want to, again, shallow merge. So you might be wondering, what's the point of doing this additional function? Well, the reason why we do this is because within this function, we get access to state as well as props. Props I'm going to cover later, but state, at this current moment, this state variable that we have access to is equal to the current state. And the reason why we want to use this is because sometimes we want to maybe update our state based on the previous value of the state. Props, on the other hand, is something that does with components. It's different values that you can pass to your component, and we're going to do a whole separate lesson on that and deeper understand it. For now, just understand that you don't really need it right now, but if you wanted to utilize props somehow inside of your state, you can do so. But again, don't worry about it. These are both optional, as you can see right here. I'm not even going to use it. I'm just going to use the return where I pass the object that I want to have. So let's just save this and see if it still works. So if we go back, here we see Yihua Zhang. I hit change name. It's updated to Andre Niagoy. So just like we saw earlier, this is doing that same state update as we had before. React is registering, oh, it's a different object in memory. I can now re-render, which we saw. But I mentioned earlier that we want to see the console log show the correct value. Well, that's actually what this second argument is, this function that we wrote, this callback. Again, as I mentioned, a callback is just a function that my code says, oh, once I'm finished, I want you to run this callback. So here inside of this function, we can write whatever we want. And I'm just going to console log the new state, so this.state. And what happens here is that this console log inside of this function is going to run only after all of the state changes have been applied. Meaning that only when React has determined in its asynchronous manner, oh, I've updated shallow merge the state and now the state is the new object, then I'm going to run this callback function. So now if we save this and we go back, now if I hit change name, what we'll see is that we have the correct newly updated state. And this format is actually the ideal optimal way that you should be writing your setState code in class components. The reason for this is just because by doing this, it's much more clear what's happening. You don't have to use the previous state or the props values, as I mentioned. We're definitely not doing that here. But in this way, anyone looking at it just anticipates and understands what's going to happen. It's going to understand that, oh, this object, just like before, is just going to be the thing that gets shallow merged, but also that this follow-up callback, if there is one, is going to run only after the state is fully updated, which makes it much easier to think about what's going to happen. You don't have to consider, oh my God, at this current moment, is my code actually updated or not? You know for sure that React is handling that. The moment that the state is up to date is only when this callback is going to get run. Now, again, this callback is also entirely optional. You don't have to pass it. You can just pass it this function. If you don't want to run a callback after state updates, there's nothing wrong with that. If we refresh and we clear out our console, we change name, our code still just works. So this is just a very key thing to understanding setState and how React determines when to update, when to batch things to make it more performant, and also when to run after it's updated the state. And this is really all it is. I know there's a lot that we learned about setState, and we're going to get a lot of practice. So don't worry. We're going to practice with it. We're going to get familiar with it so that as we build out Monsters-Rolodex, it'll become like second nature to you about using setState. I know I talked a lot about setState and it's really boring and really technical, but now we can start using setState to actually build out our Monsters-Rolodex application. And as promised, I'm also going to talk about props and how that gets involved as well. So in the next video, let's start building out our application. Welcome back, everyone. So let's start actually building our Monsters-Rolodex project so that it looks much more similar to the application we're expecting it to be. To begin with, what I want you to think about with this app component that we have here, this class component. Let's get rid of everything inside except for the div. Right now, this app component is pretty much the only component in the entire application. And it means that it represents the entire application as well. What I want you to think about is that when you look inside of index.js, I want you to ignore everything except for this part right here, react-dom.render. What it's saying is that React, I want you to render whatever's given to you as the first argument at the point where you go onto the document and you find some element with root. I explained to you earlier that when you look inside of the index.html file that got generated for us, we had this div with the ID of root. And what React does is it says, okay, instead of this div, I want you to render the entire application. And the way it does that is it takes this argument, which is really just the app as far as we're concerned. This app is this component. Whatever this component renders is whatever React DOM is going to render in this place. So here, this component is actually going to contain our entire application. All of the HTML here that we're going to return is going to be all of the HTML of our application. And these are going to be broken up into smaller and smaller components. And we'll talk about how that's done. But what you need to understand really is that this app component represents the entire application. It's a pretty common best practice to do so, where you have one app component, and this app component is what you use to render as the entirety of your application. So now that we understand that the app is going to be the actual application, let's start actually building it out and understanding what it is that we're trying to do. So with Monsters-Rolodex, It is a Rolodex, which is a tool that shows you a bunch of different user profiles. In our particular case, these users are monsters. Now, let's say we wanted to show 3 monsters. How would we go about doing that, doing what we know? Well, to begin with, inside of state, maybe we have 3 different monsters. We have monster 1, which is going to be a monster with the name of Linda. We have monster 2, which is going to be a similar object with the name of Frank. And then we have monster 3, which has the name of Jackie. Here, inside of our div, we want to render these 3 monsters somehow. And for now, just to keep it simple, let's say we render these monsters' names as h1s. So what we can do is we can say h1, and then using curly braces, monster1.name. Or sorry, this.state.monster1.name. And then similarly, we would just copy this 3 times. And now we use monster 2 and monster 3. Now, if we save this and we go to our application, we see that we have it updated. Linda, Frank, and Jackie are showing. So our code is working. But let's go back to this code here. This is actually pretty repetitive. If we had 100 monsters or 1,000 monsters, if we imagine a really big Rolodex, then do we have to copy and paste this 1,000 times? That seems extremely inefficient, doesn't it? What if instead we know that all of these different things are going to be the same? All these different monsters are going to be displayed using just an h1. Can we instead just use this as a template? Especially if every single one of these monsters is the same shape of data. The object is just an object that has a name of Jackie, or a name of Frank, or a name of Linda, or a name of whatever. We know that we can expect that this object is going to have a name property that's going to be a string. So we're just going to want to put that string inside of an h1. Can we just reuse the same HTML template? Well, actually we can, and this is what we're going to do to make this way easier for us. So what I'm going to do is that instead of each of these individual monsters having their own key on the state, I'm going to make a new key called monsters, and it's going to contain an array. Inside of this array is going to be my 3 monsters. So I'm just going to copy this over and get rid of the keys because it needs to actually look like an array. So now I have a monsters key with an array of our monsters as we had before. And now instead what I'm going to do is I just want to use this h1 template. But how do I access this array and convert it into those h1s? Well, here I'm going to use the array method map. So inside of our HTML, we're going to once again now call squiggly braces because I mentioned before that we want to access JavaScript. So I want to say this.state.monsters, which gives me the array, and I want to use the .map method. The .map method is a method that allows you to iterate over every single element from left to right inside of your array, and it gives you back a new array. But why is this useful? Because what we really want is an array of HTML elements with the shape that we expect the HTML to render. So in our particular case, we want to return a bunch of h1s where the text inside is the name of the monster. So right now I have an array of JSON objects. I don't have an array of the JSS HTML. So how do I do that? I use .map. .map, the way it works is you pass it a callback function. This callback function, the first argument that it gets is the actual element. So in this case, it's a monster. We know it's a monster. What React does, or rather what JavaScript does with .map, because map is a JavaScript method on arrays, is that it takes the callback function that you pass to it and it invokes it on every single element inside of the array, from top to bottom or left to right in this particular case. So we know that when we invoke this callback on this element, this one first element first inside of our array, this monster is going to be the element itself. It's going to give us that JSON object where the name is Linda. And here what we want to do is we want to return back the h1, as I mentioned, where I'm calling. So once again, we need the curly braces because we're inside of HTML. I want monster.name. here, what's going to happen, as I mentioned, is that React is going to look at your code and say, oh, inside of here, there is some curly braces. You want to access this.state.monsters, which is an array, and you want to map over it. What you want to do in that map is you want to give me this callback function where I'm going to take the element that you're trying to iterate through, so each of these different monsters, and I'm going to give you access to it inside of the callback. And what we want to do is we want to say, okay, with that monster or with that element, I want you to return me in that place an h1 where the inside is using monster.name. So this particular monster, I'm going to put Linda in there. And then the next one, when it iterates on the second element, it's going to use Frank. And then in the third element, it's going to use Jackie. And here, when we look at our code, we see that it still works. In fact, to prove that it's still working, I'm just going to add a fourth one, and this monster is going to be Andre. If I save and I go, there it is. So easy now that inside of this array, all we need to do is just make sure that we have an array where every object has the same signature or the same shape. And now inside of our code, our .map function is always going to now just generate a new h1 every time a new monster is added inside, or it's at least going to do it for every single monster inside of our array. And this is extremely powerful because by doing this now, this one block of code right here now encapsulates the entire UI rendering of all of the different monsters that we want to show. And this is an extremely powerful thing about React. Now, if you're unfamiliar with .map, we're going to include a video in our appendix where Andre's going to go into more depth about map if you're uncomfortable with it. But if you are, and you already understand how map works, then let's move on to the next lesson. And the next lesson, we're going to talk about something that some of you might have seen if you have your developer console open. You'll see that there's this warning where each child in a list should have a key property. And we're going to go into exactly what that means in the next video. I'll see you there. Welcome back, everyone. In this video, we're going to break down this warning, which says that each child in a list should have a unique key property. What does this mean? A key property is just a property on the actual, you can see it as a template or you can see it as the element HTML that we're returning from our map. In this particular case, it's the h1. React's just saying, hey, I want you to give me a key property, which is some unique string value, or it could be an integer. It doesn't matter. React is going to turn into a string either way. So here, if we know that, let's say, for example, our names are currently unique, then we could pass it a name value. This will work in our current context, but you can imagine that there might be a case where if we had 1,000 people, one of these names might overlap. We might have two different monsters named Frank. If that's the case, well, then this is no longer unique. So what we need to do is actually use a unique value. And most of the time, a unique value is going to be an ID. So in most projects, in most APIs, in almost everything where you're getting some kind of data, they'll have an ID value, which is some kind of string. That's like very complicated. And usually it's extremely complicated in a way that no two of these strings is identical, making them completely unique. And this is what we're going to use inside of our key value. So instead of monster.name, we're going to say monster.id. So you might be wondering, well, Yihua, why do we need this key value? This again goes back to React and re-rendering. This key value is actually something that React uses in order to make it more optimized when it comes to updating and re-rendering components on your page. On this page, we now have one app component, yes, but we have 4 different H1s that React has rendered onto the page for us. If we inspect, what we see is that inside of our app, which is the div, which is our component, we have these 4 H1s. But React will actually update this DOM directly, as we've seen before when we, let's say, add more to our components. In this particular case, how does React actually differentiate Linda from Frank, from Jackie, from Andre, these different H1s? The only way it can do it is by using the key value. And why is that important, you might be asking? Well, let's say, for example, what we did is we updated the name of Jackie to something else, like Yihua, for example. When React does that, Does that mean that React should now re-render every single H1 in this entire list? Or should it just re-render Jackie so that now it says Yihua? In order for React to do that, it needs to be able to properly differentiate these different components from each other. Because as I mentioned, these components are all using the same template. So how does React actually differentiate them and know that when Jackie got updated to Yihua, only Jackie needs to be up to date? Well, it uses that key value, that unique key value that associates that component to that bit of data. That is the purpose of the key. So we'll talk more about this when we start building a more verbose website. But for now, that's why whenever you use .map and you map out a list of HTML elements, you want to make sure that the top level, the very highest one, so let's say if this H1, actually let's make this a div. And inside of this div, we have an H1. We want to make sure that at the highest level of this element, which is the div, that we add this key. And now if we go back, we'll see that each of these are divs with the H1s. You might be wondering, well, I added the key, but why is it not showing up inside of the elements? Well, this is actually something unique for React. React is going to be the only thing that needs that key value. The regular HTML, when it actually gets built, doesn't need the key value. So React takes it off. But it knows under the hood, it's keeping track of this key. And using this key again, it's able to be much more performant and efficient when it comes to differentiating these components from each other and then figuring out which ones to re-render appropriately when their values update. That's the whole point of the key. So now that we understand this key, let's now move our application towards something that's much more typical of what we would expect. Instead of hard coding this array of monsters, let's fetch it from an API somewhere. In the next video, before we talk about that, I'm going to talk about some of the higher concept of why that's important when it comes to React and single page applications. So I'll see you in the next video. Welcome back, everyone. In this lesson, we're going to talk about how to get arrays of information from somewhere that is not just hard-coded on our website. So let's think about applications for a second. Right now, this array is hard-coded on our React application. The only way that this code can be updated is if we update this directly using some JavaScript code as we saw, or if we manually update it through typing. Almost all applications don't do this when it comes to any kind of dynamic information. This is dynamic because these values can change. We could get new users, we could get less users. You can imagine that on Facebook, they get millions of new users or users changing their data every single day. It would be completely unrealistic to have that all hard-coded inside of their React code. In fact, what they have to do is they have all of that user data living in a database somewhere. And then whenever their application needs it, they will then ask that database for that information and then use it to populate their website. Right now, what we're doing is we are hard coding in the website. We're not actually calling it from any database. And that's what we want to change. But before we go into that, we need to talk a little bit about single page applications and why it is that a React application as a single page application makes this whole process way easier. So let's break down a little bit of how websites work before and after SPAs. SPAs stand for single page applications, and they use frameworks kind of like React and Angular and Vue to help build them. So what we're building is a SPA whenever we work with React. Now there are of course some nuances once you start doing things like server-side rendering or even static page rendering when you do things like Gatsby, which is a React framework for static pages. But as far as our application goes in this course with React, we're just focused on building our SPAs. But before we understand SPAs, we need to talk a little bit about the world before SPAs. So let's say you have a website. In this particular case, let's imagine you are navigating to zerotomastery.io, which is our website. When you navigate there, what happens is that you actually need some code. And in a non-SPA environment, your browser doesn't actually know how to build this website. So what it has to do, it has to ask for the code from some kind of server. Now, this server is going to host all of the HTML, CSS, and JavaScript required to build your entire website. So your browser is going to go, oh, I need to access zerotomastery.io. What do I need? I need the home page. So you're going to make a request to the server and say, can you give me the code for the home page? So the server is going to say, okay, send you back the required HTML, CSS, and JavaScript needed to build the home page, and then your browser takes that and actually creates the UI and the page that the user is trying to access. Similarly, what happens if you try to navigate now to zerotomastery.io/React? Well, this is a different page entirely. So the code that we had before for the home page, not all of it is relevant. So what's going to happen is the browser is going to make another request to the same server and say, hey, someone's trying to access the React page. Can you give me the code for that? And the server says, okay. And it will give off the required HTML, CSS, and JavaScript files for the React page, which your browser then uses and builds that page. This is very familiar if you were using websites pre-2010. Nowadays, there's very few websites that kind of have this interaction, but you might remember before that there was a brief white page when you were navigating between pages on a website, which was when your browser was actually making a request on the network to a server and getting that code, which is why there was that white page, because essentially that's the time it takes for the network request to ask and then receive and then build the web page. Now, in an SPA environment, this is completely different. Similarly, you're still going to ask the browser, hey, I want to access zerotomastery.io. So for the very first time, there will still be a request to the ZTM server because at this point, your browser doesn't have the code for ZTM.io. So it's going to make that request to the server, and the server is going to send back the same thing, some HTML, some CSS, and some JavaScript. But now, remember, our website is an SPA, meaning that it was built with React. So this JavaScript code actually contains the React code as well as the React library and all the stuff that we wrote in order to build the website. So now what's going to happen is that our website, our browser, is going to take that code, build out that homepage, and now, just like before, everything here is the same. You have your homepage, everything is built with the code that we got from the server. But now when you navigate to ztm.io/React, we still have all of that JavaScript and React code. And now React doesn't need to go and ask the server for more code. Instead, using this React code, it itself is going to build the CSS and HTML pages required for the React page. And this is the big difference. We no longer need to go to the server for the code whenever we navigate and change pages. Anything that you see on a website that is an SPA or built in React, what's happening is that components are getting stripped off, they're getting put on, they're getting created, they're getting destroyed. All of this process is all happening live on the browser once we get that initial bundle of code that contains our React code. And this is what makes React so powerful, because now we no longer have any more of those white pages, and there's no more additional requests to the server for page-related code. This is not entirely true in the future once we start doing really customized optimizations. But for now, and the majority of SPAs, that's the main difference you need to think about. Any of those optimizations are further down the line, way further down the line. You don't have to worry about that right now. Right now, all you need to know is that through an SPA, we're able to get the entire bundle of our React code and our website code in one shot. So let's talk about what we are trying to do with our Monsters-Rolodex. As I mentioned, we already are writing some of this code required to build the Monsters-Rolodex website. We don't really have any pages at this point. We have our home page, which is going to display all those monsters, and then we're going to really just sift through them using a search bar. But right now, we don't actually have all those monsters because we're just hard coding them. So what we need to do is we need to access those users from some kind of user API. We're going to ask an external API, which is going to give us back a list of those users that we will then use in order to build out the list. So that code that we have hard coded, instead, we want to get that from an API somewhere. Not only do we have to get it from an API somewhere, we have to learn how to actually bring it into our React application so that we can use it. So that's what we're going to cover in the next video, and I'll see you there. Welcome back, everyone. So here is the website that we want to use in order to get our list of users. The website will display all of this as JSON, which is pretty much just objects of users with certain attributes on them. So there's an ID, there's a name, there's a username, there's email, there's address, and then there's some other extra information. What we really care about for now is just that there's a name and there's an ID. We need the name to display, and we need the ID because it is the key, if we remember. So what we're going to do is we are going to make a request to this website, which will give us back this array of JSON objects. So very easy. If you want this, it's actually going to be in your resource folder, so it's very easy to access. And what I want you to do is I want you to copy this. And then what we need to do now is figure out how to bring this array into our React application. So let's go back to our application. And let's think about a couple things that we need to do before we even start coding it. First off, what we need to do is think about where we're going to leverage the actual array once we get it inside our component. We've actually already thought about this with our monsters array. So what we want to do is we want to update the state of monsters to the array of users once we get them from the API. Here we have some hard-coded values, but in reality, I actually don't want that. Because when you think about it, why would I want to use any hard-coded values at all? I just want to use what values come from the API. My application should not have to worry about what that data looks like. Or not what it looks like, but whether or not I get how much data. That's not something our application should be largely concerned with. Of course, there are certain things like there are edge cases where if it's empty, do you want to display some kind of message that tells the user that there are no users that have been fetched? Perhaps, but that's not what I'm talking about here. I'm talking about the initial state of this monsters array. If you think about it, if you have an application that makes a request for a bunch of users, if you, let's say, fail in the middle of that API request, let's say your network cuts off or there's some corrupted data or something that is not related to our application, what would you want to do? What would it matter for a user to see? The user should not see anything then. They should just see the fact that there is an empty array, meaning that nothing should display then because nothing was properly fetched. That is the typical behavior of most applications. So in this case, with our state, we want to think about what's known as the empty case or the null case. So what happens when you have an initialized state or when you have a state that has nothing in it? So I'm talking about these state variables, of course. A monsters here is a list of users. So what's an empty version of that? Well, it's an empty list or an empty array. So we want to initialize these values as empty. Once this is empty, now what I want to do is I want to actually get that list of users. And the way I'm going to do that is I need to think, when do I get the list? How do I get the list? Where do I put the list? We already talked about where. It's going to be in our state. But how do I get the list? This is actually where React is going to give us these things known as lifecycle methods. So when you think about a component, I've always mentioned that a component's key thing in React is just figuring out when it renders and when it re-renders. So if our monsters array is empty, when we get the new list of array from our API, we want to update the state object and therefore we want to re-render this component. But when do we want to get that information? We want to get it the moment the app is actually mounted or the moment it's rendered by React, because we want to display the users as soon as possible. In order to do that, we leverage lifecycle methods on this component class that React has given us. And these different methods are listed here. You'll see in my dropdown. There's a bunch of them, but the most important one is really component did mount and component did update. And probably also component will unmount, but we'll talk about these a little later. We'll focus on component did mount. So component did mount is a method that you have access to, and inside you want to write your code. And whatever you write here will get run whenever the component mounts. Mounting is the first time a component gets placed onto the DOM. So the first time React renders a component onto the page, that is mounting. It only happens once throughout a component's life. The only time when a component might remount is if it's been unmounted, meaning it's been completely removed from the DOM. And you could almost argue that it's a different component. It might be the same app component or the same component we're using, but it's a new instance of it. So we'll talk more about that as well as we start building out a more complex application. But for now, just understand that the moment your component gets placed onto the DOM is when you want to make an API request for something like users, because that's when you want to get that information so we can display it as soon as possible. So remember, if you need to make an API request so that your component can have the appropriate data it needs in order to render the appropriate things, that's when you want to put it in component-did-mount. So inside of component-did-mount, how do we actually fetch from that API? Well, we're going to use the native fetch. And native fetch, what we do is we give it the URL that we need in order to get that JSON. So here, I'm going to paste that in. Again, you'll find that in your resources folder. Once we fetch this, this is going to be a promise. And a promise is something that is asynchronous in JavaScript. It's essentially a promise that eventually I'm going to have a value. We can talk more about promises in a video in the appendix where if you're not really familiar with it, it's a good time to watch that after this video so that you can get a deeper understanding. But all you need to know is that what's going to happen is JavaScript is going to fetch what data it can from here. If it succeeds, it's going to come back, and then we can call .then on that value, meaning that now we have a response back from that API request. And this, we want to pass a callback, where the argument is the response itself. So the response that they give us, let's take a quick look at it. So I want you to see what we're going to get. We're going to go to our application. We're going to open up our console. And again, it's empty because you remember I took out all the monsters, so there's nothing in our initial state. But here we got our response back. And inside you see it's just this object, and it has a lot of stuff in it. There's headers, and there's like the status of whether or not it was successful, which it was. There's the URL in which we fetched it from. But primarily what we want is we want this in a JSON format. So what we're going to say is that, okay, I want you to return from this .then this response.json. So I'm converting this over into JSON. And this is what is being returned from this .then. Every .then that returns a value is going to return another promise that has been resolved. So here I can actually say .then again, and what I have now is the users. And let's just quickly console.log this as well. So remember, whatever got returned from response.json is going to get passed to this users as the argument of our callback. So if I save this, I come here, there we see it. If I just refresh, just so you're familiar, you'll see that this is the array of the users that we got from JSON placeholder. It's exactly what we're expecting. So now that we have this, let's actually get this in our state, which we can do using setState, as we've done before. So let's get rid of this console log, and instead what we're going to say is this.setState. And here you can either pass it the object where monsters points to users, or you can use the function method. So I'm going to use the function method, and I'm going to return back an object where monsters now points to users. And the reason why I want to use this function method is just so that I can also pass it the callback when this setState is finished, just so that I can make sure that my state has the correct value. So now if we go back to our code, what we see is that we do indeed have all of our users in here. Let me refresh, and we also see that we are logging out our new state with the appropriate monsters with the appropriate values. So everything here is working. And the key thing I want you to focus on, and what we learned, was that whenever we have a component, a class component specifically, that needs to leverage some kind of API call in order to get data that it needs in order to display the appropriate UI, you want to put that inside of your component-did-mount lifecycle method. Now, there are definitely more lifecycle methods that we'll cover in later lessons. For now, though, I just want you to focus on component-did-mount and mounting of the component. In the next video, I'm going to go a little deeper into these three methods that we've seen, which is the constructor, component-did-mount, and the render method, because there is an order here that is important when it comes to how this component is getting added and React determining when to run the code inside each of these. So in the next video, we'll cover that so that you can understand deeper how a class component works. See you in the next video. Welcome back, everyone. So far we've learned quite a bit about class components. We've learned about their constructor call. We've learned about some of their lifecycle methods, component to mount specifically, and we've learned about the render. So you might be wondering, what's the order that these actually get run when React decides to initialize and mount a component? So the order I'm going to tell you is that it runs the constructor first, because the constructor runs before anything in any class. That is regardless of whether this is React or JavaScript. Classes will always run the constructor function first. Inside of here, the only thing you're really going to do with the constructor is initialize the state. So this is pretty much just saying, hey, React, there's going to be a state object for this component, and this is the initial values that it's going to have. That's all you really need to ever use the constructor for. The render runs next. And what it does is the render determines what to show. This you can see kind of as the template of the HTML. So this dictates what the UI for this component is going to be. Then the next lifecycle that runs is component did mount. Because what happens is that React is like, okay, I've run the constructor, I've initialized the state, the initial state at the very least, and I am going to now render the initial UI of this component. So it's actually going to mount this initial UI onto the DOM. So what this means is that whatever the initial state of your component is what it will mount on. Then once it mounts, it will run the lifecycle method component did mount, because our component did just mount. The moment it mounts, it runs the code inside. And here we can easily see very quickly if I console log in each space. So this is 1. This one with the render should be 2. And then inside of this component did mount, this should be 3. So if we save this, we go back to our application, we see 1, 2, 3, and then you'll notice that 2 runs again. So why did this happen? Well, let's think about what just happened. Our constructor runs, our state gets initialized. So console log 1, yes, we know the constructor runs first. Then the render runs console.log 2. This is the second thing, the initial rendering and mounting of our component onto the page. Then component did mount 3 runs. And here we are fetching some JSON. And remember, this is asynchronous, so we actually don't know when this data is going to come back. Once it comes back, we are going to now update the state. But the moment that that state updates, remember, I told you that the moment state changes and you've called set state, React knows, oh, this component's different. I need to re-render it. Re-render here is the key word, meaning that we need to run the render again. Because the moment you run the render method, React is saying, oh, let me render onto the page again with this template. And inside of this template, the state.monsters is now different. Because as we know, we've updated the state with the appropriate users, which is why you see the second 2 logged out. This is how React is going to work majority of the time with your components. By looking at just the order of when the initial render happens and another render happens once set state gets called, you now understand pretty much the core of class components and rendering. This is like 80% of what you need to know about class components when it comes to understanding the rendering cycles. So the moment that set state gets called, the render method gets called again. Because once the state is up to date, we want to re-render what this component's UI is with any new values that may be there, which we know is probably going to be the case because the state object is different. And the render is simply just going to look through this JSX and say, oh, I need to look at state.monsters. What's the monsters? Whatever the new value is. This is the key thing of understanding React and really just understanding with class components when something re-renders. And here we explicitly see step by step what that looks like. Run the constructor, run the initial render when your initial monsters value was an empty array. Then once your component mounts, fetch the new users, call set state, and once again, once set state gets called, call render again, and now monsters is the new updated users list. This is pretty much the basic flow of rendering and re-rendering when it comes to making these basic API requests. That's it. With a bit more practice, this will become very familiar, but this flow, I just want you to understand that. Constructor runs first, initialize your state, render your initial component UI. Then, once you need some API calls, do it in the component did mount lifecycle. Once that happens, you want to set state to make sure that your component updates. And once it updates, it's going to call render again to re-render the UI. That's the flow. We're going to dive deep into a lot more of these concepts, but now you understand very integrally. One of the hardest things for a lot of people when it comes to understanding React is when things re-render. But now you've seen a very common flow you're going to encounter over and over again in your React life. You've understood some of these life cycles. So this is enough for us to get started with this component. So let's start actually making this look a little bit more similar to our website. And we'll do that in the next video. Welcome back, everyone. Just so that we can keep track of all these things we're learning when it comes to our lifecycle methods and our class component methods, as well as rendering and re-rendering. I know it's a lot of new concepts that we're learning at once, which can be confusing. So just so that we're aware of the order, as I mentioned before, it's constructor, then render, then component did mount, and if component did mount updates the state, another render. We're just gonna update this console log text so that it shows us the method, so that as we build out this application, we can see very clearly what's happening. And it's really just for your own familiarity in case you get confused. So instead of console log 1, we put constructor. Instead of console log 3, we put component did mount. And instead of console log 2, we put render. So now that we have this, we go back to our application. We see that when we refresh, we'll see that our constructor runs, then our render runs, component did mount runs, then render runs, and then of course, our monsters array gets logged from our callback in our set state call. So everything here is just a recap. Now moving forward, let's talk about how we're actually going to build out this application. And in order to do that, we got to talk a little bit about what we're looking to do. So as I mentioned before, we have these different H1s that represent different monsters. Now, before we actually start styling these H1s to look more like the final product, what we want to do instead is actually work on functionality. You always want to work on functionality of your application before you work on the CSS. Because once you have the functionality in, it's easier to style afterwards. At least that's the way that I prefer to do things. So in order for us to think about the functionality, let's actually take a look at our final product. What are we trying to work towards? So here, we have these different monster cards, which represent the different monsters in our H1. So instead of H1s, we have cards, but as I mentioned, that's the styling. We're not going to work on that. Instead, we want to add in this search functionality. So what does the search functionality do? Well, let's say that you want to find Clementine Bausch. As you type it in, it will filter out the monsters that do not match in name to what we've typed in here for our string. So CLE only matches 2 cards. Clementine and Clementina. In fact, if I type out Clementine, it should get rid of Clementina. But as I remove it, it will bring back anything that does match. So this is the functionality that we want to add into our Monsters-Rolodex project. Another thing to include is also the fact that if we hit this X, it will also clear the search field and in turn also bring back all the different monsters that were loaded. So this is the feature that we want to build in. Now, before we start coding this right away, with any feature we're building, we want to think about what it is that we need to do, because only then do we get a better, clear idea of the requirements of this feature. And from there, it's the best way to start moving forward when it actually comes to planning out the code that we want to write. So what we need and what we're missing is we need an input field. And with this input field, we need to be able to insert text, so allow the user to type into it, and filter out our monsters. So let's just think about that. Given what we have, we clearly don't have the input field. So we know we need an input field somewhere. So let's start with that. Inside of this app, I'm going to use an input field. And this is just the same input field that you have inside of HTML. But one thing I want to mention is that all of these different HTML-like JSX tags that we're writing, the divs, the H1s, the inputs, or any single HTML tag that you can typically write inside of React in this JSX, it looks like HTML, but it's a little bit more advanced than that. What it is really is that it's pretty much a component that React has already included into the JSX. So just like the components that we're writing, all of these are also components. An easy way to think about this is that when you look at this app, this class app, we know is a class component. We've been writing it, and we export this out. But when you look inside of index.js, what's happening is we are importing this app from .app. So we're importing this whole class component that we're writing. And what we're doing is we are rendering it right here. But if you look at this, do you notice that this looks like HTML? Well, this does. But again, we're still inside of JSX. And the important thing to notice here is that what is happening is that this app is being written in JSX like an HTML tag, the exact same way that these divs and this H1 and these inputs are as well. And the reason for this, of course, is the fact that React has created these HTML looking components for us. For every HTML tag, there is an equal React component. And the reason why React does this is because it allows us to bind, once again, functionality to the UI. So if you think about this input, what do we want to do with this input? Because with all of these inputs, we typically have a bunch of HTML properties we can provide it. In fact, any HTML property you can think of is equally available on these React HTML components. One thing though that I want you to notice is that some of them are named a little differently, and we can see this explicitly up here in this div. We notice that instead of class, it's class name. And the reason why it's class name instead of class is because this is written in JSX. And JSX is a syntax extension of JavaScript, meaning that all of the rules of JavaScript apply to JSX because you're really just writing JavaScript with some additional functionality. And class being a protected keyword in JavaScript means that class is also a protected keyword inside of JSX. When you think about classes, we use it up here. And what it does is allows us in JavaScript to create classes as well as class components. So for this reason, React cannot just allow us to use class freely inside of our JavaScript because there's a very key functionality of JavaScript that's tied to class whenever it appears inside of JavaScript and equally inside of JSX. So keeping that in mind, that's why it's class name. So if we wanted to give our input a class, then we have to use class name. And that's exactly what I'm going to do. So here I'm going to say that class name is equal to search box. And what other input properties do we want? Well, we want to give it a type. So we want to say that the type of this input is going to be search. We also want a placeholder. So placeholder is going to be the text that shows up inside of an empty search box. So before the user types in anything, what do we want to put there? Usually with this text, you want to put some kind of text that explains what it's going to do. So I'm just going to say that it's going to be search monsters. And that text search monsters is going to show up in that empty input box when users haven't typed in anything yet. Finally, now what we want to do is we want to actually code in the functionality in order to filter down this list. So how do we do this? Well, typically with inputs, what happens is that you have a change handler that you can bind to an input. So this is an event handler very similar to our button. If you think back to our button, you remember that earlier we had a button that would change the name inside of our search field from Yihua to Andre, and we used the onClick handler. So here, instead, we have a similar handler, but every time the value inside of the search box updates or changes. And this is the onChange handler. And just like with onClick, you get to pass it a callback. And this callback runs whenever the value inside of this input changes. So what we want to do is we just want to say, okay, what's going to happen every time it changes? Well, we want to start filtering out the different monsters that we have available. And luckily for us, just like with this event handler inside of regular HTML JavaScript, with JSX, this is pretty much the same event handler. So what we're going to get back is we are going to get back an event. So for those of you unfamiliar, let's just quickly console log this event so we see what we receive. So coming back into our application, we see that we have our input field. We see we have our placeholder text, search monsters. And now if we start typing in, if I type L, we see we get this synthetic base event. This event, if you look closely at one of these properties, has an underscore React name. So this tells us it's a React event because React is in here. In typical any other events that are generated by your browser or your DOM, you would not see underscore React name. And the reason for this is because React is generating these events for us with these different methods that it provides us in those JavaScript HTML components. The reason for that is just so that it makes it easier for us to do this kind of event handling, like this onChange handler. And the reason why there's an underscore is because these are typically the kinds of properties that React adds to these events, but they're not for us to access. We shouldn't be accessing anything with an underscore. Generally, everything else, though, we do want. And the main thing that we want is target, because inside of target, other than all of these other keys and values that you could use, these are going to be mainly valuable because of this value. Inside of value here, you see is the string L, which is what we have typed. Now, if I continue to type E in the next event, if I check in the target, what we see is that the value is LE. And similarly, if I type another A, we see that we're going to get inside of target and value LEA. So we know that with this, we're now able to actually get the value. Now, this is going to be my challenge to you. Knowing that we need to use the event.target.value, I want you to take this and actually try and filter down this list of monsters. We've done something very similar already. We know that we need to use this handler to update our state object or our state array for monsters. What you have to do is figure out how to use this in order to filter it down. And to give you a hint, there's actually an array method called .filter that you can leverage for this. I'm going to include in the resources folder a link to .filter so that you can take a look at it, but I want you to try and implement it yourself. Implement a way where as you type, you will filter out these monsters. So good luck, and we'll do it together in the next video. Welcome back, everyone. In the last video, I issued a challenge to you in order to figure out how to use this event we're getting back from our onChange handler inside of our input in order to filter out the list of monsters that we have stored inside of our state. Here, what we're going to do is do this together. So we know that event.target.value gives us the string that is typed into this search bar so far. So what we need to do is we need to filter down this list of monsters into a list of monsters that have names that match this event.target.value. So here what I'm going to say is I'm going to initialize some kind of variable called filtered monsters just so that we know exactly what it is that we're creating. And I'm going to say this.state.monsters.filter, and .filter is very similar to .map in the sense that it gives us back a new array. And what that array will contain is going to be a list of elements where it's run this callback on every element in that array. So here we know that monsters is an array of these different values that have a name on them. So let's just say, for example, we have Leanne and we also have Yihua, just as an example. So of course our array is bigger, but I'm just going to use these two for example. What's going to happen when you call .filter is that .filter is going to receive a callback that you give to it, and it's going to pass and call this callback on each element, the same way, left to right. And based on what the return of this callback is, whether it's true or false, so it's expecting a Boolean, it's expecting true or false. If it's true, then it will keep that element. If it's false, then it will take it out. So what will happen is once filter runs this callback on all of these different elements inside of the array that you're calling it on, it will give you back a new array. So here, let's say that with .filter, what we know is that the first argument, just like we saw before when we called .map, the first argument is going to be the element itself. And I'm just going to call it monster, just for my own sanity. And here, we're going to say that monster.name, so give me the name. And what we want to do is we want to think about how we're going to actually check whether or not the text we have is included in this name. Luckily for us, with all strings, we have a .includes method. And I want to say that if it includes event.target.value, meaning that if the name includes the string, then what I want you to do is I want you to return true. So luckily for us, includes is a method that returns a Boolean as well. .include returns true if this string includes the string you pass to it, meaning that if the name includes the search string, then return true. If it doesn't, then return false. And what we're saying is that when you filter over these monsters, if this monster's name includes the search string, then keep it. If it doesn't include it, then get rid of it. And here, filter monsters will give us back a new array. And the reason we want a new array is because similarly with our previous example, when we were looking at React with those objects and our state objects, you remember with our object, if we modify the object, React can't actually register that it's a different object. Similarly, with arrays, it's the same. If you increase or decrease the number of elements inside of an array, meaning you add more or you remove to it, this is still the same array in memory. It behaves very similarly. Now, React doesn't really care about this as much because it's really just with the state object that it checks. But as a general best practice, you always want to use non-modifying methods, meaning that if you're going to modify an array, you want to generate a new one. Chances are you don't want to modify the same one. And this is a concept called immutability, and it's a general best practice. So most of the time, remember, if you're going to modify an array, create a new array with that modification. And there's a series of these different methods on arrays that are helpful. .map is one, .filter is one, and there's another one we're going to learn later called .reduce. So here we filtered out this monsters array. And now what we need to do is we actually need to set the monsters to this new filtered monsters. So here we can just say this.setState is equal, again, to this function. And we're going to return back an object where monsters is filtered monsters. And here, very explicitly, this is exactly what's happening. And if we save and we check back here, now if we type in LEA, we see that we're filtering out. Now you might be wondering, why is it that this first name monster of Leanne is not here? Sorry, let me refresh. You notice that as we typed in LEA, we expected the capital Leanne. Well, the reason for this is because includes is not case sensitive. In order for us to make this case sensitive, we actually need to lowercase all of the text that we're typing in. So here what we can do in order to actually make this handier for us is let's actually cast this into a variable. So let's say search string is equal to event.target.value.to lowercase. So to lowercase is a method on all strings that lowercases them all. So no matter where there is a capital, it will get lowercased. So if you have a string that's like A like this, when you run to lowercase on it, will give you back a string that's like this. So that's really handy for us when it comes to any kind of searchability. We just want to lowercase everything because most of the time, people don't search with the idea that it's case sensitive. So now that we have our search string, we want to do the same thing to .name. We want to lowercase the name. And then on that lowercase string, we want to check to see if it includes our new lowercase search string. And now if we save this, and we go back to our application, if I type LEA, we see that it works. So this is the beautiful thing now. Everything is working for us. But what you'll notice again is as you remove characters, why is it that this array of monsters is still what we had filtered? I want to give you a second to think about it. Really think about what's happening here. And in the next video, we'll cover it together and how to remove it. If you want to take the challenge, in fact, and you figured out why it is that even as we removed the different strings, we didn't get back the original list of monsters and you want to try and solve it yourself, please try and take a stab at it, because that's the best way to learn, is to really try and figure it out yourself first. But once you've hit a point where you've ever figured it out or you want to see the answer, join me in the next video and we will implement this together. Welcome back, everyone. In the last video, we learned how to implement a search bar into our application, and we learned how to filter out these different monsters that we have based on what gets typed in. However, what we noticed is that while we did implement a case-insensitive filtering system, the problem is that as we get rid of the characters, we are left with this filtered list. We cannot get back a new list based on the characters that are actually in the search bar. Why is that? So let's go back to our application. When we look at the code, what we'll notice is that we are directly modifying this monsters array. However, whenever this change event happens, we are just using the current monsters array, meaning that every time we're filtering, we're not filtering off the original list of monsters. We're filtering off of the currently filtered list of monsters. In case that is a little confusing, let's make this clear by console logging this out. So here I'm going to console.log. I'm going to say that this is the starting array. Actually, let's make this more clear. I'm going to make an object, and I'm going to say starting array goes to this.state.monsters, because this is the monsters array in our state that we have when this event first fires. And then what happens is we modify it. So following set state, I am going to pass it a callback once the state is updated. And here, instead of calling it starting array, I'm going to call it ending array. And this is just easy for me because using this object, we see these keys. So if we go to our code, what we see when we start typing, L-E-A, we notice that when we went in the first time for the L, we saw that there was a starting array of 10 and then an ending array of 9. And then when we typed the E, there was a starting array of 9 and then an ending array of 5. And then finally, when we typed the A, we had the starting array of 5 and the ending array of 1. So this is expected because we're filtering down the list to 1. But now, as we remove, what we notice is that our starting array is 1. Every single time, the starting array is the same array as our filtered list. So no wonder we're not getting back all of our monsters from before. We don't have that stored anywhere anymore. That list is completely gone. So this actually brings us to a very important best practice. If you are going to modify any kind of data inside of your state, such as filtering it out based on user input or whatever, if you're going to go back to it, and most of the time you want to go back to it and at least keep some kind of reference to that original list, what you want to do is you want to actually keep your state equal to the original list of whatever it is that you're keeping track of. So for us, it's the users. We want to keep that original list as users. We don't actually want to modify the state and use that value. Instead, we want to filter that value and then pass it into wherever we need it to be. So how do we do this? How do we modify our code to do so? So here, what I'm going to do is get rid of these console logs. And what we're going to do is we're going to keep this search string, because this is still useful. And we're going to keep this filtered monsters list, because essentially this is a new array. Remember what I told you, .filter gives you back a new array. That means that this .state.monsters is untouched, because any filtering happens in the new array we get back. The original array is completely unmodified, and this is exactly what we want. The question now is, with this filtered monsters, how do we actually use it inside of our rendering? Because we now want to render this filtered monsters list. We want the same functionality we had before, except instead of accessing on the state, we want to access it where we filtered it. Well, this is actually where we should move some of this code out into the render, and maybe this will make it more helpful for us. We can either move it out of the render, or we can move it out into a method. And there's a little bit of optimization here that we're going to have to talk about. But first, what I want to do is let's just move it out into this render, because it's the easiest way. So what we're going to do is we are going to create this filtered monsters list out here inside of the render, but outside of the return. So here I have access to filtered monsters. But the problem is I don't have access to search string. And in order for me to get access to search string, I need access to this event. So what we should do is we should actually store this search string value inside of our state, because then we have access to it anywhere in our component. Right now, this search string is only available inside of this callback, but not actually inside of our component. So in order for us to get access to it in our component, we need to move it into our component. And the best way to do that is to put it into state. So inside of state here, I'm going to say there is a search field. And this, to start, as I mentioned before, is equal to the null case or the empty case of what this will be. And this is going to be a string. So the empty case of that is an empty string. Then what we're going to do is we are now going to get access to this search string value. So what we want to do is we actually want to update this in our set state. So instead, in our onChange of setting state of monsters, we're going to update this search field. So here I'm going to change this to search field instead of search string. And by doing this now, I can get rid of that code. And this is just a quick shorthand when you're writing objects. If you use a variable as the only field, then what JavaScript is going to do in ES6 is it's going to say, oh, okay, you know, the key is going to be the name of this variable and the value is going to be the value of this variable. And by doing this now, we are updating this search field value. And here, what I'm going to do is I'm going to change this now to our newly stored this.state.search field. So now filtered monsters should be using this state search field because we're updating it in the same way. So you'll notice that we're just moving some things around. And instead of mapping over this.state.monsters, let me just map over filtered monsters. So if I save this now, here you'll notice that we have our original list of monsters. And then I'm going to say LEA. So this filters out as we saw before. But now as we type back, we get back our original list. So everything now works the way we want it to. Now I know we covered a couple bigger concepts in this video, so some of this might be a little confusing, and that's perfectly fine. Let's just quickly go over what we did. What we knew was that as we were filtering monsters, we needed the original list of monsters to display because any future filters that we wanted to make should be made on the full list of monsters. It shouldn't be made on the filtered list of monsters, especially when we start removing characters and we want to get back to that state of our original full list of monsters. So remember, whenever you're filtering down a list, you always want to filter from the full list. And if that's the case, what you want to do is you want to keep track of that somewhere, and the best place for that is in the state. So after you've updated state with the full original list, don't modify that. Modify that somewhere else. Inside of our input, because we want to access that input value, we want to store that somewhere where the rest of the component has access to it, not just in the callback. Because remember, with JavaScript, all of our variables are locally scoped. So with that in mind, what we need to do in order to make that more accessible to the rest of the component is we have to move it to something where the rest of the component has access to, and that is the state. So what we did is that we stored the value that we wanted. So we don't store the event, we store the actual thing that matters for us, which is just the string. And we want to modify it in a way where it's useful for the rest of the application, which is where it's lowercase. So here, what we're doing is we're storing that inside of our state. So once we have this search field, now inside of the render, we are able to filter it down from the original list of monsters using the search field. There's a couple little optimizations that I'm going to show you in the next video, and we're going to deep dive into that so that you can learn a little bit more about the render cycles, about React and these class components. Join me in the next video where we'll talk about that. Welcome back, everyone. So in this video, I want to talk a little bit about some of the optimizations inside of React and the best practices around these optimizations. But at the same time, I want you to understand more what's happening whenever React is rendering the code that you write. So bear with me here. We're going to get a little bit into the weeds of JavaScript, but we're really going to come out of this as better developers. When we look at this render method, every time React needs to update the DOM, it runs this render method. Inside of this render method, I want you to focus specifically on this onChange callback that we've written. This here is called an anonymous function. And an anonymous function is a function that is not stored anywhere in a variable. What this means is that when JavaScript runs this code and it comes across this line, what it sees is that there is a function being created. So what it will do is it will create this function for you. But what happens afterwards is that it gets thrown away. And the reason why this is significant is because every time render is being run, this function is getting reinitialized. It's getting recreated every single time render runs. Because once it's done with it, it throws it away. So there's actually nowhere in memory that's keeping track of this function. The reason why this is problematic is because, technically speaking, we actually never update this function. What I mean by this is that, yes, the event value will change, but that is the event value. That's not actually the function itself. If you think about it like this, the event is being passed into our function, but our function is not getting rewritten. Even though we're referring to this event, JavaScript is smart enough to know, oh, this event is not something that this function is controlling. In fact, the only thing about this function is that it doesn't change. And as a result, every time we are reinitializing it, we are actually making our app a little bit less performant. So with just this one function, your performance is not going to see any hit at all. And we're going to do a really deep dive into performance and in performance optimizations in React much later in the course. But what I want to do is I want to explain to you some of the optimizations and the reasons why we write code the way we do. Because when it comes to just one function, this is perfectly fine. But when you have a lot of them, then your component really starts to slow down. So in general, this is a needless performance risk that we don't have to have. So what we do in order to improve this with a class component is we move this method out into the component because this is a method related to our component. Specifically, it's related to our search. So what we can say is we can create a brand new method on our component called onSearchChange. And this is going to be the callback itself. So everything here for this callback, we can just copy like so. And now what we need to do is we can just pass this onSearchChange right here. Or we got to say this dot onSearchChange because it's attached to our class now. And now if we save, we go back to our code. As we type, we see that everything still works. So this is just one of those things where if you think about onSearchChange, this class component is only going to build this function once when it initializes the class for the first time because it's a method. Once that method is initialized, whenever render runs, right now it's just always going to refer to this method that's already been initialized. It's not going to just reinitialize an anonymous function over and over again every time render gets called. That's the difference in what we've just done. So this is just one of those optimizations we can make. Another optimization we can make is that instead of just calling this everywhere, we can actually use destructuring in ES6. And destructuring is a big benefit for this exact reason. It makes our variables look shorter and it makes things easier to read. So what we can do at the very top here, inside of our render, is we can say, I want to initialize a constant and I want to pull it off of this dot state. So inside of this object, what I'm going to do is I want to get the monsters and I want to get the search field. And I also want to get off of this onSearchChange. And what we've done here is we have pulled off these different methods and values that were originally on this dot state, and this, and we've cast them to variables. And now what we can do, instead of calling this.state, is I can just say, give me monsters, use the search field, and then use search change on search change. This is actually mistyped. There we go. So now if we save, when we go back to our application, we see that everything still works the same way. So here we've performed two big optimizations. The main benefit of this optimization is that it's more readable for us. When we look here, we see that these variables are being initialized, so we know what we're getting off of this.state and off of this. So later on, when we see these values, we know where they're coming from. And the other optimization we made was that we made our app a little bit more performant by not unnecessarily rendering extra anonymous functions whenever the render call is being called. Instead, we've moved it up into the method, which only gets called and initialized once when our class component initializes. So just a couple quick improvements to our code now. And hopefully this actually makes it seem a lot more readable to you as well. Because as you're looking through your code and you're looking through these methods, you are looking at all the things that are getting involved. You see this on search change, and now when you read this input, you see, oh, this is on search change. You don't have to read through an anonymous function here. You just know that if you were to care about what it includes, you could go look at it when you need to look at the method. Otherwise, it's also a performance improvement. So with this, we have now improved our application and we've added our search feature. In the next video, we are going to start implementing some of the other improvements to the application. Primarily, we're going to start moving some of these different features out into a component architecture. And with that, we're going to talk about the folder structure. So it's a lot of very interesting things. But if you're confused about any of the improvements we made here, please watch this video again and really try and understand what it is that's happening with that anonymous function and these renders. We'll definitely bring this up a lot more in future lessons as well. But this is a good time, I think, to introduce this concept because moving forward, we're always going to write our code this way. So hopefully you understood that, and let's move on to the next video. Welcome back, everyone. In this video, we are going to really deep dive into components and understanding what components are conceptually. We're going to take this concept into our application so that we can understand how to leverage this concept of components so that we can write a more scalable, maintainable, and reusable web application inside of React. So what is a component? We've already written one component, which is our app component. It's a class component, but it is a component nonetheless. And so far, let's quickly recap what we know about this component that we've written. This component right now is something that governs a piece of the UI. For us, this entire application, everything you see, so all of this UI, is all encapsulated inside of this app component. What this means is that our entire application lives inside of one component. But if you really think about the concept of it, what we've done so far in our component is that we have tied together the functionality of the UI with the actual UI itself. And that is what React does. If you remember in the early lesson that I was teaching, was that React is really just a way for us to tie together the visual representation of the UI and the functional representation of the UI. It ties them together. But that's what the code does. What about this concept of a component, though? We know that a component is meant to tie together functionality and visual representation of our user interface. But what it also aims to do is it aims to tie together reusable portions of the code together into one segment. And what I mean by this is if you look at our application, we really only have two features. We have a list of monsters, and we have a search bar that searches through those monsters. Technically speaking, these two parts are the two features that encompass our entire application. However, if you think about it deeply, this list of monsters can be a list of anything, really. The concept of a list alone is just a concept. You can have a list of monsters, you can have a list of cars, you can have a list of homes, you can have a list of anything. Similarly, a search bar is just a field input that takes some text, and then we do something with that text. In our particular application, we filter the list of monsters with that text. But you could also take that text and do something else with it. You could use it to actually filter through a completely different set of articles. You can use it to search for a specific website, as Google does. But the idea is just a search bar really takes some text and then does something with the text. The reason why I'm trying to generalize these two features is because that's the idea of components. You want to try and figure out if when you're creating a component, you can genericize the functionality of that component as much as you can so that it becomes as reusable as possible. And by thinking about components that way, you're able to build your application so that you don't have to rewrite a lot of code, because that's the most important thing about our code. We want to be able to create Lego blocks. We want to be able to build these reusable bits of code that we can use in multiple places. But we want to use them in a way that makes sense, where ideally it has a single responsibility. So let's think about what that means. And we're going to learn about that a lot. That idea of a single responsibility throughout our components. It's very general and it's very abstract. And it's something that really comes to you as you build a website, and it varies from website to website. But through good practice, you'll really come to understand this. And throughout the course, we're really going to develop this concept. But if you think about it right now, let's think about that concept right now. Inside of our application component, our search bar and our list of users is completely tied together. If in our application, for some reason, we wanted to reuse this list component, we can't do it because we automatically get a search bar with it. This becomes evidently clear when we look inside of our code. Right now, our search bar is tied to our filtered monsters list through all of the code that we've written, and it all lives inside of our app component. We're not actually generalizing the feature of the search bar or the list of users. So what we need to do is we need to start generalizing them. And by doing that, we're also going to understand more about components and how these components re-render. So let's get started doing that. Let's first generalize a component that makes the most sense for us immediately and the easiest way, which is this list of monsters. Now, before we actually start figuring out from a coding perspective how we're going to do that, there's one very quick thing I want to highlight, which is the fact that what we need to now understand is our folder structure. So inside of most React projects, you do separate the files that you have into different folders by their responsibility. And one of the most common patterns you'll see across React projects in terms of their folder structure is they will create a folder that holds all of their components. And usually that is the components folder. Depending on the size of your website, these folder structures may evolve and adapt according to what your senior architects who lead the projects are going to figure out. But there's a pretty general pattern that we're going to follow for all of our projects in this course. And they're going to give you a good idea of how to make that decision and how these decisions do get made when it comes to figuring out the folder structure. So for this one, the most common one is we know we want to start building out components, and we want those components to encapsulate functionality. So what we want to do is we want to make a folder that's going to hold all of our components. And if we really think about what it is that we are creating right now, our very first component, looking at the actual feature that we just spoke about, this is going to be a list of cards. So that's really what this component should be. It's a list. But in this particular case, the final output of this is a list of cards. So that's what I'm going to make a new folder that's going to hold this component to be. It's a card list. So again, that is going to be how we're going to make the next folder as well, which is to encapsulate our second feature, as I mentioned, which is the search box. So here, inside of this components folder, we are going to create and add into it all of our components, and each component is going to live in its separate own folder. So we're going to have a components folder, and then we have a card list folder, which holds our card list component. We have a search box component, which is going to live inside of the search box folder. And then any future new components we make, we're going to make a new folder for that general component inside of this components folder. So that's the idea around components and breaking them up, and then how they live inside of our application. And in the next video, let's actually start moving our card list into its own component. Welcome back, everyone. So let's actually start moving this card list section of our code into this card list folder. So let's talk about the file. What we need to make is we need to make a component file. So here I'm going to say card list.component.jsx. Now, depending on your project, or depending on the files you look at when you are out there reading other React projects, you may see that this file is called instead index.js inside of a card list folder. You may also just see card list.jsx. All of these are valid ways of naming a file. It's just how you decide to do it for your project, or how your senior architect decides to do it for your project, so that it's easy to navigate. Personally, I like card list.component because it's very clear to me when I'm searching through files using the global search function what I'm looking for. I can just say I want the card list, and I know it's a component. Now you might be wondering, well, isn't it inside of the component folder? As long as you find the card list file inside of the component folder, isn't that going to be the file? The problem with this is that there may be numerous files inside of the card list that are all related to the component. This might include styling files, this might include test files, this might include a plethora of other things. Again, depending on how you architect your application's folder structure. For me personally, this is the way that I prefer to do it, and it's really easy for me to search, and this is what I prefer. So this is my justification for why I name my files this way. I picked this up when I was coding on Angular projects. Angular has this type of naming convention, and I thought this was a really great way of navigating through files, and I've just kept it and moved it into my React projects. So here, inside of our card list component file, what we need to do is we need to bring in the relevant component, which is, again, our class component that we get from React. So we're still writing our class components, even for our card list component. You might be wondering, well, Yihua, what about functional components? We'll learn about functional components and how to convert this whole Monsters-Rolodex application over to functional components once we finish with our class components. Right now, I still think class components is the best way to really learn about them to begin with, because you will see them in projects. And also, it's easier to understand how React does rendering and the concept of rendering overall. Class components to me are just the most clear, again, because of those lifecycle methods. So here, what we want to do is we want to initialize this card list component, as we did with our app. And as we saw, we want to extend our component. And then once we have this, what we want to do now is just render something, just so that we can make sure that our component is working. So what I'm going to return is a div. And inside of this div, I want it to say, hello, I'm the card list component. So let's just save this. And what we need to do is we need to export this. So I want to default export this. And what exporting does is it allows other files to import the code that you write inside of it outside. So this way, what I'm saying is that, hey, I've got this class card list and I want you to export it by default. Meaning that if they don't try to destructure from the file in order to access other things, by default, give them whatever this is, which is our card list class component. So then what I'm going to do, I'm going to go into app.js and I'm going to import it like so. So I'm going to import card list from, I'm going to go up to the components file, into the card list folder, into the card list component file. And now we have access to this component. And as I mentioned, we can use these components the same way that we use any other of these components. Input, divs, they're all components. Except now we have card list. So one quick thing to note, all of the components that you write, unlike these other components that React has given us that resemble the HTML tags, ours must always be capitalized as the first letter. So it's camel case in the sense that every subsequent word needs to also be capitalized, but the very first letter also needs to be capitalized. This is how React can see, oh, this is a component that is made by the actual developer. So now that we have our card list, let's just save and see what we see. So inside we see, this is our component. Hello, I'm the card list component. So we know our card list is working and it's rendering onto the page. Now, before we proceed any further, I want to highlight one thing about components. Inside of our component so far, we have returned one element. And what I mean by one element is the sense that even though our components might have a lot of HTML inside of them, this component is just one div. But you can imagine that if inside of this div, we had perhaps an H1, and maybe as a sibling to this H1, we had another div. Let me just structure this so it's more clear. And maybe inside of this div, we have a p tag that has some text. And then maybe beside this, we have some other components. This is all perfectly valid. But the thing to remember is that technically this is all encapsulated in one parental component or parental HTML tag. This is an important thing to remember because all components must be just the one component or the one parent level holder HTML tag. If you have siblings, this is actually going to give you an error. You'll see that here, all this is highlighted. Now I turned off highlighting because it gets annoying when I'm teaching and you see all of the different text fly up. But this is a very important thing to note. You cannot have multiple different components at the same level returned from a component. You must have one parent level component. Now there are some ways around this, which I'll show you in a later lesson when we talk about more, I guess, complicated ways of rendering different components. But for now, this is a very good rule of thumb, is that when you return a component, make sure that there's only one top level component that you're returning. So now, again, we understand that our card list component is rendering. We've put it into its own file. What we need to do now is get the monsters that we had before into this component. And we're going to do that using props, which is going to be a new topic with our components. And that's what we'll cover in the next lesson. Welcome back, everyone. So in this video, let's talk about actually getting these monsters that we want to pass into our card list so that it renders into the card list. As I mentioned in the last video, you're going to do it with props. So what are props? Props are pretty much shorthand for properties, which is identical to these different properties that we've already used inside of our other components. Class name, type, placeholder, onChange. These are all props of input. And input, as I mentioned, is a React component that simulates and generates a input HTML tag when you actually render it to the page. So similarly, we can pass these monsters into our card list as a prop. Now you might be wondering, what is the name of the prop? Because all these other props that we see are props that have been predefined for us. As I mentioned, onChange is one that React has actually already placed onto this input component so that we can trigger onSearchChange or any other callback that we want to pass to it whenever there's a change event on this property. The difference with other props inside of our components that we write is that we can name them technically whatever we want. But we have to make sure that what we pass in is the same thing as what the component is expecting. So what do I mean by this? Well, technically you can pass whatever you want. Let's say, for example, I want to pass these monsters through, and I want to call it monsters. This monsters will actually pass. And the way that we can check what I'm going to do first is I'm just going to pass into monsters a string for now. And it's just going to say, I am the monsters. I'm not going to actually pass the array through because I want to show you what's going to happen. Now, inside a card list component, we can actually access this as a protected keyword on this. So remember, this references the actual class component itself. And here on this, React has given us this special keyword props. And props will log out all of the props that you have passed this component inside of an object, where the key is the name of the prop and the value is the value of the prop that we pass to it. So I'm going to save here, but I'm also going to remove all these other console logs so we're really clear about what it is that we're seeing. And just in case, I'm also going to remove, I think there's one more right here. I'm also going to remove the additional callback that we passed to our set state. So now we should just see what happens inside of our component. So here you notice that what we logged out was an object where the key is the name of the prop and the value is the string that we passed to it. For now, I want you to ignore the fact that it's logged twice. We'll talk about why that's happening a little bit later. But for now, just look at this object. So any props that you pass into this component, you will see it inside of this object. So let's just quickly test this theory out. Down here, I'm going to make another value. And I'm just going to call it anything, just so that I can prove to you you can pass in anything you want. And I'm going to pass it an array where inside is a string A and Z. If I save this, I go back. Here we see that there is our new prop that we passed in, anything, with an array that contains A and Z. So this is how you can access props and pass props from one component into another. One important thing to note here now is that because we can pass anything into our props, we can now pass in our monsters. So we want to take a second and we want to think, what do we want to pass into this list of monsters? Well, this is where it's interesting to think. Do we pass in the filtered monsters or do we pass in the full list of monsters? Well, as we know, this card list component should only display the monsters. The card list itself shouldn't really have to think about how it's going to filter because that's really actually up to the search box. The search box is the one that actually modifies the monsters that are being passed into this. For this reason, there's no reason for us to tie that responsibility together. Instead, all our card list cares about is what am I going to have to display? And what that is going to be the array of filtered monsters. Now let's save and go back to our project, clear out all of this, and refresh. And what we see we're getting in is our monsters array. And as we type, we should see that this will continue to update and give us the correct list of monsters. So even though we can't see it visually, as we type in our letters, we do see that the only monster we're receiving is the one that matches the LEI string. So everything here is still working as expected. In fact, as I erase, we're getting back our full array of monsters. So here again, everything works. Now what we want to do is we actually want to render these monsters. So what we're going to do is let's go into this component and let's actually just do the same thing we did before. So we know that what we're getting back is the monsters. So I'm going to say const monsters. So I'm destructuring off of this.props. And the reason we destructure is because if we need to use this in more places than one, it's just easier to do so. And now I can just say monsters.map, the monster, and just render back an h1 where the text is monster.name. And if I save this, we go back, we see here we have it. Again, we have that warning with the unique key prop. So let's go back and make sure we have it. And here we're going to say monster.id, which we remember was what we used before to keep track of the unique keys on these h1 tags. And if we clear and refresh, we see that it's gone. And again, if I type in, everything works as expected. So just like that, we now have a card list component that replicates the same behavior we had before. One quick thing to note. What I want to do is I want to console.log here render. And I want to go back to what we were talking about before, where what we noticed is that when we refresh, we see that the render is called twice. And here it actually has to do with the way that React renders components. I want to talk about this in the next video, but I want you to take a second to think about it. If you can come up with an answer that's at least pretty good, because it's really important here that you think and try and piece these things about how React renders together while we're learning this topic. This way you really get to think and really try and understand based on the way that React does things that we've learned so far about why it might be doing these things. So once you have an answer or once you've thought about it a little bit, join me in the next video and let's break down why in our component we see render twice. Welcome back, everyone. In this video, we're going to talk about re-rendering inside of components, and we're also going to understand how it extends into this new component structure that we have, because now we have two components. So when we first looked at our component, before this was saying console.log render. I've updated this to say console.log render from card list. And I did this just so that we can be clear that the render log is coming from the card list component. Here, what I'm going to do is I'm actually going to comment this out for now. We're going to use this later. But outside of that commented out console log, there's no more console logs. So going back to our application, if we refresh, what we see is that we're calling render from card list twice. Now at this point, I want you to pause and think about why this might be happening. Really think about the flow of all your components. Once you've thought about that, let's explain why this is happening. Render is getting called twice inside of our card list component. Before, when we looked at app.js, when do we see that render gets called? Render gets called when we initialize the application, because constructor gets called first, and then render gets called. And then when we called component did mount and we actually did the fetch, we call a set state. And remember, whenever set state gets called, render gets called again. So we can predict that if I just comment out that and we just look at this render from app.js and I refresh, we saw that we initialize the app, we call render from app.js, and then component did mount happens, and then we do the fetch, we call the set state, again, render from app.js happens. So we know that set state will trigger render from calling. However, components will also re-render when props change. And this is a very important thing because it's just like set state. Whenever props is different, our components will also re-render. So how does the props change inside of card list? Well, let's console.log this.props, and then let's just console log our actual value inside of props so that we see. Let's refresh. When we first render our card list, we are getting past an empty array. This is the initial state value inside of app.js of our monsters. It's an empty array. That is being passed into card list initially. So card list is getting rendered, and it's getting rendered with an empty array. And then what happens is that we call set state with the full list of users in our component did mount. And here, that's why we see the second time that this array is now a full array. Well, how does React actually know, oh, I've got new values? I need to probably re-render in case the UI is based on our props, which is exactly what's happening. This is why all of these are now updated. Because React is saying, oh, I have new props. Let me re-render the component with the new props. Our props, as we know from our code, directly actually gives us the new monsters. We map over the monsters, which is our props. And that's how we see the UI update with all of these monsters. This is an important thing about components. Components re-render based on two conditions: when set state gets called and when props are updated. This is how primarily React determines that you want to re-render, because only when those things happen does React actually update the DOM and try and see, oh, what are these components and what are the new things that we need to return from them. That's why you see render from card list get called twice. And this goes into a deeper thing when we think about this new component tree. When I say a component tree, what I mean is that you have these parent components and inside there are child components. If we think about it, React always renders from the top down. So what do I mean by top down? If you look at index.js, index.js shows us the very top level component, which is our app component. So what it's going to do is it's going to attempt to render the app component first, meaning it goes to the constructor and then it calls the render call of our app.js. When it's going through render.js, it goes line by line, runs all of our code, and then it goes into this return. And inside here, it now sees card list. Once it sees card list as a component, then it's going to try and run this card list component's different lifecycle methods. So from the card list component, it's going to call the constructor, which even though we haven't written it, it's running it under the hood. And then it's going to run the render and actually render out what's inside. If we had another component here, imagine we have a third component and we call it third component. At this point, after running through the render and the constructor, then it's going to go into another component and it's going to do the same thing. It's going to run this component's constructor, this component's render, and any subsequent children are going to do the same thing. So it's going from top down. And this is the idea of a component tree, where the top of the tree is your parent component, and then each level down is any children that there are, and subsequent children, and et cetera, et cetera. We'll definitely talk about this more, but this is the way that React renders things. So very important thing, remember, React renders on mount and it re-renders whenever props change and set state gets called. And here we've seen two examples now. We've seen set state where we're calling it and we saw the render get called. And we're seeing when new props come in, render gets called. So that's a very important thing to think about when you're looking at your components and thinking about how do I update my components? Well, that's how you do it. You either have to make sure that set state is getting called and you're updating the state, or your props are changing. Those are the main ways that you want your components to update. If your component is not updating, then you're probably not either updating props or using set state. So we'll talk about how to leverage this when we want our UI to update, when we make changes and we build complex applications. But this is a very important groundwork to understand about how React determines when it needs to re-render the application and it needs to re-render components. So hopefully now you understand at least the basis of how these components render and re-render. This will get us through the majority of a lot of the rest of building this application and future applications. We just really need to understand this about React and these components rendering and re-rendering. So now that we understand this, let's build out the rest of our application. Welcome back, everyone. So in this video, let's actually move out another component that we were talking about, which is our search box. So here we already have our search box folder. So let's just do the same thing and create a new file called searchbox.component.jsx. Once again, we want to make sure we import component from React. And then we're going to initialize our class searchbox, which extends component. And then inside of our render method, we want to return the actual HTML related to our search box. So here, I'm just going to cut this out. Go back here, paste it in. And before we actually figure out how we're going to get this into our component, let's just make sure to also export our component, just so that we remember to do this when we need to actually access this component from the code that uses it. So similarly, let's talk about props again. We know that this input is supposed to be a generic search box component. What it does is it takes some text and it does something. What that something is, we don't really know. However, here, how do we genericize what this input is? Well, there's a couple things here. What are some of the props of a search box that we know we want to change? And what are the ones that we don't want to change? Well, we know that we want to keep the type search. If this is a search box component, we want to use a search input. Now, if you're unfamiliar, what a search type on this input does is it turns our input box into an actual search box one. And what that does is it allows us to actually generate this little X button. So when you hit it, it actually clears out the text. So automatically it builds that into the feature for us. If we did not have that, we would not be able to actually have that X. It would just be a normal input field. So that's why we know that if we're doing a search box, we probably want that feature. So we want to keep this type search. But what about everything else? Everything else, we probably want to make sure that they can be dynamic, because we probably don't want the class name to be search box for every single search box. That's not specific enough. You can imagine that if an application has multiple search boxes, in order for us to be able to distinguish search boxes from each other, they might need different class names. So what we can do is we can actually use another feature with props. But before I talk about those ones, let's just make sure that we first just enable our onChange as well as maybe our placeholder. So what we're going to do is we are going to first look at this onChange. OnChange is a callback that runs whenever change happens on our input. What that happens is up to the component that's trying to render the search box. Now you might be wondering, should we bring in this search field text into the onChange? Well, let's think about that. Where are we actually using this search field state? We're actually using it inside of our app component. We're filtering down our monsters from the search field. So that means that because this app component utilizes the search field value that our search box actually has in order to determine what it's trying to do, which is to filter the monsters, we actually need this string stored inside of this level. Now, there's different patterns that you can do this, but this is a good way of thinking about with React components. So that means that what onSearchChange is, as far as for our search box component in the current context, is it is just supposed to update app.js's state search field value. And that's exactly what our onSearchChange method here does. So we want to pass onSearchChange into the search box component. So let's think about what we're going to name this prop inside of our search box. We know that we're attaching it to the onChange of the input prop. So what this is it's an onChange handler, because that's the function. We're passing a handler function, an event handler. So what we can call this is exactly that. It's an onChange handler. This.props.onChange handler. So let's just comment this out for now, and let's just make sure at least this is working from what we've, again, just defined. So I'm going to default export it out. I'm going to copy search box. I'm going to go into app.js. I'm going to import it from the respective file. Import search box from components -searchbox-searchbox.component. I'm going to copy search box. I'm going to go down to where it was before, and then I'm going to pass onChange handler, which is equal to onSearchChange. And now if I save this, let's go back. What we see is that because we commented out our placeholder, there's no placeholder. But if we type in, we see that our application still works as expected. Amazing. So everything here is working. Now this placeholder text. We know that with a placeholder text, this might also change. This search box is supposed to be a generic search box. Just because in this particular case, we're searching for monsters doesn't mean all our search boxes are going to say search monsters. So this is another property that we probably want to change and make generic. So I'm going to do the same thing. I'm going to say this.props.placeholder. And similarly, let's just make sure that this works. And I'm going to say placeholder, which is equal to search monsters. Actually, I don't need these squiggly brackets for that. Let's just say search monsters. Let's save this. Go back and see. There it is, search monsters. Everything still works. And finally, for class name, let's do the same thing. We can here say this.props.className. And then similarly in app.js, we do class name is equal to search box. And now if we save and we go back to our application, let's just make sure that class name is being applied. It is. So everything here works as we had it before. Now, one quick note is that you may be wondering, why are all these other props named the exact same as the base props, such as class name and placeholder are the same prop name as the one in input, whereas here for onChange, I call it onChange handler. You can call it onChange as well. In your props, you just define them the same thing. I just prefer to do it this way myself, so it's a little bit more explicit for me, especially when I'm writing my own components. But again, it's a personal preference thing. It might just be a little bit of a tick thing. It's entirely up to you if you want to keep it the way that you keep it. People will sometimes write these a little differently. just based on the preference. Honestly, a lot of these standards of how you name your props is kind of going to be set on a project by project basis. Sometimes there are different rules depending on who is the architect or the senior developer and what they want to set it up as for consistency across the code base. This is just my personal quirk, is that all of the change, if I want to name an event handler as a prop that I'm passing in, I just say handler to be explicit. That's a personal preference for me. That is really all it is. So we have our search box working. We have our card list component working. Everything here is pretty much going to be the basic setup for our components. In the next video, what we're going to do is now just start styling everything. And we're going to understand how CSS files work inside of React. And through that, we're also going to understand how React builds our project a little bit clearer. So let's talk about that in the next video. Welcome back, everyone. So in this video, let's apply some of our styles and have a better understanding of the way that React handles regular CSS. So right here, when we initialized our application in Create React App, we knew that we had also generated this app.css file. Inside of this app.css file, there are, of course, a bunch of styling that was related to that original spinning logo that Create React App scaffolded for us. Now, we don't need any of this anymore. So what we want to do is we want to start styling our application to look much more similar to what we had in the final output. So let's go here and see. What we have is, of course, we have this title, but then we also have this background, and we have these different cards that are styled in place of what we see now, which is just H1s. So let's start styling, and that way we can get an understanding of how this application works. So here, let's talk a little about structure. Inside of app.js, app.js represents the entry point to our entire application. There's a reason why, in most applications, app.js does not live inside of your components folder. And the reason for this is because app.js is not necessarily the same category of component as these other components. These other components represent reusable components in our application, whereas app.js, there is only ever one. You will not have multiple app.js's because, again, app.js is the entry point, represented as a component, into our entire application. Similarly, then we also have an app.css. This is going to be styling that should apply to your entire application. You can keep it in app.css, or if you don't like app.css, you can make a index.css file instead and import that instead into app.js. It's really just up to how you want to name this idea of a styling file that reflects styling that should be present across your entire application. So for us, what should go in there? Well, for now, let's look at this application. We know that this background is ever present, so let's actually add this into our application. So CSS inside of React is like CSS anywhere. I don't want to spend too much time on CSS because, generally speaking, there's so much JavaScript and React that we have to learn throughout this course. So what I'm going to do is give you all of the CSS that you are going to apply. I'm going to, of course, talk about how CSS actually operates inside of React and all of the considerations you have to make for it. But if we just talk about CSS, I'm going to spend hours on hours teaching CSS. So there's no real point to that when really the purpose is to learn React and JavaScript. So here, just look inside your resources folder and get that CSS file and just paste it into your app.css. Once you've pasted it in, save and go back to your application. And you will see that you now have this gradient background. So one thing to note about the way that CSS works inside of React is that no matter where you import it, as long as it's a general CSS file, React will build it all into one big CSS file so that no matter what, that CSS is always present in your application. Now, why is this an important thing to think about? Okay, let's discuss and represent how we should structure our CSS knowing that. And we'll better understand what I mean when I say this. Inside of your search box component, what you want to do is you want to write CSS that's relevant to the component. So I'm going to make a searchbox.styles.css file. This is just going to hold CSS that is only applicable to our search box. And of course, our search box component here, right now we are appending some classes on here. But let's say, for example, by using string interpolation, we can do this. So we have to wrap our string interpolation because interpolation is JavaScript inside of these squiggly brackets. And here with this interpolation, I'm saying, okay, I'm going to use some JavaScript in this string. I want you to take this variable and apply it. And we know class name is going to be a string. But let's also just say, for our sake, we say this is a search box. So I'm adding the class name search box. Right now, the property that we're passing in to app.js is also search box. And I'm just going to call this monsters search box. So when I save this and I save this, if I go here and I look at this component, I will see that there are now two classes on here. There is search box and monster search box. So monster search box tells me, oh, this is a search box for monsters, but then search box is general styling. And this is important because inside of my search box styles, I can now target this search box class that I have by default in the component. If I wanted to overwrite some of these styles or add additional styles for the monster search box, which is a specific instance where I'm using the search box component for a specific purpose, then I can apply styling on that class. And that is dictated by whatever is passing it in. It makes it flexible like that. But I do want all my search boxes to have some general styling. So here, inside of here, you can just, again, look inside your resources folder, find that CSS code for search box, and paste it in. Now we save. And what we need to do is we need to import this CSS file into our search box component. So I'm going to say input, and then I'm going to go up in the same folder and just import searchboxstyles.css. Once I look inside of my code, I will see that this search box now has the styling. It's thicker now, it's bigger now. That was all we did for updating this. But one thing I want you to know, when I mentioned earlier that no matter where you import CSS, it will be present on the entire page. The important thing I want to say there is that this CSS does not mean it only applies to your search box component. So our targeting inside, of course, only applies to this class. But I mean that this file is not in isolation from the rest of our application. Because styles, CSS styles specifically, apply to the entire website. The file is present across the entire website. That means that other components are not protected from the styling that you write. Even though here, when you see this import, it makes it seem like I'm importing styling that's only relevant to search box. That does not mean that only within the context of this file is this CSS applied. Once CSS is actually bundled and then put onto a website, that CSS is applicable to every single component, every single HTML that's on that website. And a quick way that we can test this is if we look inside of our card list component. For this div that reflects our card list component, I'm just going to put a quick class name here. And I'm just going to say card list. And I want to do this just to demonstrate to you that we can target this from our search box styles. Let's say here I say .card list. And let's do something really bold. Let's set the background color to red. If I save this and I go back here, you see that this card list component's background is affected. And this is because, again, when you import a CSS file, that CSS file is going to be applicable to the entire website. The only reason why we put these imports at the component level is more so for us. When we are looking for our styling that is related to the search box, you want to put it where that component lives. And of course, you want to target your CSS so that's only relevant to the component's code inside. But this is just a designation for us as the actual developers. As far as the underlying technology is concerned, if you write CSS that will overlap with components outside of your component, it will still happen, exactly as we saw here. This .card list code in CSS is still going to affect other code. So that's an important thing to remember. Now, you might be wondering, is there a way that I can isolate my code so that the CSS doesn't overlap with CSS in other files? There is, and that involves learning some CSS-In-JS libraries, which we'll do in a later project, not this one. That is going to help us do the isolation. And we're going to definitely dive into why the differences with that one exist between this one, which is CSS in React. Now let's delete this style. And in the next lesson, let's style the rest of our application, including styling out our different users/monsters into their own respective cards. So I'll see you in the next lesson. Welcome back, everyone. In this video, let's style the rest of our components. What we want to do is we want to turn these H1s that represent our individual monsters into these different monster cards that we see here. So how are we going to do that? Well, let's go back to our code. Inside of our code, I want to navigate to this card list component. And what we want to do is actually create the template that will reflect the card. So instead of H1s, we are going to make a card component, and it starts with a div. So a div is going to hold all of the actual content for this card. And I'm going to give this a class name of card container because I'm going to style it using that class name. What else I'm going to do is I know that there needs to be an image. And here we're going to give it the alt text of monster because that's really what it's for. The alt text is for accessibility, and it essentially on screen readers will mention what this is. And here we can say that it's a monster. We can get more specific if we want. If we wanted to say that not only is it a monster, but there's a name to the monster. And we can do that by, again, using string interpolation. And then here I can say monster.name like this. But now I need to give it a source. The source is going to be a website actually called RoboHash. RoboHash is awesome because it allows us to generate these images that we're going to use, and I want to use the monsters. So in order to do this, what RoboHash does is that after robohash.org, after the slash, you can type whatever you want. For me, I know that with our IDs that we're getting back from JSON placeholder, they're numbers, and they increment by 1. So if we say /1, and here following the actual monster ID, we add this URL parameter set, I can say that set2 is the one I want, which is the monsters. If you actually save this, you'll see that right here, this is our monster. If I increment this ID, I'll get a different monster. So using this, we can generate all the different monsters we want to use for the images inside of our application. The additional great benefit to this is that there's another URL parameter you can add, which is size, and you can tell it how big you want it to be. So I want it to be 180 by 180 pixels. And there you can see that this will be my image. So that is the dynamic value we want. So let's just copy this. And again, you can just find this inside of your resources folder. Go back to our application. And I want to say that source is going to be equal to string interpolation. And instead of this number, I'm going to say monster.id. And now that we have that, let's also make sure that we have an H2 that will have the name of the monster. And let's also make sure that we have a paragraph tag that contains the email of the monster. And let's not forget, because we're mapping over, we need to make sure we also include a key. So that key value was monster.id as well. And here, if I save this, if I go back to my application, I'll see that we have our card. Now, it doesn't have all the styling of our card, but it's the beginning of it. It's already resembling much closer to what this final application looks like. One quick thing I want to note. One improvement that you'll notice here is that we are actually calling monster.name twice, and we're calling monster.id twice. Whenever you see this, this is a good time to destructure, because essentially what happens is that you can imagine perhaps there's a chance that later down the road, how you get this name is different. Or let's say monster name is no longer monster name, it's username. you would have to change this in multiple places in your file, and that's a little inconvenient. The way that destructuring works is that we cast it as a variable, and then we just use that variable. We've already done it before. So here, let's just make sure we do that as well. So I'm going to use these curly braces so that I can actually destructure off the properties I want off of monster. And this way, wherever I reference it, I can just change it in one place. So I know that I want the name, I want the email, and I want the ID. And now, if I just go through and remove the monster dot, and I save, and then I go back to my application, I see that everything is still working. So that's a nice little optimization. Now let's style the card list and the card component. So we're going to make another file, cardlist.styles.css. And inside, we know what we need to do is we need to style this card list container that contains all of our cards. And we also need to style the individual cards themselves. So again, go into your resources folder, get the card list CSS file, and paste it inside of here. Once you paste in your styles, don't forget to go back to the card list component and import in the styling file that we just created. So now if we save and we go back to our application, we'll see that we have the same styles as our main application. So this is pretty much the majority of the application. There's one more header to add for Monsters-Rolodex, but you'll notice that your app pretty much looks the same now. And if we do and type, we see that everything works as it did before. One quick thing that I want to challenge you to do and really think about here. Some of you were looking at this application might actually notice an optimization. That optimization is to take this code for this card and actually move it into its own card component. So that's actually what I'm going to challenge you to do. I want you to just take this component that we have inside of card list and move it into its own card component. Move the styling, move all the relevant code, and then get it there. And once you've done that, in the next video, let's do it together. So I'll see you in the next video. Welcome back, everyone. In my last video, I asked you to move this into its own component, this card. So what we can do in this one is do that now. So let's create a component called card. So we'll initialize the folder and we'll say card.component.jsx as well as card.styles.css. Inside of card component, let's do all of our setup. So we know we need to import the component class from React. We also might as well import our style file because we know we're going to need the styles. Finally, let's initialize the class. So we'll say class card extends component. And also we need to make sure we export default the card. So I like doing all of this up front, this setup for a new component, just so that I remember. It's easy sometimes for us to write our code and then for things not to work, and we think that it's a bug, when in reality, we're just missing some of the crucial steps that are necessary in order for these cards and these multiple files to all work together. So by doing this stuff up front, you're making sure that you get around that. We also need to make sure that we render something, and in that render, we return something. So what I'm going to do is I'm going to come over, I'm going to copy this code over. So this is the HTML. And when we look at this HTML, what do we see that we're missing? Well, we actually don't have all of the required variables. We don't because we haven't inserted anything. So here, what I want to do is I want to make sure that I destructure off the ID, the name, and the email, which are the values that my component is expecting to use. And obviously, this is going to come in as a prop. What I want to do is I want to pass the entire object through. By doing that, I know that what I'm getting off of this props is going to be exactly that whole object, and that object should have these values. There are ways that we can enforce this that we'll talk about later. For now, we are making a pretty small application. We're the only people coding on it, so we know what it is that we're coming in, which is this monster. At this point, if we save this, And what we're going to do is replace the card list component with this component. So here, I'm going to say card. And instead of doing the destructuring here, I'm just going to pass monster like so as that prop that we set up. And then I'm going to import in card from card-card component. And let me save this. And just to make sure, our code is still working. The other thing that we're missing now is moving the styles. We have card-related styling inside of card list. And as I mentioned, CSS is relevant everywhere, which is why our styles still work. But again, for the proper separation of concerns, we want to move this into card styles. We've already done the import. If we go back, we see that our code is still working. The last thing that we need to add is going to be the title. So here, I'm going to leave it up to you to put whatever title you want into your application. What I'm going to do is just go into the app.js, and I'm just going to put an H1 above the search box. And here, I'm probably going to want to move it a little or put some padding around it. So I'm also going to give it a class name of app title. And inside, I'm just going to say Monsters-Rolodex. I'm going to save this, go into app CSS, and target app title. Once we're inside, what I want is a margin top of, let's just say 75 pixels. I want a margin bottom of, let's say 50 pixels. I want a font size of 76 pixels. And I also want a font color, or just color in this particular case, of #0CCAC4, which is a light blue. At this point, you can also actually include a new font. And if you're unfamiliar, or if you are familiar with adding fonts into applications, typically what you might do is you might go on to Google Fonts, and inside of Google Fonts, you'll just find a font that you like, and then you'll install the script into your HTML file. So I'll show you how to do that. You can pick whatever font you want. I'm going to pick Bigelow Rules, which is this one, because it looks kind of like Monsterish, kind of reminds me of Addams Family. So here, I'm just going to hit this plus to add this style. And then all you do is you take this link, you copy this, you go back into your application, and let's just close all these other unneeded files. In order for us to actually include it in our application, typically you put it inside of your index.html. And for us, it's the exact same. We have it here inside of our public folder, and we're just going to paste this somewhere. So I'm going to paste this right here. And this will install in our Google Fonts. So once I have the fonts, then what I'm going to do is I'm going to go back into my app CSS, and I'm just going to say that font family is going to be Bigelow Rules, because this is the one that we just installed. You see the name right here. And then if we go back to our application, we'll see that everything matches now. So this application looks pretty similar to this application. I've got a little bit more padding or margin at the top. It's up to you if you want to add less, add more. You can tweak this however you want. But this is it. This is our application. Everything works as we expect it to. You can clear the search bar and everything works. And there you go. This is your first project of Monsters-Rolodex. If any of this was confusing, please rewatch this series of videos, because from here we're really going to build atop the foundation of everything we've learned. And just to quickly go over, a lot of the main focus of what we wanted to understand about this project and React was primarily components, how they render, how they re-render, and the basic composition patterns that we need for React. So now that we understand this, I'm going to go deeper with what we've just learned, and you're going to get a lot of practice with a lot of these concepts again. We just work with class components, And in the next video, what I'm going to do is I'm going to talk about converting these into functional components and some of the differences between class and functional components. So if you're unfamiliar with class components, just quickly go over them. You'll get a good understanding of generally how they work. And then in the next video, let's dive deeper into functional components and hooks. Welcome back, everyone. In the next few videos, we are going to learn about functional components and how to write our application using functional components in place of class components. I want to mention that functional components utilize hooks in order to replicate a very similar behavior as we see with class components. The key thing is that they differ in how React utilizes them in order to re-render. The behavior in the application is the exact same, and the way you write these components is largely the exact same. You just have to change your understanding of how these components operate. And I know right now it seems a little vague, but don't worry too much about the implementation yet. We're going to spend a lot of time with that. I really want you to understand the high-level concept here because this will really help you understand why React has functional components as well as class components. React is a library that has been around for a long time. It's important to note that because of this, React is constantly changing. In this change, it's constantly trying to support multiple businesses that utilize it in order to build their web applications. This means that these businesses also have a very diverse pool of developers. Some are comfortable writing classes, some are comfortable with functional programming, which is writing in the majority of your code as functions. And as a result, React largely does cater to both different developer pools. Similarly, throughout React's development history, it has tried to keep up with the trend of larger developer practices versus lesser developer practices, and it's constantly trying to balance these things. As far as you need to be concerned, it's important for you to know class and functional components because different companies will write React differently. Some will write them in functional components with hooks. Some will write them in class components. Most will write them in a mix. There may be a larger push towards functional components as you join newer startups, but that does not mean that larger enterprises do not run class components. So it's very important that you know both so that you're able to effectively write React regardless of the team you join. In a similar fashion, class components is a very important starting point for learning React because React was founded on the concept of class components. It was probably the first way that you could write components in the very beginning. So the majority of how React determined the base point of how it thought about rendering inside of a web application was based on classes. And as a result, by understanding how React decides when to render and re-render, we're able to just have a better foundation of understanding that concept. So that when we move over to functional components, we already understand how rendering, re-rendering operates. Then it's just a matter of changing the model to a different form of component. And we're definitely going to dive deep into all of that. So don't even worry. You're going to become a whiz in no time. I do want to note that in the upcoming videos, we will start diving deeper into functional components. But in your Capstone project, which will be the project that we work on after we finish this section, I will start flip-flopping between functional components and class components. The reason for that is because it requires us, in my opinion, to have a good foundation of both to really understand functional components. Functional components is easier learned in some ways once you have a foundation of class components, but it is important to note that they are two different styles of writing components. It seems really vague right now, but again, you will understand why. I just want you to prepare yourself to see that we will be using both class and functional components, and throughout this course, I will be answering when you should use one over the other. But generally speaking, most of the time, you can use either or. It's really just up to the team that you join and what the general coding patterns are within that team. Sometimes it'll be functional, sometimes it'll be class, sometimes they might not care. It really depends from organization to organization. Therefore, for you to be the most effective React developer you can be, you should learn both and understand both. So with that noted, let's move on to functional components. Welcome back, everyone. Before we move on to functional components, I want to quickly go over our class component rendering and re-rendering. because we're relying on a lot of life cycles right now inside of our class components that we need to now understand how a functional component replaces them. So in order to understand that, we need to properly understand all of our life cycles once again. We've gone over it a couple times, but there's actually this great diagram here by Wojciech Ma, who I will link inside of your resources folder, that has shown this diagram where you can see the breakdown of class components and their rendering and re-rendering alongside life cycles. So let's go through the three most important phases: mounting, updating, unmounting. So when a component mounts, as we saw with a class component, we know it runs the constructor, and then it runs the render method. At this point, after these have been called, React will update the DOM. And in our particular case with mounting, it is updating the DOM by mounting our component for the first time. And after that has mounted, then you will see component did mount as the lifecycle method that get calls after. This is all of our code inside of our current app class component. Nothing new here. What happens subsequently is with updating. As we see here, whenever new props come in, or whenever set state gets called, render gets called again. This still aligns with what we know. We remember logging out render, and whenever new props came in or set state gets called, the render method gets called. Similarly, React will then update the DOM with the new UI, and then there is actually another lifecycle method that you can hook into called component did update. So you can run some code inside of this after a re-render happens, meaning when new props comes in, set state gets called, React has updated the DOM, then this method runs, just like component did mount runs after the mount update. There's also this force update method where you force the component to re-render. This is oftentimes not something you should be calling. It's provided if you have to force your component to update. But typically speaking, you want to rely on React and its component structure, understanding when updates are supposed to happen. You should not necessarily always force an update. This more so only happens when you're integrating with third-party libraries that don't necessarily have a React-based library that hooks in and follows along with the typical update cycles. Then you want to use force update if you have to, but most of the time you just want to rely on what's provided. Finally, there is unmounting. Unmounting is just when you are taking a component off the page. What this means is sometimes you're navigating to different pages or you're changing your UI where you don't need a component on the page anymore. React will be the one that takes that off the page. And once it takes it off the page, it is now unmounted. So there's no longer existing on the page. And before that happens, there is a component will unmount lifecycle method that runs before the component is finally stripped off. This is typically done when you need to clean up certain things. When you think about this, for those of you familiar, this is where you might want to remove any listeners or anything that consumes memory by relying on the component actually being alive. This will run before you actually pull that off, so you don't get any memory leaks. We'll definitely talk about this because we will utilize some listeners if you're unfamiliar with the idea of an event listener. Or subscriptions, that's another way to think about them. If those you aren't familiar with, don't worry, we'll do them later in the Capstone project. But for now, this is mainly where you will do these types of things. This is where you will utilize this lifecycle method on an unmount. Now, this is unique to class components. Component did mount, component did update, and component will unmount. Functional components don't have these lifecycle methods, but they do still follow this same three phases of components. There is a mounting phase, there's an updating phase, and there is a unmounting phase. The only difference is that you don't interact with these three phases the way that we do with a class component, where we override the constructor method, the render method, component did mount, component did update, component will unmount methods. Those are what we were doing inside of our class component whenever we wrote into our constructor or our render or our component did mount lifecycle methods. Functional components do not do this. They are completely different, but they follow the exact same structure. And that I want to make very clear. It's just that you have to think about how a functional component moves through these three phases based on the concept of a function. And that is what we're going to cover when we dive into our functional components. So go over this chart whenever you need to. Really understand what's happening. And once you do, join me in the next video and let's dive into functional components. Welcome back, everyone. So let's talk about functional components. A functional component typically takes the form of an arrow function. Arrow functions at this point are the norm of writing functions. And the way that we want to replicate, let's say, this app component is we would say const app the same way that we said class app. So we're initializing some constant variable named app. And we want it to be equal to a function. That is pretty much all you need as far as the boilerplate of a functional component goes. You don't need this constructor. You don't need these lifecycle methods. You don't need the render. These are all things that are only unique to class components. These are methods attached to a class. Functions, in this particular case, and functional components are pure functions, meaning that all React is going to do is run this function top to bottom. Whatever gets returned finally from this function is going to be the UI that this function returns. So in turn, what we return from our class component is inside of the render, in this return statement in our render method. But with a functional component, whatever you return inside of the function is going to be the same UI. So let's just copy that over and paste it into this return. This right here is your functional component. What you see inside of here is enough to get a functional component working, assuming you have all your variables. In our particular case, we don't, but just so that I can show you what I mean, I'm going to comment everything else out that is a component and just render an H1 because nothing inside of this function is reliant on any of that. And here our class component is now in conflict because we have two matching variables, both named app. We have our const and we have our class. So I'm just going to comment out the class. And just to show you that this is all it takes, now our app is a functional component. Now we save and we go look inside our application. We see our title, so we know that our functional component is working because it's all we're rendering from this functional component. Now, before we start moving and figuring out how our functional component can reflect all of those other functionalities that we had in our class component, let's break down the differences immediately when it comes to the mounting phase with a functional component. Clearly, when we look at this functional component, there's no constructor method because constructor, as we know, is related to classes. Because there's no constructor and no class, a functional component behaves as you would expect a regular JavaScript function to do. And all a JavaScript function does is it takes some arguments and it returns something. In this particular case, a React functional component takes arguments that are the props of this component, and then it returns JSX. That's all it is. A function, when it gets invoked, runs from top to bottom, and then that function is done with. So unlike our classes, which get instantiated, and then there are all these different numerous lifecycle methods or constructor method or render method that are related to class components, that are constantly being kept alive and being run and invoked depending on what phase a class component is in, functional components do not do that. Instead, React takes your functional component, which is just a simple function, and it says, oh, I need this component. I'm just going to run this function and just return whatever returns. Once I've returned it onto the page, I'm done with it. React under the hood will keep a reference to that component and, of course, the functional component that instantiated it. But as far as you're concerned, the simplicity of a functional component is like a JavaScript function. It just runs from top to bottom, and then that's it. Here, with our functional app component during the mounting phase, React is essentially saying, oh, you gave me this function. I'm just going to run it and just return that HTML JSX, which was inside of your return of this function, and then that's all I'm going to do with it. That's a very important thing to note because functional components do not go through life cycles the way that we typically think about when we're talking about class components. It's almost an entirely different mental model. Sometimes when you read different guides on React, you will see people talking about functional components going through similar methods and using similar hooks that replicate life cycles. This is actually very misguiding because there are no life cycles when it comes to functional components. You have to think about it in a completely different way. And the way you want to think about them is in the concept of functions and side effects. What are side effects? In order for us to understand side effects, we need to understand pure functions and impure functions, which we'll cover in the next video. The reason why you need to know about functions, pure functions, impure functions, and side effects is because in order for us to replicate all of the behavior that we had in our class components with state and with set state and with lifecycle methods, we need to understand this idea of side effects. So we'll talk about that in the next video. Remember, without understanding functions, pure functions, impure functions, and side effects, you won't be able to fully grasp the way that React handles functional components. So in the next video, let's talk about it. Welcome back, everyone. Let's talk about pure and impure functions. When we talk about a pure function, there are mainly two things to consider. And the first one is very simple. You have a function. So here I'm going to initialize one. I'm going to call it pure-func. And what this function does is it takes some arguments. In this particular case, let's imagine it takes two numbers. What a pure function should do is return the exact same thing, no matter how many times it gets called, when it's given the same arguments. So here our pure function is just a function that receives a and b, which are both integers, and it will add them together. That's what it returns. So here, for my function to be pure, if I give it 2 and 4, it should always give me 6. No matter how many times I call this function, this should always return 6. And looking at this function, you might think, oh, yeah, that's super intuitive. Of course, because looking at the identity, this is a very simple function. But we all have seen functions that go way beyond and above this. And where are those conditions where this may not be pure? One easy example to think of is if we created some other function, let's call it func_a. And this function, similar, has a and b, which are both integers. But what it does is it relies on some external value c. And let's say c right now is 3. And what it does is it returns you a plus b plus c. In this particular case, when you look at this new func_a, if you were to pass this 2 and 4, you would get 9, because 2 plus 4 plus 3 is 9. This currently does give us back 9 every time we call it, but c might change. And if c changes, this is now no longer giving us the same value as it did previously. It's now giving us back 11 instead of 9. So this is an impure function. An important thing to note, c may change without func_a knowing. And that's a very important thing. A function is considered pure when everything that dictates what it returns is completely isolated from what gets passed into it. This is very important because this function's return should solely be dependent on the props being passed in. That is the only way that your function is considered pure. Another thing that your function should not do in order for it to be considered a pure function is produce side effects. What is a side effect? Let's once again talk about that variable that we had before, c. C is some value that is outside of our function. In fact, we can make a new function. Let's call it func_b. If this function takes a and b, but for some reason what it does is it sets c equal to a plus b, and what else it does is maybe it returns a times b. Func_b, at this point, if you were to pass it 2 and 4, this will definitely always give you the same result. That validates what we said about pure functions. However, c is now being changed outside of the function. This is considered a side effect. A side effect is when a function creates some kind of effect outside of its scope. And in this particular case, it's setting some variable outside of the scope of its function. And the scope is whatever is inside of this function. The variable c does not live within the scope of this function. It's accessible within the scope of this function, but it is also accessible outside of the scope of this function. And as a result, if it were to change that variable, that is considered a side effect. These are very important things to note about pure functions and impure functions. So in summary, remember, a pure function, if it is to modify or rely on something outside of its scope and beyond the parameters being passed into it, that is an impure function. Now, when it comes to pure and impure functions, is one superior over the other? This is a highly contentious topic. Technically speaking, many JavaScript developers prefer writing code in a functional way because it's very predictable. You can look at a function, looking at its arguments, and understand what its output is going to be. This gives you a contract that is very secure. You can trust that this function is going to return what you expect it to return because it does not rely on something outside of the arguments being passed in. However, that does not necessarily mean that impure functions do not have a place. And this is an important thing to note because in React, what we are writing is going to be impure functions. We're going to use hooks to create impure functions. We have pure functions and we also have impure functions, but when you think about some of these hooks, understand that what you're doing is you are generating side effects. And that is really the idea around why pure and impure functions is an important thing to note. Because generally speaking, we want to write our functions purely, but when you write functional components, you will create impure functions. And by understanding that idea of modifying or relying on some value that exists outside of the scope of your function will help you understand the way that functional components render and re-render in React. So now that we understand this, let's move on to our next video. Welcome back, everyone. So let's continue with creating our app functional component. So here what I'm going to do is I'm going to move search box back into the return of our HTML. So I'm going to uncomment it. And let's think about what we need in order to pass this on search change that we had before into search box. As we know with a function is supposed to iterate from top to bottom, meaning that JavaScript runs from top to bottom. So of course we need to actually create this on search change function inside of our app. So I'm just going to create this function right here on search change, and this is going to be equal to a function. And this will be the exact same search change handler that we had before. So scrolling down here, let's copy what's inside of here. In fact, let's take the whole entire function because we need the event. We're going to have to fix it up a little bit because it is commented out below. So if I paste this here, I will need to uncomment that out and fix the tabbing here. So here what we do, we get the event. And then what we do, we lowercase it. And following up, we do this set state. So this .set state, as I mentioned, is a method unique to class components, but we're not using that anymore. In fact, let me remove it because we don't need our class component anymore. How are we going to set state? This is actually where we need to use a hook. So let me explain what hooks are, and more specifically, the most simplest hook that's available to us, which is the useState hook. useState essentially gives us an ability to encapsulate local state in a functional component. So let's talk about how we actually use it. What we're going to do is we are going to use array destructuring from useState because useState gives us back an array of two values. So if you're unfamiliar with array destructuring, essentially what it does is it allows us to assign variables to values inside of an array. So as a quick example, let me just quickly show you. Let's say that we had some array and it contained the values 2 and 4 like this. If I do const a b equals array, So I'm saying, hey, I want you to assign a variable A to the first value and a variable B to the second value. Now, A, as we see, is equal to 2, B is equal to 4. So this is exactly what we're doing here. useState gives us back an array of 2 values. The first value is going to be the value that we want to store, and the second value is going to be a setter function. So what do I mean by this? useState, unlike the setState that you're familiar with inside of class components, is an object in the class component, but in the functional component, it's individual values. We are not trying to store entire objects. So here, what we want to do when we say, oh, this useState value, we are going to encapsulate a singular value from that state. So if you have multiple values in a state, well, then you need multiple useState calls. Each hook only hooks into one value. So here, we want to do search field. So search field, you want to pass into the useState the initial value that it should be. And for us before, inside of our object, our search field's initial value was an empty string. So we want to do the same thing here. We're going to initialize it as an empty string. And what we'll get back again is the value and the set value. So here, I'm going to call it the search field value. And then I'm going to call this set search field. So with these 2 values now, we're able to actually replicate the set state for just search field. So we don't need this anymore. Here, these 2 names clash. What really this search field is really the target value that's been lowercased. So I'm just going to say this is the search field string, because that's what it is. It's the string value we're getting back from our search field. And what I want to do is now I want to call that set search field setter function that we get back from useState. And then I'm going to pass this in. So far, this is all we're really doing. And with this search field, what this should do now, simply, is just log the value. Because right now, nothing is actually happening. We haven't used this search field string in the state for anything yet. Before, we were filtering monsters with it, but so far we haven't done anything. And the reason why is because I just want to show you what these values will be. So here I'm going to console.log search field. And I just want you to see what's happening. So let's save. Let's go to our application. Let's clear this out. So when we initialized, our search field is an empty string. That's the first time it logs. So remember, we're logging this after our useState gets called. So at this point, search field is an empty string because that's the default empty string value. We have this onSearchChange function, and what it does is it receives the event, it lowercases it, and then it calls setSearchField. And then we pass that into our search box component. So our search box component runs it every time we type into the search box. Now, if we start typing, what we see is that our search field is indeed updating the value inside of the local state with this string value. Now, one quick thing I want to mention is that when we're logging this isn't an object because I am logging out an object right here. I'm just using object shorthand in order to make it more clear to us what it is we're logging. But setState is really not in an object anymore. It's whatever value it is inside of the state itself. So in our particular case, this useState is a string. And whenever we set the value, we're setting a string. So search field value itself is actually a string. So if I instead remove those curly braces, and here instead you'll see it mounts, it's empty. And then as you type, you log out a string. It's still just whatever value type it is. It doesn't get converted into an object the way that setState had it before, where our entire state object was an object. In here, it's whatever type it is when you pass it to the state hook. So this is an important difference. So now that we understand how to utilize the useState hook, in the next video, let's dive into the way that we can understand how these components are re-rendering in the context of this hook. See you in the next video. Welcome back, everyone. In this video, we are going to talk about rendering and re-rendering inside of our functional components. And specifically, we're going to talk about how hooks and more specifically, the useState hook fits inside all of this. To begin with, I have console logged out the string render on line 8 at the very top of our functional component, and we're still continuing to log out our search field value. What I want you to think about is whenever right now, inside of our application, let's clear this. When I refresh, we see render and then we see the empty string. Whenever I type anything, you'll notice that render is getting called first, and then the string value is being called. What this means is that React is running this entire function every single time it needs to re-render a component that is a functional component. This is a very important thing. Previously, inside of our class components, whenever there were mounting and update cycles, render would get run. And update cycles ran whenever props changed or whenever state updated. The only thing that ran, though, was whatever code was inside of the render method. With functional components, we don't have a render method. This entire functional component you can kind of see as the same thing as the render method. Essentially, whenever React has determined that a functional component needs to render or re-render, it will just run the entire function top to bottom. The way that it determines whether or not a functional component needs to update is the same as a class component. Whenever the props change, which is the arguments inside of a function that we have not worked with yet, but we will soon, but just remember that whenever props change, the whole function gets run. So React is determining, oh, I need to re-render the component. Let me run the entire functional component. Similarly, whenever state changes, it will also rerun this entire functional component. That is the only way React knows there's probably new UI. How do I determine what that new UI is going to be? Let me just rerun the entire function so that whatever gets returned from this function is going to have the latest variables, latest props, latest state values, so that I know what the new UI will look like based on the returned JSX from this function. This is the thing to remember about functional components. You cannot just run part of this function. This whole function needs to rerun every single time. So what about useState and this hook? The thing about useState is that you are getting back this state value. And under the hood, what React does is React will actually check whether or not this state value is different. Only when through that hard equality, it notices that there are different values, only then will React actually rerun this value. So currently, every time our event changes, the state value is updating because we're either typing new characters into the string or we're removing characters from the string. We saw that. However, if I were to copy search field and just call set search field instead and save this, every time we type into this search box, I don't care about what the string you're giving me back is. I just want you to set the value of search field to the current search field value. If we do this and we refresh, what we'll see is that despite the fact that I'm typing in these characters, we're not seeing any of the console logs get fired. And the reason for that is because React is calling our setter function, our set search field, but it's just not giving it a different value. So React is smart enough to know, oh, if this state value is the same value, then don't rerun this function. And what this tells us, it's not actually set search field that triggers a re-rendering of a component. It's actually when the state value changes. In the context of our current use state, if the current string value of our state is the same as the new string value coming in, literally the string values are the exact same, then we will not re-render, meaning that we will not run this function from top to bottom again. We can easily test this. Let's say I initialize the initial state value as a string that contains the letter A. Let's update so that instead of passing the search field in, we're passing back in the string value that we're getting from the event of our search box. Remember, our search box's internal string state is completely separate from our use state, meaning that whatever this state value is does not actually affect the value that our search box has inside of it. The way that we can easily see this is that with that initialization, the initial string value is A, but our search box is an empty string. Of course it is, because we're not actually taking our state value and putting it into the search box. It's the other way. We're taking out whatever value is being typed into the search box, and we're trying to remedy it against what we have in our app. So here, what should happen is that when I type the letter A, we should see no console logs because our current state value is A. So if I type A, we're going to get the letter A string, and it's going to say, oh, the value of the string you typed in is the same value as what I have inside of my state. So our function is not going to rerun. And that's what we see. We just typed in A, nothing happened. But if I keep typing it in, then we see we're now re-rendering the component because the string value is now different than what we have inside of our internal state. And now everything works as expected. So that's the thing to understand about the way that React determines using state inside of your functional component, whether or not it needs to re-render. We'll talk more about this as we build out our application with the different hooks and some more complex cases when putting this kind of stuff together. But this is really the most important difference about functional components and class components. You need to stop thinking about functional components and life cycles and start seeing it instead as when does React determine that I need to rerun my entire functional component? That's really the difference. So with that, let's move on to completely changing the remainder of our class app into this functional component. Welcome back, everyone. In this video, let's actually migrate out what we have left inside of this component, which is the card list. So let's uncomment out that part of our code and put this in. And here what we need is filtered monsters. In order to get the filtered monsters, let's think about what we need inside of this part of the code, which was our old class component that actually returned us the filtered monsters. What we need here is we need a monsters to filter from. And this monsters before was inside of our state, which was initialized as an empty array. So let's do that first. Let's first initialize a new state, so const monsters, and then set monsters. Remember, it's the value and then the setter value. And I'm going to say use state, and I'm going to pass it the initial value, which is an empty array. Now that we have this, what we need now is to figure out how to actually get the values from JSON placeholder into this app component. What we had before is that we had this component did mount call. Component did mount is some lifecycle method, as we know, that fires only when the component mounts. That's the only time when you need to fetch this initial data. After that, we don't need to ever fetch it again. But this might pose a problem for us because let's just look at if we copied this fetch, and let's comment this out back again. And let's just say put this inside of our application. If we just made this fetch call, and what we did is right here, instead of set state, we said set monsters. And instead of passing it a function, we can just pass in the value that we want the monsters to be set to. So which is our users. Now, before I save this, and before you save this, what I want you to do is I want you to also add a console.log render. Remember, I'm trying to show you that this is not the way that you want to actually fetch. There are a couple weird things that are going to happen, and we're going to dive deep into why that happens. So if you save this fetch now, and you go to your application, let's refresh. What are we going to see? We see the render call. We do see our content, but notice how this render is constantly firing over and over and over and over and over again. Why does it keep doing this? Well, this actually has to do with the way that functional components work. So what you're going to have to do in order to break this is you're going to have to go into your Windows and go down into your task manager, open this, find your application right here, and end this process. Only by doing that do you prevent the stack from continually recalling. So why did that happen? What do we know about our functional components? Whenever the state updates, if there's a different value for the state value as there was in the previous state, then it will re-render, and to re-render, we need to run this entire functional component top to bottom again. Fetch is fetching from some foreign API some specific value. In our particular case, it is the users array. This array, because it comes from outside of our browser, is going to give us an array that is different in memory than the one that we have stored. Even if the values inside of this array is the exact same, because we know we get the same 10 user objects back in this array every time we call this API URL. But because it comes from outside of our browser, it is a different array in memory. Every time this check happens, our set monsters is seeing that this users array is a different one in memory. So the equality check fails, meaning that React thinks it's going to be a different array, which it is. It's a different array, even if the values inside are the same. Remember, it's not about the values in the array. It's about whether or not that array points to the same reference in memory. And every time this happens, it is a different array in memory. So as a result, what happens is that every single time this set monsters is getting called, it is re-rendering this entire function. And this function, as I told you, with all JavaScript functions, will run through every single line. It cannot just isolate one part of this function. It has to run every line in the function. So it's going to refetch every single time, which puts us in a circular loop. We are going to re-render. In turn, we are going to fetch again, get a new set of users, and then update the state. State is updated, React re-renders this function, fetches again, gets different users, sets monsters, and then reruns. And now we're stuck in this loop where we're just constantly refetching over and over and over and over again. And that is why this is happening. As a result, what we need to do is we need to stop fetching somehow inside of this functional component every time. And the way we do that is actually using side effects. Side effects can be generated from functional components using the useEffect hook. If you remember, a side effect is some behavior that we trigger from our functions that affects something that exists outside of the scope of the function. It's either that we modify or we rely on some value that exists outside of what's within scope of our functional component. In this particular case, any fetch call is a side effect, so we need to use the useEffect hook. And this hook is a little complicated. But right now, before we move on to utilizing this useEffect hook, I want you to really understand this specific thing that happened in our functional component. It's incredibly important because through this will you actually understand how functional components really work and how React determines using functional components that it needs to re-render. So remember, functional components, anytime it renders or re-renders, runs the code inside of this function top to bottom every single time. So if you have some weird bug whenever you're coding out React components and you notice that you're stuck in a render loop, think about what's happening. Think about all the steps with re-rendering. Think about the fact that this function runs top to bottom. Look at the variables in your state. Are they different variables or are they the same variables? These are very important things to really know about when it comes to React and coding at this level with React. React has come a long way, and as a result, you have to really have solid foundational understanding of JavaScript in order to properly code React components and understand how to optimize your React code. But now that we understand what's happening inside of app and why we were stuck in that infinite re-render loop, let's move on to utilizing useEffect hook to get around this issue. I'll see you in the next video. Welcome back, everyone. So in the last video, we learned about why adding fetch calls that might call setState can trigger these infinite re-render cycles. And how do we simulate this behavior that we know we need inside of our component without causing ourselves to get stuck in that loop? I mentioned that we want to trigger side effects, and we do that using the useEffect hook. The useEffect hook takes two arguments. The first is going to be a callback function, and the second is going to be an array of dependencies. So let's break down what each of these are. What is going to be this first argument, this callback? Well, this callback is going to be the code or the effect that we want to happen inside of our functional component. What about this second array? Well, this second array contains different dependencies. And by dependencies, these are most likely going to be state values, so either search field or monster in the context of this application, or prop values, which will be arguments that get passed in as props to our functional component. What this array says is that whenever any of the values inside of this dependency array change is when I'm going to run this function, this callback function. It's going to run this callback function the very first time this app mounts, because it's the very first time this entire code is going to get run. And then any subsequent re-render of this component, I will only run this callback function if the values inside of the dependency array have changed. So by doing that, we're now able to generate these side effects, which are, again, effects that come out of our function. In our particular case, a side effect is this fetch call. So by moving this inside of our useEffect hook here, we're just saying, hey, there's a callback that creates a fetch call that then sets the monsters. And I only want you to make this call if the values inside of this array change. Well, let's think about that. When do we want to make a fetch call? When this app mounts the first time. And then after it mounts, do we ever want to fetch from JSON placeholder again? We don't. We only want it to happen once. So what needs to go inside of this array? Well, nothing. We don't ever want to trigger this callback ever again, other than the very first time the app mounts. So for that reason, we pass it an empty array as the dependency array. We're essentially saying to this useEffect, hey, the only time you should ever call this function is on mount. Because if any of the dependencies change, useEffect is going to call this function. But I'm passing you no dependencies, which means that nothing is ever going to change. So nothing should ever trigger you to recall this function ever again, other than the very first time when the function mounts. So now if we save this and we go back to our application and let's just refresh, we see that we get one render call when we had our empty array, and then we have one render call after our fetch request comes back with all of our users. But now what we'll notice is that even as we re-render, we are not recreating that fetch call. And just to be clear, let's add a console.log in here just so that we're sure that our effect is not firing more than once. I'm just going to say effect fired in here. We come back. We see that we have our initial effect fired. And now, as we type, the effect never fires again. And this is exactly what we want out of our useEffect. So here we have an example of what it's like to pass an empty array to our useEffect hook. Let's take a look at a way that we can actually leverage this functions array so that we can get a better understanding of some more complex use cases of this dependency array. Another thing that we know that we need to do is we need to update the filtered monsters. Here is something that is interesting about filtered monsters. So those of you that are savvy and have understood what we've talked about when it comes to these functions rendering top to bottom, what we know is that every time this function runs, this filtered monsters array is getting rebuilt, even if the monsters array has not changed. This is okay though, because we want to do this essentially whenever monsters change or whenever search field changes. But let's say, just for an example, that we wanted to trigger some changes as well in this application that also modifies the state. So I'm just going to give you a very quick example. Let's say that I have some string field. This is another field, and I just do set string field, and this also stores a string. And let's just create another search box. And inside, I'm going to generate const on string change. And it's going to be very similar. It gets an event. And all we're going to do is that we are just going to set the string field value whenever this event fires target.value. And I'm going to pass this into this second search box. I'm going to call this, in fact, I'm going to get rid of this class name just so that we can visually see something different. And I'm just going to set this placeholder as setString. What I'm also going to do is I'm going to console.log filtered monsters. And now if I save this, here we have our search monsters, and then we have our setString. What you'll notice is that every time I type this, even though this search string hasn't changed and this monsters array hasn't changed, I am refiltering through all of these monsters every single time, which is why you see this log of the filtered monsters every single time. Even though this string field doesn't do anything to our monsters. Our search field is over here. This string field is just a different secondary input. And yet, for some reason, as we know, our function is going to refilter through these monsters. This seems like a very inefficient thing because to filter through these monsters, it costs our application, our JavaScript, some time to do this. And over time, this could lead to a lot of inefficiencies. So what we want to do is we only want to filter these monsters whenever the things relevant to filtering monsters has changed. Meaning that if the monsters array has changed or if the search field value has changed, both of which live in our state. So what we can do in order to fix this is that we can make another effect. In order to do that, what I'm going to say is that I'm going to initialize a filtered monsters state and set filtered monsters. And this initial state is going to be the monsters value. So by default, I'm just going to take whatever value was used here. We do this because in case this initial value is ever something else, we know that the filtered monsters is always based off monsters. So I'm just going to use this value. So to initialize, it will be the same empty array. And then what I'm going to do is I am going to call another use effect. I'm going to say use effect, our callback. And we know that in this callback, what we want to do is we just want to run this filtered monsters call. And here I'm going to say this is new filtered monsters. And once we filter through and we have that new monster, then we are going to say set filtered monsters to the new filtered monsters. And now filtered monsters here is always going to contain the values we want. And what I'm going to do is I'm going to say, I want you to filter through these monsters whenever either the monsters array changes or whenever the search field changes. And just so that we can see, let's also just add a console log inside of this effect to make sure that we're not firing this effect whenever this string field value is being updated. Not our search field, but our string field. So here I'm going to console log effect is firing. I'm going to get rid of this. Actually, no, let's keep the render. Let's save this. And now let's go back. Let's clear this. Let's refresh. So we see our initial calls, of course. We see effect is firing twice because we initialize with the empty and then we initialize with the empty string. Remember, there's two fields now. And what we're going to do is let's just validate that everything works with the normal search field. So if I say LEA, we see that our code is working. We fire for each character, LEA, 3 effect is firing, which is exactly what we want. And then 3 more when we clear out the field. Now, when I type into this string field value, we notice that again, this side effect is now not firing anymore, which is perfect. It's exactly what we want. This string field value is being updated. So this set string field is getting called, but our side effect here doesn't need to run because monsters and search field are 2 values that have not changed. And now we know we're not needlessly running additional filters in our cycles whenever that happens. So that's exactly what we want to do. And this is how you want to do the majority of writing your effects. Now let's get rid of all this code that we don't need anymore because it was really just needed to prove this example. And let's get rid of these console logs. And here we've pretty much converted the main class component inside of our application over into one that uses a functional component and hooks. The hardest and most complicated thing is really going to be understanding use effects and composing your code into these effects. But don't worry, we're going to get a lot of practice with that throughout this course. In the next video, we're going to convert the remaining components over into functional components, so I'll see you in the next video. Welcome back, everyone. In this video, we are going to convert our card list component, card component, and search box component over from a class component to a functional component. So to start, let's get rid of our class import because we won't need it anymore. And what we're going to do is we're going to say const card list is equal to a functional component. And then what we'll do is get rid of this render statement so that we can have it like this, so that we are now returning the actual JSX. We also need to get rid of this.props. So how is it inside of our parameters that we get our props? Well, React functional components actually only get 2 arguments. You get the prop and you get something called the forwarded ref. The forwarded ref is something that you are honestly only going to use maybe 2, 3, 4% of the time max. It's something that we'll explore later because it's honestly a little bit more complicated given that we haven't really seen it in context. Most of the time, you're just going to use props. And this props is the exact same as this.props. It's an object that has all of the different parameters and properties essentially that are being passed into this component. It's just that instead of this.props, it's going to be the first parameter that gets passed into this functional component. Similarly, because we know that this will always be the first parameter, we actually don't need to do the destructuring here. We can do the destructuring right inside of the parameter itself, like so. And now, instead of doing this return, because we have nothing else to return, we can switch this to an implicit return. And there we have our card list component. So let's go back to our application, and we see that everything still works as we expect it to. So let's do this now. Same thing for our card and our search box. If you want, you can do this yourself. Just take some time and convert these, pause the video, and then once you're done, come back. Okay, so if you've done this, you can skip this section. If not, let's just do this together. So what we're going to do is again say const card is equal to this functional component. We don't need this component class anymore. We get rid of the render. And then let's just fix our indents. And now we know we're getting this.props.monster. So I'm going to destructure off the monster. And instead of doing this further destructuring like so, I'm just going to destructure like this. And here we see code still works. And let's do our final one, which is our search box. So I'm going to get rid of the render. Const search box equals a functional component. And similarly here, let's get rid of this component. Get rid of the return. Since we're probably just going to do an implicit return right here. And now as far as what we need off of our props, we need class name, we need placeholder, and we need onChange handler. And then let's just get rid of this.props. Let's save this. Let's go back to our application. Make sure that our search box still has all of those fields. We have the class name, which is monster search box being passed in. We have our placeholder, and our onChange handler works. So that's it. The most complicated thing that differs between a class and a functional component is really just doing the destructuring off of the actual argument itself, rather than doing it off of this.props inside of the component. But you'll notice in the card, we did it like so. We can theoretically also go one step deeper, which is an even further version of destructuring like so. If you want to do this, instead of doing the destructuring within the code, You'll notice that if we do this, our code still works. But personally, I think this is a little bit harder to read. I would personally just prefer to say, okay, we've destructured off this specific parameter, and then further destructuring happens within the functional component. But this is really preference. But there you have it. We've converted all of our class components over to functional components. And if you're a little confused about functional components, don't worry. We'll get a lot of practice using functional components and hooks throughout this course, and definitely throughout the Capstone project. But for now, I just really want you to think about the core lessons we had on functional components, rendering and re-rendering, as well as class components and re-rendering and rendering with lifecycle methods. This is going to be probably some of the most challenging parts of understanding React. But other than that, React is generally pretty simple once you have those concepts down. In the next few videos, we're going to dive even deeper into how React actually works under the hood in order to help us determine what it's going to render and re-render and why it does it the way it does. So join me in the next video and we'll get a really good understanding of how React and React DOM works under the hood. Hello everyone and welcome back. In this video, we are going to discuss briefly React 18, which has launched since the creation of this course. React 18 brings a couple minor changes to us, and I'll discuss some of those changes later on when they become more important for us to learn. But primarily, a couple of the big ones that we do need to know right now is the changes that got made to React DOM inside of React 18. Now, React 18 is an upgrade to both the core React package as well as the React DOM package, so we need to update both those packages inside of our application. So here inside of Monsters-Rolodex, let's walk through how you would upgrade to React 18. First, what I'm going to do is I'm going to say yarn upgrade React and React DOM, and I want to do these both to the latest version. So I'm going to say -- latest. If you don't do -- latest, what it's going to do is it's going to take the seminal version, which for us is 17, and update to the latest version of 17. Instead, though, we want the latest overall major package update. So by adding -- latest, this will now update us and hopefully upgrade us to version 18 and the latest version that is stable that the React team has launched for React and React DOM. So let's wait for this to load and we'll see how this upgrade happens. So now that we've finished loading, what we see is that we've updated our direct dependencies, React DOM and React, to versions 18. So there we go. We're updated to latest version 18. Let's talk about some of these changes inside of our actual library and how they impact the way we work. So first of all, what I want to do is I want to actually go into the index.js file. Index.js, the main changes that happened is that now React DOM is no longer exporting render directly. And the way that we render out our initial application so that it is aligned with the way that we actually replace the root ID element on the page with our whole application, this is now different. So this is a little bit of a change that we have to get used to. And the way that we become familiar with it is that the first thing we need to understand is that we are no longer importing the React DOM library as a whole from React DOM. Instead, we are going to import in create root from React DOM/client. So React DOM client is a client-side library that we want. So I'm just going to comment this out so that we understand what these changes will be. Once we have create root, the first thing we do is we're going to instantiate this container variable. And this is going to be essentially document.getElement by ID of the root. So this is pretty much what we're doing before, where we found the actual element with the ID of root on the page, and then we rendered our application in place of where this is. So in the current newer version of React DOM 18, we don't do that the exact same way, but conceptually it's going to be the same. But here in this container, we're pretty much just capturing that same element with the ID of root, but we're just setting it to some variable container. Once we do that, we need to now instantiate our root, which is where we call create root, and we pass it the container. So all we're doing here is we're just saying, hey, I want to make some root variable, which is equal to creating the root off of this document object. Now we just call root.render. And then inside of this render, we're going to place our application. So what we had before was react.strict mode with the app. So we actually want all of this, not just the application, but also the strict mode. So let's just get rid of that. And this is what the new updated version looks like. So the primary difference, as you can see, is primarily now that React DOM creates this new root object class. And this is what we use to render into our application. But it itself is based off of some element, as we always get, with some ID of root. So here, not much of this is all that different from a high level. It's really just the way that the code is implemented now is slightly different. And that's really all it is. So as far as our concerns are with this new upgrade to React 18, this is the major change that we have to make inside of our application as far as updating index.js goes. So if you have an application and you've updated to React 18, you need to make sure that wherever you are actually replacing document get element by ID of this root element with the actual application, now you have to switch over to this create root method. And you have to remember that you're importing in create root from React DOM/client. So let's save this. Let's make sure that we run yarn start, and let's just make sure that everything is still working. So here we are inside of our application. We see we have no warnings, and we also see that our code still works. So that's our upgrade. And now that our code works, we want to discuss some of the other nuanced changes that comes with React 18. So let's talk about that in the next video. I'll see you there. Welcome back, everyone. In this video, we are going to continue talking about the changes that comes with React 18. So when you look inside of your application, in index.js, remember that we're using react.strict mode. React.strict mode is a way that enforces that we don't use any deprecated methods or methods that are going to get deprecated from React. We're following generally React best practices because any application code that is React-based housed inside of this strict mode container is going to be subject to some warnings that we'll see in the console log. Additionally, what React 18 has introduced is that it is no longer suppressing the fact that it actually double renders your components in order to try and catch any weird behaviors that might occur. What this means is that if inside of our app component, we add in our console log and we just say render. If I show you this, before we go back, I just want to walk through a couple things. The most important thing is I'm going to walk through just what happens whenever we type inside of our search box. As we know with React and rendering, our components re-render every time a set function gets called from our use state hooks. So inside of our onSearch change, whenever we type a letter, we call our onSearch change handler. This calls set search field. So that means that we get one re-render from this set search field call. So this means that this set call will trigger one re-render. So we should see this console log once. What happens then is that we have this use effect that is listening on search field changes. And when this changes, it will modify and filter the monsters array, and then it will call set filtered monsters. So that's a second render call. So that means that for every letter we type, we should see two different re-renders, so two different console logs. So let's go back to our application. Let's get rid of this first. And let's type one character from what we understand. We type E, we expect 2, but we see 4. We type again, we expected 2, but we see 4 more. So we're seeing double the amount of console logs than we normally would want. Now, the reason why this is happening is because, as I mentioned, React strict mode is double rendering everything so that it can catch any weird behaviors that might occur in your side effects inside of your functional components. We can actually make sure to see which ones are these additional calls or which ones are the ones that are coming from us, because this is really confusing. For us, we might look at this and be like, wow, our code is super not optimized. There might be something weird going on here. So what I want you to do is I want you to go and download these React developer tools, which is a Chrome extension for your Chrome browser that allows you to actually see what this is happening. So inside your resources folder, I've included the link and I want you to install that link into your Chrome. What I'm going to do, because I already have it, is I'm just going to make sure to enable it. And then back inside my application, when I refresh now, you'll notice that you see these grayed out characters. So these grayed out characters are the ones coming from React strict mode. So now if I type in E, I see 2 of them are coming from my app.js. 2 of them are coming from this weird different text file. The main thing is that is actually the strict mode, but they're grayed out. As you can see, it's a different color. So now our code behaves much closer to what we're expecting. So this is one of the big changes that comes with React 18. Due to community desire, because there is a double render happening in the strict mode, it may impact your performance in a way in development that seems a little weirder. So the React team has decided, just download the dev tools. And what we're going to do is we're not going to suppress any of those console logs that come in from strict mode, double rendering all of our components. And now we can see that, okay, we have these ghost renders. We just need to ignore them because that's just strict mode. But our code is behaving as we expect. Now, as far as we're concerned, these are the major implications that impact our current project and any code we write with React 18. So if you have installed your application and it's running React 18, these will be the different changes you will notice throughout the application. We'll of course talk about some of the more relevant ones as we go throughout the course, but for now, this is all we need to know. So with that, let's move on with the course. Welcome back, everyone. So in the last few videos, I keep talking about rendering and re-rendering with React and how React does it and why React is doing it the way it's doing it. But we haven't really talked about what it is about re-rendering with React that makes React such a good solution. So let's dive deep into this in this lesson. So inside of our application, if I open up our inspect, and instead what we want to do is look at our elements. What I want you to see is that inside of here, we have our HTML layout. What this represents is actually a tree of elements, or a DOM tree. So the DOM tree is essentially our document object model, and primarily what it encapsulates is all of the different elements that compose our application or website. It's represented as a tree because inside of these different elements, right now, as you can see, we're sitting inside of our component app. This app is reflected as a div with the class app, and inside are 3 children. There is the H1 class, there is our search box input, and then there is our card list. These 3 elements are actually siblings to each other because they all live at the same level. Inside of card list, though, this is actually apparent to all of the inside different containers. And then inside these card containers, of course, are images, which are therefore then children of the card. All of these are representable as a tree. You can see it as if siblings are branches on the same level, and then children of these different components are further branches down. So let's take a look at a visual representation of this, and what I want you to do is really think about what we've talked about. There's a top level app, inside being H1, search box, and then the card list, and then in the card list are the different cards, because this is what we're going to reflect as a tree. So here I've drawn out a diagram that reflects this DOM tree that we've been talking about. Right here at the top, you can see that this is representing the app component, which is that big div with the class name app. Inside of it, there are 3 children, which are 3 different siblings of each other. We have the H1, we have the search box, and we have the card list component. Inside of the card list, we have the children, which are the cards. I know we have about 10 different cards from our JSON placeholder, which represents the 10 different users that we have. But here I'm just going to show the 5 to make it easier for us to visualize. But this pretty much reflects a real DOM. This is a tree representation of our entire application right now. The thing about the real DOM is that it's actually really expensive in order to make changes. What I mean by make changes is something known as reflow. And what that is essentially if you were to remove nodes or pieces of the DOM, or if you were to update pieces of the DOM, it's very computationally expensive in order to make those changes. It's actually really quick in order to figure out if things need to be changed, but the actual changing process, the process of pulling things off the DOM or putting things on the DOM or changing things on the DOM, that's pretty expensive. So we don't want to needlessly do that if we don't have to. What React does is that in this case, React makes a duplicate copy of the real DOM, but it does it in JavaScript. So this is a DOM tree, but instead of using the real DOM elements, it reflects all of these elements in JavaScript. JavaScript is significantly quicker to actually create and reflect these changes. So that process where I was saying called reflow, that's like really easy to do in JavaScript. The only thing is that we need a real DOM to actually display to the user. So of course we can't use a JavaScript tree in order to do that, but we can use this tree to determine what's changed. And this tree is called the virtual DOM. So you hear a lot about a virtual DOM. That's what it is. It's a JavaScript representation of the real DOM tree. Whenever we were to make some changes, so let's say, for example, a user started typing into our search box, LEA. As we know, what happens is that we will start filtering through our monsters in our application in order to pass those filtered monsters to our card list component. So what does that look like using these virtual DOM and real DOM trees? So let's talk about how React under the hood is going to trigger through this process that we've done numerous times already in order to actually make the changes we want to see in the real DOM. So first what's going to happen is it's actually going to make another copy of the virtual DOM. And the reason why it does this is because it's going to use that first copy of the virtual DOM as a snapshot. So this is the latest snapshot of what the real DOM looks like before it needs to start actually making these changes. What React is going to do is use this newest virtual DOM copy as the actual DOM tree that it's going to make these changes against. So remember, what's happening is we're typing into our search box LEA. So as we remember, this search box is triggering an event for each character being typed in, the L and then the E and then the A. These changes are in turn going to call setState inside of our app, which is represented as that blue node up at the very top. If you remember, I said that that top node is our app component. Inside of here, React says, oh, I'm getting setState called 3 different times. What's happening is that React is actually going to batch these calls together if they're slow enough or if they're fast enough. It really differs. React has a bunch of different optimizations that it does under the hood by batching some of these calls together in order to make this process more efficient. Because even though it's in JavaScript, it still wants to be as optimal as possible and reduce the total number of changes it has to do. So what's happening here either way is that the LEA string is getting called into our setState. So this is what's happening. React is saying, oh, I want to set the state of this node. And remember, whenever state is being updated, it is re-rendering. So what this does is it's going to re-render the app. And React is smart enough to say, oh, I'm going to re-render all of the HTML and the JSX that are the children of this component. But it's also going to be smart enough to know that the only components that need to be updated is the card list, because the H1 is not changing and the search box is not changing. So the card list needs to update because why? What we're doing with that LEA string is we're modifying that monsters array. We're filtering it, which in turn means that we're passing new props into the card list. And remember, whenever new props get passed, React is also going to re-render that component. So card list says, oh, I've got new props. I need to re-render. So what it's going to do is it's going to look inside of its HTML and it's going to render new cards. Maybe in these new cards, there are lesser cards, which we know with our users is exactly what's happening because we're filtering out all cards of monsters that don't have LEA in the name. So React sees, oh, there are these 3 cards that no longer are necessary because they are no longer matching the filtered monsters that I'm receiving. So React is going to say, okay, these need to be removed. I'm going to literally remove them from my virtual DOM tree. So I've grayed them out, meaning that they've been unmounted. Remember, unmounting is that phase where you're pulling things off of the DOM. That's literally what's happening. So they're getting removed from the page or this virtual DOM representation of the page. Now what React does is it sees, okay, have I updated everything from these changes? Yes, I have. This is the new virtual DOM. So this reflects what the DOM should be after all these changes have happened. What it's then going to do is it's going to compare this virtual DOM copy against the virtual DOM snapshot. And it's going to highlight where things are different. Once it figures out where those differences are, it's going to actually make those changes onto the real DOM, because that virtual DOM snapshot is a copy of the real DOM. And because what it needs to do in the end, in order for the user to actually see these final changes, is apply those changes to the real DOM, now it knows what it has to do. It's already gone through the most complicated process of doing the diffing and doing the batching, so that this final process, React thinks, is the optimal and fastest final solution of what the current page should look like. So the real DOM is then going to go through the reflow, and it's going to remove those components or those different elements on the DOM tree. And now our real DOM is going to take the form of what it finally should be. And this is how we finally see those changes reflected on the page. So it's a pretty lengthy process, but that's really all the virtual DOM is doing. It's just an optimal way for React to figure out what the real DOM needs to look like. And the reason it does this is because pulling off and changing these different nodes on a real DOM is expensive. It's easier to do it in JavaScript and save when React is absolutely sure that what is finally supposed to be reflected onto the real DOM, it will then actually make those changes. That's the whole process of using the virtual DOM in React in order to optimize the process of figuring out what your DOM should look like. Welcome back, everyone. In this video, I'm going to break down what React and React DOM do for us as libraries, because so far we really used a lot of the syntactic sugar, meaning the much more easy way to write React using JSX. But in order for us to get a good idea of how the React and React DOM libraries actually work, I think it's easier if we just learn about both these libraries from scratch. So here, what you can do is you can watch me or you can follow along, whichever style you prefer to learn. Both are perfectly fine, because we're really just going to dive into some of the more top level API that React and React DOM provide for us that typically gets obfuscated when you're writing in JSX. So to start with, what I'm going to do is I'm going to go into my terminal and I'm just going to create a new directory called Pure React. And then I'm going to cd into it and I'm going to touch an index.html file. Touch essentially writes this file for us. So then I'm just going to open up my VS Code inside of this folder. I'm going to wait a little bit for everything to load, because sometimes when you open up your files, you might notice that it takes a little bit of time for VS Code to actually start indicating the things that it can do for you. But once you're inside, if you start typing HTML, you should see an auto suggestion. This, again, you might have to wait a little bit for your VS Code to start running up and all of these services to become available. But the moment it does, I want you to select HTML5. And what this will do is it'll write for us a quick template of what the base HTML file should look like. Inside of the body, I'm going to create a div, and this div, I'm going to give an ID of root. This is pretty much the exact same index.html file that we had inside of our Create React app, minus a couple of the optimizations that they create for us. But the key thing that I want you to focus on is the fact that there is a div with the ID root. Remember, before, what React was doing was we were taking our application and we were replacing this div with the ID root with our entire application. So we're still going to do the same thing. We're just not going to do it JSX anymore. Now, I'm also going to write some code inside of the div so that I know that when my React code mounts, I'm going to actually be aware that React is working. And we'll talk about how that works. But first, let's just type in React is not rendered. This way, it's very clear to me when React is rendered versus it's not rendered. Right now, this is just a raw HTML file, and we'll do everything in raw JavaScript. But once you've done this, you're going to go into your code, and you're just going to open up index.html inside of your browser. Inside the browser, you will see React is not rendered. So here, everything is working as we expect. The next thing we need to do is actually bring in both the React and React DOM libraries. Now you might be wondering, what is the difference between React and React DOM, and why do I need both? Well, you can kind of see the React library as the engine. React does a lot of the diffing, a lot of the optimizations, a lot of determining what to render and how, whereas React DOM determines what we're trying to render to. Specifically, React DOM renders to the DOM. So really what you're building is DOM elements. React Native allows you to build native elements. There might be React VR. Essentially, there's different ways that you might be building specific UI for some device or some platform. React DOM is the one that we use for the browser, but multiple of these different libraries all leverage the React engine code under the hood. So that's the difference between React and React DOM, and we're going to need both. So what I want you to do is go into your resources folder, and you're going to see this URL. This points you directly to the source code of React. This website called Unpackage is a great place that hosts all the actual source code for a lot of these different libraries that we use. So I'm going to copy down this, go back into my application, and then I'm going to write a script tag where the source points to React. Next, I'm going to do the exact same thing for the React DOM library. So here I'm going to get this script started. I'm going to come over. And what you're going to do is you are going to copy now the React DOM script that I have for you inside your resources folder as well. And you just add that to your source and save. Once you save, go back to the index.html document we had, open up your console, and also refresh. Once you refresh, you now actually have both the React and React DOM libraries loaded. Inside your console, if you start typing React, you'll see right there that you'll get something, which is the entire package that React has added under the React namespace. Similarly, you'll have React DOM as well. So now we know both React and React DOM libraries have been added, but they haven't done any code yet because we haven't written any of the code that we need to. So now what we need to do is we need to simulate the behavior that we had before with React. And to do this, what we're going to do is we're going to write a third script. This new script is going to be the way that we actually render our JavaScript code that utilizes React and React DOM. So to start, what I'm going to do is I am actually going to define the app component. And if we remember, components in React are just functions that return a set of UI instructions that React uses to render HTML. In our particular case, those set of instructions before we were writing in JSX. But now we can actually do this a different way. So what I'm going to do is declare this const app, and inside of this app, I want to return back React creating elements. And the way you do this is you use react.createElement. JSX is really just a fancy way that React adds syntactic sugar for all this code that we're going to write now using createElement. And React createElement, this method takes 3 arguments. The first argument is going to take the component that you want to render. So you can either pass it a string or you can pass it a component, meaning it could be a functional component or a class component. We'll figure out more once we actually understand how to use these components, but for now, let's just pass it a string. And as far as the string goes, all I want to write is a div. So by passing the string div, React knows, oh, you want to create a div. The second argument is an object where the key value pairs contain the different attributes we want for this. So class, ID, or any other additional properties that we want to add all would go into this specific object. This is kind of like props. You can see it like that. The third argument is going to be what children do we want to nest inside of it. And typically we pass this as an array. You can pass this also as a text node, which we're going to do for the next child that we add in here. Because right now it's just an empty div. And inside what I want to do is I want to pass in a string. And I'm going to pass that string inside of an h1. So how do I do that? Well, I need to make a new h1. And you might have guessed it that we need to use react.createElement again in order to create the h1. So I'm going to call it h1. I'm going to pass it a class, and here you can use class or class name. Both are viable. I'm going to pass it specifically, though, a class, and I'm going to say that the class is title. So the reason why in here you can pass it class and not class name, as we saw with JSX, is because inside of this is a key. So React is not treating this as a variable. Remember, when you write your keys, these React is going to interpret as a string anyways. So this is actually not protected as long as you use it as a class in your object. You can use class, you can use class name. React will render both over into class. So once I have my class, I am also going to now pass it a text. And here I'm going to say React is rendered. And what I'll do is I will save this. And now we have our app component. But this is not enough to actually render this onto the page. As we know before with React, React does that code where it takes your app and it actually renders it onto the DOM. And it targets this root component. So we have to write the code that will do that. And the code that will do that is I'm going to say React DOM.render, and then I'm going to say React.createElement because I want to create a new element that I'm trying to render to the page. And here I'm going to use my app component. So you actually just directly pass the variable name of your component. So in our particular case, it's const app. So I'm going to pass app through. And that's all I need. I don't need any attributes. I don't need any children in it. I just want to create this app component element. Then render needs a target. So it needs an element on the page that it can render to. This is where you're going to say document.getElementById, the same way that we had it before. And I'm going to target the ID of root. Now I'm going to save this. I'm going to go back to my code and look at that. React is rendered. For a second there, you saw there was a flash, React is not rendered, and then React is rendered. The reason that's happening is because our scripts are waiting to get loaded in first, and then our React code that we wrote finally runs, which is why you see that flash for a second. This is now us being certain that our React code is working. And this is really all it is that React really does for us. If you really think about it, React with JSX is really just using React.createElement in place of the JSX code that we have. But it's significantly easier for us to write JSX, which looks like HTML and absorbs and takes in JavaScript variables, rather than constantly writing this verbose create element where you define what we're looking for, then the attributes, and then the children. But that's really all it's doing under the hood. It's really that simple. In the next video, we're going to take a look at a more specific example where we write a bit more of this pure React code so that we can really see and utilize React.createElement in order to build out some kind of functionality that looks more similar to the app that we had before. You can actually try it yourself first, play around with this library and really learn it. And in the next video, we'll do a quick little experiment where we'll see how far we can push it. So I'll see you in the next video. Welcome back, everyone. In the last video, we learned about how React and React DOM work as base libraries. In this video, we're going to push it a little further before we move on to actually building our application back in the world of beautiful JSX. But here I just really want you to become familiar with what React as a library works so that you understand what JSX is doing compared to what you would have to do if you didn't have JSX. So as we saw, we've initialized our app component. And I typically want to actually make components that are a little bit more interesting. So let's keep this H1. Let's say underneath, we wanted to create a few elements that were a little bit more complicated. So what I'm actually going to do is I'm going to create a new component and I'm going to call it person. This person component is a functional component. So here, React is smart enough to say, oh, you're still passing me functional components. It's going to behave the exact same. Remember, create element really just replaces JSX. Everything else about our components is still the same. So what I'm going to do is I'm still going to write a functional component that gets props as an object. And instead, I'm just going to return back what I want for this person. And let's say that we know for sure we need a parent level container. So I'm going to use a div. So I'm going to say React.createElement, and it's going to be a div. And I'm not going to pass it any attributes in this particular case. And inside, I want it to have children. And these children that I want, I'm going to say React.createElement again. The first child should be an H1. And the value inside should be props.name. So So again, no attributes, but the children inside is just the text node, which is the string. Strings automatically get converted to text nodes, which is really what you see when you look at strings that aren't wrapped in like a paragraph or inside of a span. Whenever you see those are text nodes. So I'm saying props.name because I know it'll be a string. And then underneath that, let's just say that for this person, it's both a name that we're going to pass, but also a set another string. Let's say occupation. So I'm going to say react.createElement here. And this one, I want to be in a paragraph text. Again, no more attributes. I'm just going to say props.occupation. And with this, we have our person component. So what I want to do now is I want to, let's say, create more. So I'm going to do react.createElement. And here I'm going to pass it the person. Again, remember, the attributes are the props. That's how you pass props into this component. So here we know that we want to give it a name. So the first one, let's say it's Yihua. As for the occupation, I am an instructor. And then inside, I want to pass no children. So you can pass null, or you don't have to pass anything, but I'm just going to pass null, so we're really explicit about it. Next, let's make two more. So here, I'm also going to do Andre, and he is a lead instructor. And he's also going to have no children. And then finally, let's just say there's Emily, and her occupation is a teacher. And now, if we save our application, and we go back, and we refresh, we see that we have our three instructors, or our three people. And here we really saw a little bit more of a verbose example of how we've created two different components, both our app component and our person component, and how we can leverage React to actually put these elements on the page. With this, you've pretty much just seen what it is that JSX does. JSX just simplifies this entire process, but we're still writing functional components. Everything else about these components is the exact same. It's really just the fact that with JSX, it looks a lot more like readable HTML as far as dictating what UI we want to render. Reading React.createElement, this is a lot more difficult on our eyes as developers in order to actually write this code. But it's really simple. It's pretty much just what kind of component are you trying to make? What are the attributes / props you want to give me? And then what are the children inside? That's it. That's really all it's doing under the hood. In fact, in order to make this easier, what we can do is we can actually copy all of this code. And what we can do is create another file called app.js. And inside our app.js, we can just paste this code that we have. And then what we can do is we can just leverage this code inside of our script tag. So here, I'm going to save it all, get rid of this. And then this script source is just going to point to the code inside of our relative folder. So I'm going to go /app.js. And now if I save and I look back and I refresh, my code still works. This is really just a very bare bones, none of the benefits that we get from utilizing Webpack that helps build our code. We just wrote all of our code in right now in raw HTML and raw JavaScript. But really, with all these tooling that Create React App gives us, and with JSX and all of these bells and whistles, it just makes it so it's a lot more of a pleasant developer experience in order for us to write our React code. But I really just want to peel back away. What is JSX? What is React doing? What is React DOM doing? So that you have a better understanding of how these libraries function, so that when you're actually writing your React code, you have a solid foundation to stand on. But now that we understand what React and React DOM do for us as libraries, it's much easier now moving forward for us to just leverage JSX to write our code. So hopefully you understand what we just went through with React and React DOM. So let's move on with building our application. Welcome back, everyone. So in the last video, we learned about how React DOM works and React without any of the JSX and extra bells and whistles that we're used to with our actual React development. We learned about using the React libraries create element method, as well as how we can actually use React DOM to render this onto the page. In this example, I'm just going to show you how React 18 can be modified in order to make this code continue to work. As we see inside of our index.html, we are already calling React 18. And inside of the application code, you'll notice that you see the warning that React DOM.render is not supported in React 18 and that we should use create root instead. So in a previous video, we learned how to do that. But in this video, we'll understand how to do this inside of our actual basic JavaScript file. So as we said before, we need to replicate this method that we had before with this React DOM render, but now using the new create root. So first, of course, we need to get the container, which is just us calling our document.getElementById off the root. So it's really just whatever we were doing here. We're just now setting it to some constant called container. And we do this because we instantiate a root using the new React DOM method .createRoot. And we're just going to pass it the container. So up until this point, nothing is that different from what we did before. The key thing now is that when we call root.render, now what we did before was that we could just pass in the actual JSX of our application code. But here we don't have access to JSX. And as we've learned, we need to run react.createElement, which is really what JSX does. It just turns react.createElement into easier to read syntactic sugar that looks like HTML. So instead now, if we just call root.render React create element, and we save this, we get rid of our old React DOM code. If we come back now and we refresh, we see that our code works and we've gotten rid of that warning. So that's really just a quick highlight I wanted to make about how you would make these changes with React 18 inside of our lesson. From a high level, the lesson was really not about how this React 18 change impacts what you need to understand about React and React DOM. I'm just showing you what JSX does under the hood when it comes to simplifying what the React and React DOM library are doing for us. And that's it. That's all I wanted to mention. Let's move on with our lesson.
Welcome back, everyone. In this video, I want to show you all those things that we were talking about when it came to the actual DOM making updates. I mentioned how the virtual DOM is going to do some comparisons between a snapshot virtual DOM and an updating virtual DOM. And what it does is it modifies the actual DOM once it determines the correct things to re-render. So we can actually visualize this with a tool inside of Chrome DevTools. And I want to take a quick moment to show it to you. Here, in order for us to see this, what I'm going to do is make one quick modification where I'm going to bring in a title and a set title. And we're really just setting it up like this so that we can have more examples where we can visualize what's actually happening. So here, I'm going to duplicate our search box. I'm going to add a line break into our component just so that we can see these two search boxes separated from each other. And instead of an on search change, I'm just going to copy this and call this on title change, because that's exactly what we're modifying. So we're really just duplicating the behavior of our search change handler with a title change handler. And the whole idea here is just that we want to set the title. And the reason why we want to set this title, so I'm going to put that there. Let's call this our title search box. So again, the reason why we're trying to set our title is because we want to visualize some of these changes, because we only want to modify certain parts of the page. And here you're going to see that. So let's just save this. Again, we've modified our title, so now we have this title. If we go back to the code, we see that we have this set title, and we see that we have no title. So as we start typing, you'll see this title appear. And again, our previous search bar functionality still works. What I do want you to notice about this is that inside of here, if we go to more tools, you want to click rendering. And what this will do is open up this screen where we can enable paint flashing. Paint is a terminology that is used by the DOM to determine what is actually being rendered or re-rendered onto the DOM itself. So when the DOM mounts nodes, modifies nodes, or takes node off, that is all repainting. So that process that we mentioned that is expensive for the DOM, that is the painting process. So here, what happens when we check this is that whenever components are being modified, you'll notice that they flash green. So whenever the DOM has to make any changes, repainting onto the DOM itself, then that node or that component or that element is going to flash green. So notice how when I refresh the page, we see all of it flash green. The reason for that is because everything is being mounted onto the page or painted onto the page for the very first time. So of course, all of those different things are going to flash green. Now, if I start typing into this title, I want you to notice something, that the first time I type, this entire page flashes green, but every subsequent character only modifies the actual title itself. Why is this? The reason for this is because of reflow. Remember when I mentioned that the DOM needs to reflow whenever a component gets added onto the site? It's not just exclusive to adding. As long as the layout needs to be shifted, in this particular case, when this H1 is empty, it has no height, even though the H1, you'll notice, is still actually on the website. The thing, though, is that it takes up no height right now. But the moment it starts taking up height, what happens is that it needs to shift the entire page down because there is now a new element that is taking up space on the DOM. So that is reflow. Generally speaking, this reflow process is not that expensive. So it's okay if you see a lot of this green flashing from this. Really, what you just want to notice is there are certain things that you want to work within an expected behavior. So if components are being added or removed from the page, you should expect reflow of the entire page. Another example is, let's say I start modifying search monsters here. As we type, you'll notice that as the cards get removed from the page, we're also reflowing the entire document. So this is also okay. You'll see this pattern pretty much everywhere in React applications. I just don't want you to be too surprised when you start seeing these big flashes everywhere. But the key thing to really notice, though, is just the fact that when components are being mounted and unmounted, there is this reflow going on, which is essentially a paint process. However, if everything is on the page and things are just being modified, well, again, you'll notice that React will make sure to only modify the portions that are relevant. And that's what's really great about this paint flashing tool, because we can really visualize the way that React determines how a component re-renders and which components re-render, and then in turn, which reflective nodes on the DOM tree to repaint. It's really just that step-by-step process that React goes through, helping us build out our UI. So hopefully, whenever you want to see what your components are re-rendering and what is being repainted, you can just remember, you want to go into your developer tools, you want to click these three dots, go to more tools, click on the rendering, and then enable paint flashing, and you'll see what gets re-rendered. So now that we have gone through and understood how the virtual DOM works, let's move on. Welcome back, everyone. So now that we're moving into our big Capstone project, I have actually set up a repository just for you. This repository contains all of the code that we are going to write. I've also set it up in such a way that it should be relatively easy for you to work with. Primarily, I want you to code with this repository, and the way I want you to use it is more as a reference. So as you go through the lesson, you're probably going to follow all of the steps just like mine. So inside of your own laptop, on your own terminal, you're going to instantiate your own project, and you're going to follow along and code along as you do. However, if at any point you feel like you want a direct copy of my code, what you can do is you can clone down this repository simply by hitting code and then clone, and this will just bring your repository down into your terminal. So let's just take an example. I'm going to come down here to clone, and I'm going to do most likely HTTPS because it's the most simple one. And what I'll do is I'll just do, say, git clone and then type in the repository. And here, this is going to clone down the project, and I can just cd into it, and I have the code. However, one of the things that you may have to do that's different from mine is that you most likely
will need this repository on your own GitHub. So for your own GitHub, it's going to be a little different because you cannot make changes and push that code into my repository. The reason being, you do not own this repository. I own this repository. If you want a copy of this repository that you own, you need to fork this repository. So when you hit fork up here in the right corner, it will say, oh, let me fork this project into your own account. So I've set up a temporary account here just to show you what happens. And now here you see you have directly forked down this code. So once you fork down this code, you can actually clone this specific repository down into your code base. So earlier, if you look, you'll notice that I had cloned this. And this is my copy, my repository, not the one that I just forked over. So what I'm going to do is I'm just going to remove this one so that we don't have that name. And now if I clone down this repository, actually, let me copy this again. If I clone down this new forked repository, now this is tied to the version that is forked to my profile. So in this particular case, this would be your profile. And now you can make push changes to it because you own this copy. Now, one important thing I want you to pay attention to is these branches here in the top left corner. By default, this project sets you at lesson 1. But throughout the project, you'll see that there are numerous branches, and these are all different checkpoints for the code. But what I want you to notice is this main branch. Main is pretty much the branch that has the latest version of your code, or in this particular case, my code that I've written for this project. Main is also going to be very important because this is pretty much our production branch, which means any code in main is supposed to have the code that we want to be displayed live. So if we were to deploy this code base, we are often deploying it from the main branch. So the reason why this main branch is important is because in most typical projects that you work on in companies, the main branch is the one that is considered your production branch, and that's where you're going to be merging changes into it. But of course, because we're the only person working on this code base, we're not going to really care about that and the merge strategies as much. But the reason I mention is just because typically all of your final code should be on the main branch. So let's talk about these other branches though. We know that main branch is the one that should have all of the actual code we want to be our final code. But let's say, for example, what happens is that you are working on your own code base, let's say not off this fork. And what happens as you're working on it is you make a mistake of some kind. Let's say for some reason you can't figure out why your code is just not running anymore, and you just want to get a specific version of the code base up to where we've done so that you can at least have a clean start moving forward. Let's say at that point, you check your resources folder and it says, hey, I'm on lesson 12. Well, if you look at the branch itself, you'll see all of the code. But what you can do is you forked and then clone this project down. You actually have access to all of these branches. So you can just say, hey, git checkout me to lesson 12. And now this will have all of the code that you have up until this video, which is referencing lesson 12. What you can do is you can code from lesson 12 this branch directly, or what I suggest you do is you branch off from this lesson 12 branch. And what that does is it creates for you your own branch that you can write code against without impacting or affecting all of these lesson branches. So if you were to say check out -b, so I want to say, hey, git, I want you to make a new branch for me, and I want you to use lesson 12 as the basis. Just by doing this from lesson 12, you're going to say, okay, create a new branch from lesson 12. I want to call it my main, for example. You can name it whatever you want. I just called it my-main, just so that it's clear that this is my code. Here, this code base now is the same as lesson 12. So whatever changes you make are going to be made to my main instead of being made to lesson 12. And when you get to certain sections inside of our code or inside of the course where we wanted to make a deployment, you can now deploy from your own my main branch as long as you've pushed this branch up
onto GitHub in your forked repo so that GitHub actually knows that this branch exists. Because right now, all of this is being done on our local computer. So a lot of this has to do with just very basic Git strategy. But now you have your own branch based on the code of a branch inside of my code base that you will see referenced throughout this Capstone video course. And this is pretty much it. If it ever gets a little confusing, you can always check the README section down here where I walk through all these steps, particularly down in the branching strategy, which will cover everything that we talk about. So that's it. Now that you know about how you can leverage this repository for your benefit, fork it, clone it, and then work off of that using this branching strategy that we've discussed. And with that, let's get started with building out our project. I'll see you in the next video.
Ladies and gentlemen, we've come to an important crossroad in our path to becoming a great React developer. You see, we have two options here. The first option is we can keep going. We can keep learning React syntax, small little tricks, and pretty much learn the entire documentation, which is right over here. So that, like a dictionary, we understand every single thing about React, every single tool in the library. But here's the thing. You can do that on your own. You don't need me to tell you what the documentation says. And as a developer, you should learn how to read the documentation. However, I do understand that sometimes it's nice to have somebody show you how things work, how maybe something that isn't clear online is explained. So we're going to take a different strategy than most courses here. And I've talked about this before. What we're going to do is we're going to try and simulate a real work environment. What does that mean? Well, moving forward, we're going to start off building our e-commerce website. We're going to build a full-out online clothing shop. From start all the way to finish where we put it online. It's going to allow us to do a ton of things. But what we want to mimic here is how in a real life scenario, you would most likely be working with somebody, perhaps a senior developer. So along the way, I'm going to ask you to code along, have your code side by side next to the videos as we work through the project together. And as we build the project, we're going to encounter different problems, different things that perhaps we haven't learned yet in React. And slowly, we're going to learn these things as we build the project. Because we could spend the next 20 hours just building 5 more useless projects that aren't impressive because they're things that you can do in a day. What impresses employers and what gives you actual work experience is building these large projects from start to finish. So we're going to choose this path. So if you feel like, hey, I feel like I only know maybe 40% of React, then that's okay, because we have a long way to go. I hope that you stick around, because by the end of this course, that 40% of knowledge is going to grow. And we're going to try and build something from scratch so that at the end of the day, you don't just learn a list of tools, but you learn how to lead projects, how to explain to people how React works, how to decide on good architecture. It's time to get started.
This is our final e-commerce project. We're going to have navigation and routing that takes us to different pages of categories of items. And from these items, we're actually going to be able to add them to our cart. And from our cart, we're actually going to see these things directly update. And from this cart, we're going to be able to check out, increase or decrease these items again, and see the live changes in both our checkout page and our cart page, remove items, and actually integrate with a Stripe API so that we can handle payments. Now, this is actually going to be a test version of Stripe because we don't actually have items to ship and we don't actually want to process real payments because this is just a portfolio project. But the matter of switching it is simply a change in the actual Stripe website. You're going to actually learn what it is to actually build using the Stripe API. And beyond that, we're also going to integrate with Firebase to handle our authentication and our storage. So with Firebase, we're actually going to be able to authorize our users using Google so that we can sign in with our Google accounts. And once we sign in, we're also going to provide a sign out feature and a sign up and sign in with email and password feature. So it's going to be a really fleshed out, fully complete e-commerce platform, just like you would build for a real e-commerce company.
Welcome back, everyone. So let's get started with building out Crwn-Clothing. To begin with, we're going to scaffold out and set up our project using Create React App, which you really should be using 90% of the time. The only time where you don't want that is when you really want the customizability that comes with Webpack when you actually want to scaffold a project from scratch. Most of the time, though, you're not going to want that because you'll have to do a lot of those optimizations yourself. And Create React App is literally a team that's dedicated to figuring that out from tons and tons of different large enterprise projects that are pushing React's boundaries. Generally speaking as well, when it comes to setting up your own custom Webpack or setting up a custom Babel, you can pretty much just eject those files and still get the benefit of a lot of the default scaffolding setup that you get with Create React App as well. So generally speaking, I would say most of the time, always use Create React App to set up your projects. And to do that again, we're just going to run npx, which is just this helper that brings down the library and then installs our project and then gets rid of Create React App so it doesn't take up more memory than it needs to. So you're going to do npx create react app and then the name of your project, which I'm going to name mine Crwn-Clothing. You can name yours whatever you want. You may or may not get this prompt that's going to ask you if you want to install Create React App locally. Just say yes, and then you just wait for this to finish. Okay, so everything is installed now. And what we're going to do is just cd into our project. And let's open it up so that we can get rid of some of the files that have been generated for us that we don't need. So as we saw before, we'll get generated this app.js. And primarily what we don't want is we don't want everything here inside of our app. Most of this is not really necessary for us. Perhaps we'll keep the div, but let's just make our own div for now. And inside of this div, let's just also say hello world. So at least we know our application is running. Oh, sorry. This auto tag closer is doing a lot of funky stuff right now. As a result, we also don't need the logo. We also don't need the CSS. Really, we just need our app. And I'm going to change this over to a arrow function, just because I'm much more familiar with ES6. And this is it. This is all we need our app to be for now. Inside of app CSS, we don't really need any of this either. And for the remainder of our project, we're primarily going to write actually in a variation of CSS known as Sass, which is stylish or sassy CSS. And it's just an easier, more composable way of writing your CSS. In fact, once we learn that Sass writing style of CSS, we're going to migrate over to a JavaScript CSS library. But we'll discuss all of that later. Right now, don't worry too much about it. We can keep the index CSS. We can also change it later. For now, we can keep it. There's not much significance to it. And then finally, inside of index.js here, we have everything that we need. We can keep all this. Everything here is good. Primarily speaking now, our project is pretty much set up. So now let's just save everything and start up our application just to make sure that everything is working as expected. In the terminal, I'm going to run yarn start. This might take a little bit of time to boot up depending on your computer. And automatically it should take you to localhost 3000. Here we see our hello world, so we know our application is working as we expect. What we want to do now is we want to start setting up the basic outline of our application. So I kind of want to generate these 5 different category cards per se, let's call it that. So let's think about what this component might look like. We know that there will be an outer container that is going to hold these 5 different cards. And in each of these cards themselves, we have what looks to be another container. So this could be another div. Inside of this, there's an image. There is yet another container. And then inside is 2 different text fields. So let's just build that. So coming back to our application, instead, I'm going to generate one outer div. And just so that we can be clear for ourselves, let's also add class names on these that tell us what these different components are. So let's start with class name on this outer div. And I'll call this the categories container, because that's pretty much what this is. And then inside, we have these 5 different divs. So I'm going to create one placeholder for now. And this one, I'm going to call it the category container, because that's really what it is. It contains all the content in our category. Inside, we have an image. And for now, this doesn't have a source. So let's actually comment it out just to use it as a placeholder so we know that there is an image eventually. And then within this image, there is yet another container that is going to hold the 2 titles that we have. So this one, I want to call this the category body container. And then inside of here, let's say there's an H2 with hats as one of the texts. And then there is also a paragraph tag. And this one will say shop now. So we know that there are 5 of these. So let's copy this and just paste this 5 different times. And now that we've pasted this in, let's see what we have. We have hats, jackets, sneakers, women's, and men's. So let's say hats, jackets, sneakers, women's, and men's. Let's save this. And let's go back to our application and see what we have. Let's refresh. And there we see it. We have our hats, we have our jackets, we have our sneakers, we have our women's, and we have our men's. So this kind of gives us our layout. We haven't applied any styling to this yet, which we will do in the next video. But you can see how it's pretty much just the exact same way we were starting with our Monsters-Rolodex. At this point, really, that's all it is. You're going to start your project arguably the same way you start any project. You just want to start working from the outside in. But now that we have our project set up, let's start actually styling this and installing in the next video a tool that will help us write easier CSS. I'll see you in the next lesson. Welcome back, everyone. In the last video, we set up some of the base structure for our application. In this video, we are going to expand upon that and actually transform this to look closer to what we have in our final product. We're just going to build upon some of those concepts that we learned in Monsters-Rolodex in order to actually flesh this out before, again, we start componentizing even just this directory. To begin with, what we want to do is just apply some basic styling while also abstracting out the work that we need to do. So, as we can see here, notice how essentially all of these components are duplicated 5 times. We hard-coded this at first because it was the easier thing to do. But as we scale, this definitely doesn't make sense. Essentially, we're repeating the same code here where these values, where it's pretty much just the H2s, are the only places where it's essentially different. Maybe the image is different, but we haven't even tackled that yet. But we can already tell that this value is going to be repeated just using a different value. So this is a good place for us to actually start optimizing a little bit. So instead of hard coding out these 4 other sections, what we can do is we can actually initialize some variable array. And I want to call this thing the directories or the categories. And this is going to be an array that contains objects that reflect what it is that we have in here. So to begin with, let's just start with 1. Let's just figure out the shape of what it is that we want to display. We know for sure that we have a title value. This title is going to be hats because that's essentially what we're going to display first, just the hat. And then we know that there is also a subtitle. And the subtitle here is shop now. But let's think about this. Every single one of our different categories is also going to say shop now. So technically, you don't actually need to pass this. This value can actually be hard-coded. So you actually don't even need a subtitle because you know that Shop Now is going to be present in every single one of your categories. So that's a good way to determine what values you need in your object versus which ones you don't. I'm also going to initialize an ID just so that it's more clear. And let me just start using these categories here. So we know that inside of our categories container, we're going to map over the categories. So remember, wrap it in your squiggly brackets, then say categories.map, and you're going to pass it a function where you get the category. And then what you're going to do is you are now going to copy this through. So actually, let's do a single line return of our JSX here. And inside, let's make sure to use this title value. So instead of taking category, let's just destructure this off completely. And then inside of here, we'll just render title. So far, what we're doing is we're just setting up our code so it's easy to add these objects into our categories and then have React, of course, reflectively generate multiple divs. So let's save this and just make sure it's working for just our one object so far, which is our hats. And we see that it's working. Now, if we were to duplicate this, let's say the 5 times, 2, 3, 4, and 5. Let's remember what we had. We had hats, jackets, sneakers, women's, and men's. Let's save this. Let's go back to our application. And we see, just like that, we've replicated this behavior very quickly, very easily. So just to recap, what we did is we took and went from our hard-coded JSX over to a more dynamic and reusable version of our JSX. And this is going to reflect our category component that we're eventually going to use. But before we start migrating out into a components folder and doing all of that code, let's just make sure that everything we want here in one file makes sense. This is a good way to practice writing your React because it gets complicated once you start navigating and making multiple files. When you're working in the beginning, just do it all in one file when you're getting used to the way that React is written and the way that the code works. Now, one of the great advantages is that we can now easily modify all of our components in one place. So let's say we wanted to actually use an image. And in our particular case with this background image, we can use a div, and I'll show you how the styling works for a background image. But as far as the idea goes, it's very easy to set this up because now we can just apply it in one place and all 5 components will reflect this change. So this is one of the main advantages of writing our code in React is that it becomes very simple. You essentially have data that becomes your UI. And all we need to do now is just apply what we want to call this. So let me say I call this background image just for now. It doesn't actually have an image because we haven't given it anything, nor have we told how it can be a background image. But as far as the idea goes, it's very easy to reflect this across all of our different HTML components, the 5 different categories that are now reflective here. So now that we understand the setup of how to convert our data in JavaScript into our JSX UI, we can now actually start styling this component, which we'll do in the next video. We're going to learn about Sass, we're going to learn about how to add that into React, and we're going to learn about how to actually start making this look the way we want it to in our final result. So let's do that in our next video. Welcome back, everyone. In this video, we are going to tackle learning how to write Sass rather than CSS. Sass is really just a much more efficient way of writing CSS, and let me break down how it works. So first, we need to actually load in the ability for our application to consume Sass files. In order to do that, we need to go back to our application inside of our terminal, and we're just going to run yarn add Sass. Luckily for us, Create React App, by default, when you include the Sass library, will set your application in such a way that it will be able to render Sass styling. We're going to break down much later how you can do that yourself with Webpack, because it's really what it's done, is that it's set up these configurations within the underlying Webpack so that you can actually leverage Sass files inside of your application. So now that we have it fully installed, we are going to go back to our application. And now what I can do is I can make a new file. So for now, I'm just going to call it, let's actually call it categories.styles.scss. So SCSS is the Sass file type. Once you have this in, what is Sass versus regular CSS? So in order for this to work, let's look at an example. Here we have a div, and this class name is categories container. If I had styling for categories container, here, let's say, for example, I wanted to make the background color red. If I wanted now to target specifically the category container inside of categories container, the way that I would do that in regular CSS is I would say, first, give me the categories container class element. Then go in and target the category container. And then inside of there, I could do something where I set the background color to green. This way, now, I'm essentially saying, hey, I have styling for categories container, and anything nested within, I want you to target it, knowing that my CSS essentially is going to target it like so. Go into categories container, and then get the category container, and then apply the styling. If we went even another step in and tried to target the category body container within this, I would have to go even further. Categories container, category container, and then category body container. And here I would do a background color of blue, let's say. So just to show you, let's just actually import in this styling file that we just made, category styles.scss. If we save this, and now we go back to our application, we see our styling. It might be actually a little bit difficult because we don't have enough, I guess, like padding so that we can see it. So let's just make this more clear. Let's do padding like this. Let's just add a padding value so that we can see everything that we've just written. So if we save this, we go back. There. We see that the red on the outside is the container. We see the green on the inside is the inside target. And then, of course, this body container is the blue. So this is how you would normally write your CSS. Sass, however, makes this much easier. Instead of writing all this nesting, unduplicated styling like this, it actually allows you to directly nest these values within the inferred parent. So here, categories container, I can just write my category container code like this. So category container knows, oh, I'm nested inside categories container. You want to target category container within this specific parent class. So only give me the styling if this class is literally a child of this class, which is what the previous code we had written was doing. Similarly, if you want the same thing here, you would move this inside of here. So now it knows that only apply the styling to this category body container if this is a child of category container, and if category container is also a child of categories container. So now if I save this, again, we refresh, we see our code still works. Everything here still works. This is really the great advantage of Sass. It makes our CSS code much more legible and a lot easier to write. It's way more intuitive when you're reading it, and it's really self-contained. And Sass is pretty much the format of CSS that we're going to write for the rest of the course. So now that you have your Sass and you understand the differences between Sass and CSS, unfortunately, again, this is not a CSS-heavy course, so we are really just going to import in all of our CSS that I have pre-written for you, or all of the Sass, I should say. So inside of your resources folder, I want you to copy the Sass code in the Sass file and paste it in here. So do that now. So once you've pasted it all in, I'm just going to quickly go over the structure. I'm not going to really go over a lot of the CSS itself because there's a lot of CSS, and going through all of the different variations is really going to take up way too much time, and we really want to focus on the React, not necessarily the CSS. But primarily the main thing I want you to notice is that I did not nest the category container class within the categories container. The reason for this is because we know that the category container is going to be its own component. Typically, when we saw this with our Monsters-Rolodex, if we're mapping through this, we're most likely going to use this as its own component. One quick thing that we didn't do that we want to make sure we do is leverage the ID and append that onto this as the key. Because as we remember, whenever we map through things, we want to use the ID. So that's just one quick thing. But other than that, all of our Sass code is now in. So let's just save this and let's go back to our application and let's refresh. We should see this warning go away, which we do. But here we now see this looks much closer to what we have in our final product. So now that we have this different styling, what we want to do next is we want to actually append the background image. So let's do that in the next video. Welcome back, everyone. So in this video, let's actually learn a little bit more about some styling facts within React. And also, let's add the image. So what I want you to do is go into your resource folder, get the categories JSON file. Inside is just an array of JSON, and I want you to paste that in place of your current categories array. All that really changes is that you'll notice now we have this image URL field, and it points to a special place where I'm hosting all of the images that we need for our respective different categories. So once you have this in, I want you to also destructure off the image URL because we're going to leverage this and it's a string. What I want you to know is that when you are trying to append, let's say, some additional CSS that's dynamic, you can actually do that in React by passing it as a style object. So on any different component in your JSX, you can actually append custom styles by giving it this style field. This style field takes an object where the key is the CSS property that you want to modify. So in our particular case, I want background image. So with background image, the value that we need to pass it is going to be string of URL, and in the brackets is the actual URL string value. So here I'm going to use object destructuring. So I want to use the backticks. And with the object destructuring, I'm going to pass in image URL. If you're unfamiliar with destructuring, all this is really doing is it's just allowing us to use a string variable inside of another string. And this, essentially what will happen is that we will apply a custom style onto this specific HTML element. So if we save this now, and we go back to the application, we'll see that now we have our images loading in. And that's pretty much it. As far as why it's all working stylistically, of course, it's because I've already pre-written the styles for you, so keep that in mind. But just really focus on the fact that all we really did, if we now inspect this image, is we now have appended this style property. And inside, as you remember, you can actually do this in any HTML element. You can pass it as a string. But for us, with React allows us to pass it a JavaScript object, and it will convert it all for us, both from camel case, which is how we should write it inside of the JSON object, over to the kebab case, which is how it actually gets interpreted when you're writing raw HTML. So that's the great thing about React as well, is that it will essentially handle all of this for us. So now that we have all of this code working, what we want to do now is really just start moving what is in its appropriate one file to its own separate component. So what we know is that we are really just using a category item here. So what we can do is go and create our components folder. And just like we did before, I want to make another folder where we have our category item. Category item is going to be a component, so it needs both a component.jsx file and it also needs a style file. So category-item.styles.scss. So here, let's just go into our style file. Let's cut out all of the styling that we had and let's paste it into category item category.styles.sass. Inside of category item, let's import in our style file. Let's initialize our category item as a functional component. And let's just remember to export by default out the category item. As far as what we're going to receive, we are probably going to receive the entire object as a prop. So here we can do, let's call it a category. And that'll be the namespace that we do. And in turn, we just want to return all of that HTML that we had from before. So let's just close these folders. Let's go here. Let's copy this HTML that we've been using. Let's paste this in here. And now we remember that we cannot use the ID here. We need to put it in the place where we actually call the map. So we'll remember to do that when we go back to our app.js. But we know that we need the image URL. So here we can destructure here, or we can destructure directly in the actual prop. It's entirely up to you, whatever you prefer. We need the image URL and we need the title. So here we've pretty much converted this over into its own component. Let's save this. Let's go back to our app.js. Let's import in the component that we need from our components folder in our category item and our category item.component. Let's copy the category item. Let's paste this in. And now we know that we need to actually pass the entire category. So here we can do key is equal to category.id and category is equal to category. And now if we save and let's go back to our application, we see that everything is still working as we expect it to. Awesome. So everything's still working and we've pretty much started separating out our different components. What I want you to do is I want you to actually even move this component, which is the entire categories, into its own component. So you can make this category menu, you can call it directory, call it whatever you want, but essentially it should not all live within our app.js. And you also want to move the style that we had here for this categories. So you can move this also into your own component. That's my challenge to you. So do that, and then in the next video, we'll do it together. Welcome back, everyone. So let's now move the remainder of what we had inside of our app.js into its own component. Inside of the components folder, when we think about what we want to name this, you want to kind of pick a name that really captures what this feature will be. For us, because this feature is not being reused yet, we don't need to overly optimize what the definition of this component really is right now. We know at least it's our directory menu. So I'm just going to call it directory. And inside, I'm going to call it directory.component.jsx. And I'm just going to move over this code. So I'm going to say const directory is equal to a functional component that returns back this div. We know that off the props, we're going to get categories. And then we also know that we're going to export default directory. We see that we're missing category item. So let's go to app.js and let's scroll up and take this category item because we no longer need it in app.js anymore since we're now putting it up into directory. So here we just need to make sure that our relative import is correct. So from here, we go up one. And right now, we go from directory up to the components folder and then into category item, and the remainder stays the same. So here's our directory. Now, what we also need is the styling for this directory, because if you remember, we have a bit of styling in our categories.css. So let's make a new file called directory.styles.sass. And inside, let's just copy over our categories container. You can call this categories as well, just to match the styling. For me, I'm going to make this a little bit more clear. I'm going to say directory container, and I'm going to modify the styling inside of directory component here, this class name, so that it's more clear as well. You can easily make these changes on the fly. As you write your code, honestly, sometimes you might feel like your naming of a component makes more sense as you start writing it out. It's perfectly fine to change these class names and all this stuff when you're in this phase where you're building out a feature. As you start to work with other teams, sometimes you may want to talk about this with your teammates to make sure that everyone understands and agrees that these component names do capture what it is that you're writing. Because one key thing to think about when it comes to variable names, you are writing code for people. Yes, the computer interprets it, but it's developers, human people that are reading this code. So you need to be writing these function names and these component names in a way that is intuitive for people. What's intuitive for some may not be intuitive for others. So feel free to rename this whatever you want as well. Whatever makes sense to you about what we're building, you can definitely try and name it that way. That's the beautiful thing. I want you to try and see. That's honestly sometimes the best way for you to know whether or not something makes sense or not. So let's go back to our app.js, and now let's import in our directory. So we need to go up to our components, into our directory folder, grab directory, component file, and we'll just replace this whole section here with our directory, and we're going to pass in categories is equal to categories. And now let's save this code. Let's go check. This was our hat image, but let's check our application. Let's refresh. Oh, we didn't actually resolve the category style, so we didn't remove that code right here. We no longer have category styles because we deleted it. And in our directory, we also did not import it. There. We just imported our directory styles file that we moved our styles into our directory component. And then app.js, we removed the reference to that category styles file that we removed. And now if we go back, we have one more. Cannot resolve category item component inside of our directory component. So let's go back here. Let's see what mistake we made here. Here we see. Inside, we've gone up from our directory folder to our components folder. We went into the category item folder, and then we went and tried to find another category item folder. So this is duplicated. So everyone makes mistakes. You're going to make a bunch of typos, and you're going to make a bunch of errors when you're coding. Always, whenever that happens, take a breath and just really focus on where do you think the error is coming from. We had the stack trace, which is what we saw when we saw that error message in our browser that told us where our error was. And then it's just a matter of process of elimination. What are the files that we changed? Where could we most likely expect to see these errors from the stack trace? And then it's just a matter of going back through all the possible cases. And most of the time, honestly, 90% of the time, a lot of our errors are going to be typos. And now here we come back. We see that everything is exactly how it was before. So that's it. We've moved out and made these major components now. And now we can start building out the rest of our application and thinking about what else to build. But before we proceed, what I want you to do is I want you to go back to your terminal. And now is actually a great time for us to commit our code. So to commit your code is just to make a save of your code, because you really want to think about when you want to commit. Oftentimes you want to commit when you've done what feels like a contained block of work. And for us, we just built out our directory page, which is a great time to commit this work. So we're just going to say git add -a, git commit, and then our commit message will just say updating our directory page with directory component and category item component. And then you can just push this up. You can do git push. For me, because I'm using Z shell, which is my preferred. I have the shorthand GG push. This will push up, and there we go. Now, in the next video, join me while we build out the next major feature in our application. I'll see you in the next video. Welcome back, everyone. In this video, let's update the fonts throughout our application, and let's talk a little bit about some of the more nitty-gritty details regarding what it is that we're doing and how it is that we're building our application is going to actually convert into our final application. So it's going to get a little bit meta, but it'll be really valuable, at least regarding how you need to think about web applications on the browser itself. So here we're back on Google Fonts, and we need to download another font. We've gone through these steps already before, but I'm going to get a little bit more specific as to what exactly is happening when you include these fonts into your application. So here, let's pick a font that we like. Personally, I'm going to use Open Sans Condensed, because I think this one looks really modern, but you can really pick whatever font you want to use, and I'll show you how you can include it. So here, once you select the font you want, honestly, Google likes to change up their UI pretty consistently. So what you see here might not be what you see live right now. But essentially, there will be a way for you to add the font variation of the one you choose. So for me, there's Open Sans Condensed, but there's Light 300, Light 300 Italic, and Bold 700. Ignore these numbers. Essentially, what this means is that this is the regular, this is the italic version, and this is the bold version. Personally, I want just the regular version because I'm not really going to use the italic or the bold version in the application, but you can include them if you want to use them. Once you have that, you need to click this right button here that shows the different fonts that you've added. Because what's going to happen is that Google is going to generate this link for you that includes all of the different fonts that you want right here. So for example, let's say that I wanted also the italic and the bold. When I select these, you'll actually see this update. So here, notice how this has updated. It now includes the 700. Before it included also the 300 with the italicized, right? The ITAL, if you'll notice right here, ITAL. It's just including the variations of this Open Sans Condensed font that we're also going to download, because that's really what's happening here. Now, of course, I mentioned I don't want them, so I'm just going to get rid of them. But here I'm really showing you what is happening when you're generating these font links. Next, what we're going to do is just going to copy these links, and we're going to go back to our application code, and we're going to go into our index.html, and we are going to go into our head section and just paste it right here. And what's happening here is that essentially we're telling our application that when you load this application in the browser, I want you to download these things. In this particular case, what we're actually downloading is this font. So let's copy this href and just see what we are supposed to get back. So if we go back to our browser and we just paste this in, we see this. This is actually a font definition. But if you read it, it's CSS. Font family, font style, font weight, all of these are just definitions for specifically these fonts that we're trying to include and to be able to use them in CSS. So this is really how we're able to define these fonts into our application, because Google is giving us a CSS file that allows us to actually define what this Open Sans Condensed is. The source of the actual font is coming from this URL, which is what Google hosts to actually give you the font itself. What we're downloading when we include the link inside of our HTML is just the CSS rules that allow us to leverage these fonts. So that's an important thing to note. So that's the thing about this CSS rule that we're adding, or this CSS file. You'll even notice in the href it says CSS2. So that's an important thing. This is coming and giving us these font CSS files so that in turn we can leverage them in our code. How do we do that? Well, let's go into our index.css. Here, because we're writing Sass, let's actually convert this to index.sass, just for consistency. Inside of your index.sass, what I want you to do is I want you to actually remove all these different font families. You can keep them if you want. Really, it's just saying, I want you to try this font first. If that's not available, try this one. If that's not available, try this one. If that's not available, try this one. And it just keeps going until eventually it lands on one of these fonts that is applicable. For us, because I want my entire application to be in the open sans, I'm just going to do this. I'm going to remove all those ones I don't want. We can keep the base sans serif one, but I'm going to say open sans condensed. One more thing we need to do is update all references to index.css to index.sass. Whenever you update file types inside of your project, you need to make sure that you correspondingly update all references to those previous file types and switch them for the new one. So here in our index.js file, we know we're importing our previous index.css, so we need to update this so that it imports index.sass. Oftentimes you will see inside of your web application, if you visit it, it'll tell you that it can't find a certain file. Especially if that file is renamed, then you know that's why. It's because you've updated the name, but you have not updated all of the references to it. So beware of doing these types of changes and keep an eye open for it. Now that we have all of our code required to see if our font is loaded in, let's go back to our application. And here we can clearly see that our fonts are now up to date with all of our newest Open Sans condensed font. One other thing I want you to notice is if you open up your inspect and you look at these elements here, I want you to open up the head. Inside of the head, you will see these different 3 style tags, and inside of them is that CSS code that we wrote. So this is one thing I want you to understand about how Sass works. Sass, being a style of CSS or an extension of CSS, requires that Sass library that we installed, because what Create React App will do is that Create React App has actually created and leveraged this configuration so that it will take in the Sass that we've written and compile it down into CSS by the time it actually ends up in the browser. Because the browser cannot read Sass. The browser can only read CSS. But inside of here, you notice that all of this CSS code looks like the code we wrote, except it's using all of the typical CSS non-nested selector behavior. So that's the great thing about Create React App, is that instead of us having to set up our application so that it knows how to transform Sass into CSS, Sass will do that for itself due to Create React App's configuration for our Webpack. We'll talk a lot about Webpack later in the course, after we've already built our application and we want to understand how we can do essentially what it is that Create React App has done for us. But right now, I just wanted to highlight something interesting for you to see since we're talking about Sass and we're talking about our styling right now. If we go back to our application, one final thing I want to mention is that with Create React App, it also generated for us a package.log file. Because I'm using Yarn, I also have a yarn.log file. If you are not using Yarn and you are just using NPM, you would see only a package log file and not a Yarn log file. So what are these log files? These log files are essentially generated by our package managers, NPM or Yarn respectively, in order to determine for an application what version of all of these dependencies that we have inside are locked to in this project. The reason why you want this type of consistency is because these different versions might clash if you're using some specific version and then somebody else who is also coding against this library or this project, they might run different versions. So your code might not behave the same way between these two different developers. So the log file is a way for us to make sure that all of the libraries that we use as a team are locked to the same versions or at least compatible versions. And typically you only need one. So because for the remainder of my project, I'm going to use Yarn, I don't need package lock. Package lock is generated for us because Create React App by default uses NPM in order to scaffold and set up this project. But because I'm using Yarn, I'm just going to get rid of the package lock file. This is only important if you're also using Yarn. If you're not and you're using NPM, don't worry about it. But with this, we have pretty much cleaned up the majority of getting our initial project up and running. We have our fonts in, we have our directory set up. So now let's move on with our code base.